Yes, finally the 10 hours marathon is ready with quality content. Not only for showing off the 10 hours, this 10 hours is the quality content because Unify Study is providing you quality content. Was this 10 hours marathon must complete it before going to exam. And after watching this video, definitely you will get a good score in exam. And let me know in the comment section after coming back from the exam hall that yes, how much score you got, how much question you got from this video. And in this video, each and every line, each and every point will be important for you, and each and every points are dedicated for you. Everything are quality content. Don't miss it. Start watching. Click the bell icon to get all the latest notification and update, and must watch this video till the end. So here, be ready with your pen and paper so that you can take a notes for your quick revision, handwritten note you have to prepare. So first of all, I am coming to the graph theory. And here, when we are coming to the graph theory, here you can see the graph theory handshaking algorithm is a very important one. So handshaking algorithm is what? Total degree of a graph is always even. That is 2 into total age. 2 multiply into total number of edges is total degree of a graph. And the number of odd degree vertices is always even. This is the next one. So complement of a graph. What is the complement of a graph? If I am taking this is a complete graph. So this one is a part and maybe this one can be another part. So this is the graph and this is the complement of a graph. When we can make it together, that is a complete graph. So the number of edges in a graph plus the complement of a graph is making a complete graph. That's why the total degree will be always n into n minus 1 divided by 2. Why? Because in a complete graph, each and every vertices is connected with other n minus 1 vertices, right? So that's why the formula is coming n into n minus 1 by 2. Now here already this theorem I have discussed, that is 2 into g, and the total number of vertex, average vertex, what is the average degree of the vertex? That will be 2g divided by g, and this is the mean degree and this is the max degree. So odd degree is always even, and the k regular graph of n vertices has nk divided by 2 edges. So here some questions are coming, and that's why students are also getting confused always with kn and k regular graph. So kn is your complete graph and k regular graph means it is telling you that each and every vertices of k degree. Don't be confused with that, please. Complete means that n is telling you there is n number of vertices. So if I am writing K4, that is 4 vertices are there, and it will be complete then when each and every vertices will be connected with other n minus 1 vertices. And K regular means if this is a 2 regular graph, means when each and every vertices of degree 2, that is called the regular graph. That is the difference between the regular graph and the complete graph. Please remember that. And that's why in a k regular graph, there will be nk divided by 2 edges. If k greater than 2, then k regular bipartite graph has same number of vertices in each part. Next one, coming to the spanning tree. When the spanning tree cannot have a cycle, right? And we are going for a minimum spanning tree. So spanning tree is always minimally connected and maximally acyclic graph. And in a spanning tree, always n minus 1 edges should be there. And this is the stopping condition of the spanning tree also. If we remove e minus n plus 1 edges, means from a complete graph, if this is a complete graph, from this complete graph, if you remove e minus n plus 1 edge, e means e is the number of edges, n is the number of vertices, then you will get the spanning tree, right? Now in a complete graph, how many number of spanning trees possible? That is n into n minus 2 number of spanning tree is possible. When it is coming for the bipartite graph, if it is a bipartite graph KNM, this is a bipartite, complete bipartite graph, then how many spanning trees are possible? That will be n to the power m minus 1 and m to the power n minus 1. These are the very important formula, must remember that. Next formula is coming for the Dijkstra algorithm. In the Dijkstra algorithm, it is a single source shortest path algorithm. And the formula is coming, that is du plus wuv less than dv. So du means du is your source. From the source wuv, that is telling you the weight of the u to v. So when you see that the new one is less than the old one, then we will update the new one. That is dv equals to du plus wuv. This is also the next important formula from the Dijkstra shortest path algorithm. Now coming to the Euler path and Euler circuit and the Hamiltonian circuit. So Euler means what? That is each and every vertices should be of even degree. Then only it is the Euler circuit. Each and every vertices with even degree. And when there is no Euler circuit but Euler path is only there, then there should be exactly two vertices of odd degree. It is not satisfying even degree, that's why the circuit is not there, but path can be there when there is the exactly two vertices of odd degree. Now Hamiltonian. For the Hamiltonian also another formula is coming, that is total number of Hamiltonian cycle in a complete graph will be n minus 1 factorial divided by 2. This is also a very important formula. Here we are doing the revision of the quick important point. That's why I am not going for any detailed discussion. If you want the detailed discussion, then you have to go for the complete playlist. The graph theory complete playlist is there. I am giving the link also in the description and in the top bar, and you can check my playlist in this channel. Then definitely you will get it. Here we are doing only the quick revision of all the important points. That's why I am not going in detail. Next one is the Descartes theorem, Dirac's theorem is that G is a simple graph with n vertices with n greater or equals to 3, such that the degree of each vertices will be n by 2. That is the Dirac's theorem. Next one is the Orr's theorem. This is also very important. Degree u plus degree v will be greater or equals to n when the non-adjacent, that is u and v, are non-adjacent sets. But these theorems are the sufficient but not the necessary condition. Remember that this is sufficient but not the necessary condition. There are some exception also. What is the exception? Exception is that C5 is also the Hamiltonian circuit, but this is not satisfying this one. So Kn in Hamiltonian circuit, n greater or equals to 3. If n greater or equals to 3 in a complete one, then also it is satisfying, but this sometimes there are some exception. So remember the exception also. Next one is coming for the graph coloring. So in the graph coloring chromatic number. What is the chromatic number? Chromatic number is that minimum number of color required to do the vertex coloring. So here Kn equals to n. This is means number of vertices in a complete graph. If you are doing a complete graph, this is a complete graph. What will be the chromatic number? N will be the chromatic number, means how many colors are required? N number of colors are required. Now from the Weizsäck theorem, when it is coming for the edge coloring, how many colors are required? That is depending on the maximum degree. Just from all the vertices you have to see the maximum degree of the vertex. So the maximum degree will be your number of color required. This is also a very important formula. Question are coming from here. Either it can be delta or it can be delta plus 1. Delta is the maximum degree. So just think like that. If you draw this one, so in this one the maximum degree is 3. So try it. How many colors are required? It will be 3 only for the age coloring. Now next one is some graph with a bipartite graph. When it is the bipartite graph and the planar graph, then number of color will be always the maximum degree, because here you can see this is a bipartite graph, and here how many colors will be required? Maximum 3 colors will be required. For a multi-graph, it will be 3 delta divided by 2. Number of color may be as large as 3 delta divided by 2 for a multi-graph also. And according to the 4 color theorem, always when you are coloring a plane, the region, then number of color will be 4 color. Using 4 color, you can color the map. So these are the very important points of the graph coloring. Next one, coming to the set and relation. So in the set and relation, most important formulas are that in the set with n element, total number of possible relation will be 2 to the power 2n square, right? Now the number of reflexive relation will be 2n square minus n. Number of ordered pair of a largest and smallest equivalence relation will be n square and n. Largest will be n square and smallest will be n, equivalence. Total number of symmetric relation are coming from 2 to the power n into n plus 1 divided by 2. These formulas are very important. So many questions are coming from here repetitively. So remember this. Next, some formulas from the set theory. These are also very important formulas of set theory. At least the A union B is NU plus NB minus N intersection B. And here N union B, that these are the remaining formulas are also there for the set theory that you have to remember. So next one is what is reflexive, symmetric, antisymmetric and transitive. These are also very important. Just you have to remember, reflexive means for all A, B, B should be satisfied. Symmetric means when A, B is there, then B, A should be there. Antisymmetric means, what is antisymmetric? When A, B is there, then B, A should not be there. It is only satisfying the reflexive part, that is A, B, B, C, C. Transitive means when A, B and B, C is there, then A, C should be there. That is the transitive one. So what is called a equivalence? Equivalence means that is reflexive, symmetric and transitive. Poset means that is reflexive, antisymmetric and transitive. So set theory is done. Now we are coming to the number system and digital logic important formulas, and here that is the binary, octal, decimal and hexadecimal. What are the accepted range? These are the accepted range. Just go through it. And this is that binary format, octal format and hexadecimal format. Must remember, in the hexadecimal format, after the 10 it is coming from A, B, C, D, E, F. Now the next one, that is the different types of gates: OR gate, AND gate, XOR gate, NAND gate, NOR gate, XNOR gate. The tables, the truth tables also, just go through it and so that you never forgot. AND means that only one, then there is one. OR is when there is zero, both, then only zero. XOR when they are different, then they are only one. XNOR when they are same, then they are one. And NOR just opposite to NOT or. NAND means opposite to AND, NAND, not AND. Now these are the formulas, are always remember, always these are coming for our simplification. Whenever you are going to do the simplification, then these formulas are very important, right? Identity law, complement law, idempotent law, these formulas very, very, very important formulas. You have to go through it and remember these formulas. And these formulas are useful also for the propositional logic. Same way, just we are writing in different, means same formula we are writing in different way. So these are the logical equivalence formula. Next one is the mean term and the max term. Mean term, max term formula are coming from. Mean term means when 0, 0, 0, then we are writing X bar, Y bar, Z bar. In max term, sum product, we are writing X plus Y plus Z. So many students are doing mistake here, so please go through it and remember it. Don't do the mistake in your exam hall. Now the K-map. For the K-map, what you have to remember? 0, 1, 2, 3. More, don't forget, don't write here 2. That is, you have to 1 after that 2, then here is 3. And whenever you are writing 0, 0, 0, 0, 0, 1, 1, 0, then 1, 1. Here also 0, 0, 0, 1, 1, 0, then 1, 1. And here also after 6, 7, then 8 is coming directly here. 8, 9, 10, 11, 12, 13, 14, 15. So whenever you are filling the K-map, must remember this one. Next one is the important notes to remember for the encoder. When you are going for the encoder, an encoder have 2 to the power n input and n output lines. And a decoder have just opposite, that is n input lines and 2 to the power n output lines. A multiplexer have always even number, that is 2 to the power n number of input line. This input lines is depending on the select line, because in multiplexer there is different, that is the two, some select lines are there, some input lines are there and one output lines are there. Okay, many include to one output only, but the number of inputs is depending on the number of select line. If number of select line are n, then 2 to the power n number of input line will be there, but output will be always 1. And for a demultiplexer, it is just reverse. Now the flip-flop and flip-flop chart are also important. That is SR flip-flop, D flip-flop. When this is 0, 0 is no change, 1, 0 reset, 0, 1 reset, 1, 0 set, and 1, 1 that is forbidden. And D means only we are passing 0 and 1. That's why this 0, 0 and 1, 1 is not coming under D. Under D it is coming only 0, 1 and 1, 0. That will be either reset and set. And this forbidden set state is only change in JK flip-flop. In the JK flip-flop for the 1, 1 it is changing to toggle. That you have to remember. Other than that, others are same. And in the T flip-flop only same are coming. That is 0 and 1. 0, 0 and 1, 1 is working. These two are not working for the T. So this truth table you have to remember for the JK, SR, D. Now next one is all important formulas and table for the computer science, that is the computer organization. Here the byte, that is kilobyte 2 to the power 10, megabyte 2 to the power 20, gigabyte 2 to the power 30 and terabyte 2 to the power 40. Remember this one, very important. KB, MB, GB and TB. Next one is coming the formula for the average access time in a cache memory. Cache memory always numericals are coming from here. So heat rate, level 1 heat rate into level 1 access time, level 1 miss rate, then level 2 heat rate, then level 2 access time. Level 1 X heat rate, miss rate, level 2 is miss rate, then the memory access time. Because here there is CPU, after that it is coming to level 1. When it is available in level 1, it will fetch the data. If it is not available, then it will go to level 2. So it will search to level 1, it is not available, then it is going to level 2. That's why here level 1 miss rate, then level 2 heat rate. Some part will be there, that heat rate. After that the access time, then whatever not available, finally it is going to the main memory. That's why this formula is coming and you have to remember this formula. Next one is the formula for the TLB concept. It is related concept. So operating system TLB, how it is working. So CPU is searching for fast TLB. It is available in TLB, translation look aside buffer. If it is available, then it will get that, and this is giving you translation, that is logical address to physical address. If the physical address is available, it will go to the main memory and it will fetch the data. If it is not available, means it is miss, then it is going for the page table, it is searching it. After that, it is going for the main memory. That's why TLB search time, when there is heat in TLB search time plus main memory access time. When it is not available in TLB, then also you are searching in TLB. That's why TLB search time plus 2 into main memory access time. Why? Because page table is also storing in main memory. So one time for main memory, that is in page table, another time for the data. That's why 2 into main memory. Always remember in that way so that you will never forget. Next one coming from the pipeline. In the pipeline also it is coming that effective time for the type pipeline is k plus n minus 1 cycle. K is the number of segment and n is the number, and here k plus n minus 1, that is the total. And TP is the propagation time. And for the non-pipeline, that is normally it will be n into k into TP. Right? And the speed up ratio is coming from ET non-pipeline divided by ET pipeline. Here very important, don't do mistake here. The speed up is just here, it have to be n into k into TP divided by this one. And finally efficiency is S by K and throughput is N by K plus N minus 1 and to the power multiply into TP. These are the very important formula for the. If you want to get a good score, then you cannot leave programming. And to do programming, you need to go for conceptually, because this is the question pattern. But you can see this question asked on 2021 and this question asked in 2019. But the pattern of the question and actually the body of the question is same. You can see that while loop, everything is same. Just they change something here. Here they change here counter, but here they did directly return, and they change the option here. Just by changing the option, they frame the question repetitively. So this is a repeated pattern of this type of operation where you need to do the bitwise and shift operator. How to solve this type of question. That's why you need to watch the complete video and must subscribe to the channel. Click the bell icon to get this type of video in detail. After watching, let me know in the comment section what you are feeling. So see that here I will solve this question, and after that definitely you can solve this question by yourself. So see that how it will be going on. Before solving a question, what is the approach? You have to understand the approach of solving. Approach of solving the question is understand the question, means what is going on in each and every line. If each and every line is clear how the execution is going on, then it will be more easy to execute it. So here it is a normal function. Here the counter value is 0. Here is a while loop going on. This while loop is going on till this. And this while loop will be going on till positive number, means whenever you are getting 0, it will come out from here and this is sending a return. So what is going on in the while loop? It is going on in this while loop, that is counter equals to counter plus n and 1. This is called bitwise AND operation. Bitwise AND operation means you need to change this number in binary and 1 will be also binary. Now you have to do the bitwise AND operation, that is the logical AND operation. Means when these both are 1, then only you will get 1, otherwise it will be 0. And next line, what is going on in the next line? This is actually called the shift operator. And this is the shift right operator. How it is working? It is also working on binary operation. Like that, if I am taking a number 1000, it is what? This is 8. And it is right shift by 1 bit. This 1 means it is right shift 1 bit. Means I am shifting this bit here. This bit will be shifted here, this bit will be shifted here, this will be shifted here, and here will be 0 and this 0 will be discarded. So what is this number? Now this number is actually 0100, means it is actually 4. So what is going on? when we are doing right shift 1 bit, then any number will be divided by 2. And in this context, remember one thing, if I am doing left shift 1 bit, then the number will be multiplied by 2. Because next time your question will be multiplied means left shift operator also. So you will be confused. That's why remember it. Now see that what is going on here. So definitely in this line it will be n equals to n divided by 2. Now how to solve? Here this line, what is the meaning of this line? You can see here is double equals to. Means it is working as a if condition. Means if counter value equals to 1, then return true, that is 1, then it will return 1. Otherwise means else it will return false, that is 0. So here you can see in the option these are given 1 0 1 0, that's why. Now when I will get the counter value 1 and when I will get the counter value 0, that is actually our target. If I can understand when the counter value is 1 and when the counter value is 0, means your problem is solved. This is the thing what you need to do. Now we will solve it. How to solve it? For solving, take any value. First of all, you can see that what are given in option. In option it is given to power of 2, odd, even, or the binary representation, all are 1, or any 1 means any number 1. So I am taking a number that is 7. I am taking a number 7. So n equals to 7. If I send here, what will be happen here? So I have written this code, means this is the way of solving any program. That's why I want to show you how you can solve that. Go to a online compiler, search online compiler, write down the program and each and every line try to put the printf so that you can understand what is going on. Because this program I will explain. Every program you need someone to explain, it's not good. Rather than that, if you are doing it by yourself, then it will be more good. But I am explaining it. From the next time you can try. So see what will be going on here. I send here n equals to 7, right? So that's why you can see from the printf only, this is the output actually. Whatever output is showing of the program, that is given here. Now when I send the n equals to 7, what is the binary representation? Binary representation of 7 is 1 1 1, right? So here I am doing counter equals to counter plus. So counter value is what? Counter value is here, it is given, that is 0. You can see the counter value initially 0. So it will be 0 plus, I am doing the AND operation. N is 1 1 1 with 1, that is 0 0 1. So it will be what? 1 1 is 1, 1 0 0, it is 0, means it is 1. So you will get here 0 plus 1, that is 1. So now your counter is updated to 1. That's why in this line, whenever I have done the printf, you will get that counter equals to 1. For 7, you are getting counter equals to 1. Now you will do n equals to n by 2. N by 2 means what? 7 by 2. If you are dividing 7 divide by 2, it is 3. And here it is 6, and after that 1 will be remainder. As it is the integer, your answer will be 3. And that's why now n value is 3. Because it will be again going to this while loop. So while loop, again I am doing printing here. So next time n value is 3 now. So 3 means what? 3 means it is 0 1 1. Just we did the right shift. See that it is also right shift, because this 1 bit will be discarded. After that this 1 1, it will be 0. So 3. Whenever I am doing the operation 3 with 1 AND operation, so 0 0 1. Again what I will get? 1 0 0. I will get again 1. So last time counter value was 1. 1 plus 1. Now you will get 2. So now counter value you got here 2. Done. Now next time what will be the value? Again 2 will be divided by 2, that is 1. So 2 is divided by 2 means 1. n is 1 now. Now again the bitwise operation I have to do. So 0, 0, 1, that is 1. It will be AND operation with again 0, 0, 1. So you will get here 0, 0, 1 only. Last value of counter was 1. Right? Here we have updated with 1 plus 1 is 2. That was last value was 2. Now this will be 2 plus 1, that is 3. So that's why you got the counter value equals to 3. After that again last one, A1 will be divided by 2. Whenever we are doing 1 divided by 2 means it will be ultimately 0. Why? 2 is dividing by 1, this is 0. So here you will get remainder 1, but the answer will be 0. So means n is greater than 0. No, this is false. This is coming out from the loop. Whenever it is coming out from the loop, what is the counter value? Counter value is 3 now. Last value of counter is 3. And this condition, what is that condition? The condition is checking here, if counter value equals to 1, then it will give you 1, otherwise 0. So this condition will be false now because I got 3. So here whenever it is coming out, it is returning actually 0. So where it is written, I am getting return here because I call from here. So my return output is here 0. So I got output 0. Means from this program you can understand, when I put the input 7, then I got output 0. Right? So is it an odd number or even number? It is a odd number. Now you will think that for odd number then I am getting 0, means for even number I will get 1. No. Understand this very carefully. It will be not. Why? See that whenever I am taking another number, even number 12, I am telling you with 12. If I am getting 12, then actually you see 12 also 0. Then after that 6 will be 0. But counter is here, it is counter the 0. Next it is n equals to 3, then it will be 1. Then n equals to 1, that will be 2. Your output is 2. Why it is happening? Because see why it is happening. 12 means how to represent 12? 1, 2, 4, 8. So it is 1, 1, 0, 0. That is 12. So first time whenever you are doing AND operation with 1, this will be 0, 0, 0, 1. You will get here 1. 1, 0 is 0, 0, 0, 0. So that time counter value is 0. That's why for 12 counter value will be 0, because 0 plus 0 you will get 0. For 12 you will get 0. Next time you will get 6. So for 6 what will be done here? For 6 means 6 is what? 1, 1, 0, that is 6. 0, 0, 1. If you are multiplying it will be again 0. So that's why now again 0 plus 0 will be 0. For 6 also you got 0. Now for 3, whenever you are getting 3, 3 means what? 0, 0, 0, 1, 1. 0, 1, 1. That is 3. So it will be 0, 0, 1. If it is 3, 0, 0, 1 will be 1. Now 0, 0. Now you will get here 1. So now 1 will be added with 0. Now you are getting a 1. So that's why for 3 counter value will be 1 now. What happened here? Very carefully see that. Actually this 1 is shifted. How it is shifted? 1, 1, 0, 0. First time it is shifted like, but this is 0 will be discarded. 1, 1, 0. Next time this is shifted like 0, 1, 1. Next time it will be shifted like how? 0, 0, 1. Last it will be shifted like 0, 0, 0. You can see when I am getting this bit 1, last bits are 1, then actually the AND operation will give you 1. That's why for this 3 you got here 1. And again next time when you will get 1, for this 1 also you will get 0, 0, 1, 0, 0, 1, you will get here 0, 0, 1. And that's why last counter value was 1 plus 1, then you will get 2. So it is very clear. Actually how many 1 was there? There was 2 1. and whenever this is shifted to the last bit, ultimately it will be shift to the last bit. Whenever it is shifting to last bit, then counter value is increasing. Means ultimately it is depending on the number of 1. How many number of 1 is there, that is actually according to that only you are getting the counter value. See that? Is it or not? So there was 2 1, that's why you got the counter value 2. Now if I am doing here, so I got the answer, but I am explaining again what is going on here. For the 8 you got here 1. For the 11 you will get, if you are executing, you will get here counter 3, because 11 there will be 3 1. For 12 you got this number, and for 8 whenever we are doing 8, then you are getting again 1. Why? Because 8 will be 1 0 0 0. For 1 0 0 0 you will get 1. Ultimately, if you think very carefully, what will be going on? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Any number, whatever in 2 to the power, like if it is 1, then always your counter value will be 1. If this is 1, means it is the number 2, then also you will get counter value 1. If this is 1, means your number is 4, then also you will get counter 1. If your number is 8, then also your counter value will be 1. If the number is 16, then also your counter value is 1. Because ultimately this 1 will be shifted when here, then only you are doing the operation with AND operation, then only you will get 1. Otherwise every time you will get 0. Whatever number in 2 to the power, if you are doing half, 32 divided by 2, that will be 16, then 8, then 4, then 2, then 1. So whenever I am getting 1, then only this value will be 1. Then only counter value will be updated to 1, otherwise not. How it is? See that. 1 0 0 0. If I am doing the operation with 0 0 0 1, it will be 0 0 0 0. So for 8 you are getting 0. For 4, what will be 4? 1 0 0. If I am doing 0 0 1, then also I will get 0. So for 4 also I will get 0. Then 2 1 0, that is 2. If I am doing operation, that is also 0 for 2. Now for 1 0 1, whenever I am doing operation, then I will get 1. So here only I will get counter value as 1. Before that everything will be 0 if it is in 2 to the power. And that's why whenever it is coming out, then counter value will be 1. So your answer will be, when the number is in 2 to the power, means n of the power of 2, n is the power of 2, then only you will get 1, otherwise you will get 0. I hope you understand it. And that's why I am showing all the result. For 12 you will get here 2, for 11 you will get counter 3, for 8 you will get 1, and for 7 you will get 3. Means it's not depending on number of 1 or odd number, even number. Ultimately it is depending on 2 to the power, because number of 1, how many number of 1 are there, that is actually it is counting by the counter. I hope it is clear to you. And now you can solve this question. I hope so. It's very easy. Same thing is going on here in this while loop, and it is asking only the return B. Means in that question it was counter. What is the counter value? You are checking what is the counter value out of number of 0, number of bits, number of consecutive 1, and number of ones. Everyone can do the answer now. What we are getting the value? It is actually the counter value. What we are counting here? Yes. So here your answer will be number of 1, because every time we are counting, where you are getting always confused, right? Because your concepts are not getting clear. How the recursion is actually going on? What is recursion? And as you know, recursion is working on stack, but how it will work? I am giving you clear explanation, complete explanation from this question. You can see this question here. This is a long recursion going on. In this long recursion, what will be the output? This is the question. So please watch the video till the end and definitely subscribe to the channel. Click the bell icon to get this type of more videos where you will get complete easy explanation. And after watching the video, definitely let me know in the comment section how you are feeling. So let's come. Here, what is recursion? Recursion is a process of repeating item in self similar way. How it is repeating item? That is a problem here. How it will repeat the item? So that's why take this one. First of all, whenever we are doing, see that here this is calling with 5. If we'll call with 5. Okay. So I will call this with 5 first time. Then every time here it is doing return if n minus 3 plus n plus if n minus 2 plus n. Now see that. First time when we are calling, this will be little bit lengthy. Please keep your patience and please concentrate here. Please watch it completely. After watching, it is my guarantee your all concept will be clear, but you have to watch completely. See that whenever I am calling, so this function every time it will evaluate n minus 3 plus n plus f n minus 2 plus n. This function is executing every time when n is greater than 0. Otherwise, if n is less or equals to 0, means if n is coming either 0 or any negative number, then it is returning hyphen, right? Yes. Now how it will work? So for that, it is better to take a new page. Let me take some new pages so that I can discuss it clearly. Okay, just I am going to take some new pages and let me discuss it clearly. So here this function was working like this one. First of all, I am calling f5 and my function was like if n minus 3 plus n plus f n minus 2 plus n. Every time this is evaluating here. Okay. So when I am calling f5, how it will be? F n. N means what this is? N means here I have to take, means this will be not n, this will be here 5. 5 minus 3 I am taking. After that plus n is 5 plus f 5 minus 2 plus 5. Normally we are putting the value of n here, nothing else. Then it will try to evaluate this part, that is f5 minus 3 means what? f2. Now when it is calling f2 means there is a recursion. Now what it will do with this part? This part will be remaining, means it will be put in a stack, because here this is a return function, right? We are calling it recursively. F2 will be called, but this part is remaining. So this part it is putting in the stack. That is the main concept of recursion. Whenever you are calling any recursively any function, then the remaining part we have to put into the stack, so that when I will get the return, then this stack will be evaluated. So let's see how it is going. I will call with F2. I will evaluate F2. How to evaluate? From this one, that will be F, put the value of n, that is 2 minus 3 plus again 2 plus F 2 minus 2 plus 2. Just put the value of n here. That is going on because 2 is here when this function is calling, when n is greater than 0. If n is less or equals to 0, then return hyphen. It was returning hyphen. That was the question, right? Now what will be done? Here again it will be try to evaluate f minus 1, and this part is remaining in the stack. Again, this is not done because this is not evaluated. What will be the value of minus 1? F minus 1 will be return hyphen because of this condition. Here this condition will be satisfied here. F less or equals to 0? Yes, because n value is now minus 1. For minus 1 this is satisfying. So that's why returning hyphen, right? So here it will return a hyphen. Where it will return? Here it will return because it was calling from here, means I am returning hyphen. After that this 2 will be here. This is the 2, and don't be confused with this plus. All this plus will be work like a concatenation. It is working like a concatenation of string. It is a string concatenation. Okay, so here it is returning hyphen. After that this 2. Now again I have to evaluate this part. When I am evaluating this part, that is f2 minus 2 means f0. So when this is f0, again as it is less or equals to 0, it will return you again hyphen, right? Means where it is returning, it will return here. Again hyphen, and the remaining part was 2. That's why here is again 2. Right? I hope this is clear to everyone now. So what this is returning here, I am getting here finally hyphen 2 and hyphen 2. This is coming, right? So this is the return from where it is returning. This minus 2 and minus 2, it was calling from here, means here hyphen 2 hyphen 2. This is not minus, this is hyphen 2 hyphen. Okay. Now where it will return? It will return, this was calling from here, right? So that was hyphen 2 hyphen 2, and this 5 will come here, that is 5. Now it will try to evaluate this part. Now try to evaluate this part. When we are trying to evaluate this part, that was f 5 minus 2, means this is f3. Now again as it is f3, I will put here the value of n. f3 minus 3, then plus 3 plus f3 minus 2 plus 3. Just put the value of here, because this is always, when this is n greater than 0, always you will call this recursion, right? Now see, f3 minus 3 means what? That will be f0 plus 3 plus f3 minus 2 means f minus 1 plus 1, right? This is coming. Now when 5 minus 2 was 3, now f0 means what? It will return a hyphen, right? So when it is returning hyphen, after returning hyphen, this will be 3. Then again f minus 1, this will return a hyphen. So that's why again hyphen 3, right? Clear? Is it clear to everyone? I hope this is clear to you. Now when I am returning, so that hyphen 3, this was hyphen, then 3, then again hyphen, then 3. Now I am getting this one. From where I am getting this one? It was calling from here, and ultimate call was from here. Means this is concatenating here, that is minus 3, and finally again minus 3. Sorry, here we did a mistake. See that here it was, just let me take the eraser. Something we did mistake here, that is, it is not minus 1, it will be not minus, right? That mistake we did. Let me do the correction. The correction will be here. This will be 3 minus 2, that is 1, not minus 1, right? So when you are calling with 1, f1, how to call? f1 will again here, let me erase this part also, how this is calling. So here this one again f0. F0 is returning hyphen. That was okay. Hyphen then 3. That is here. But for f1, if we are trying to expand here the f1, what is coming in f1? F1 will be extended like this way again. That is, here we are expanding f1. Okay. Here f1 minus 3 plus again 1 plus f1 minus 2 plus again 1. Got it? Because you are putting this 1 with this n value every time, because definitely 1 is greater than 0. That's why. So here it will be f1 minus 3 means this is minus 2 plus 1 plus f1 minus 2 means that is minus 1 plus 1. Right. Now, as this is minus value, this will return hyphen, means here I will get hyphen, and for this one, that is 1. Again, here this is, I will get here also hyphen, means again hyphen, and this one, that is 1. Got it? As this is a negative number, I will get return hyphen. Again, this one will come here. Then again, this is a negative number, that's why I will get hyphen, and again this one will come here. So that's why here I will get hyphen 1 hyphen 1. From where I am getting? I was calling from here. Means with this hyphen 3 was there. Now with this hyphen 3 means I am writing here with this hyphen 3, it will be like hyphen 3 was already there, then hyphen 1 and this 3 was remaining, that 3. So this is coming here finally, that is finally it is coming hyphen 3 hyphen 1 hyphen 1 3. This hyphen 3 was already from here, that 3, and this hyphen 1 is coming from here, and this 3 was remaining, that 3 is coming from here. This is clear. Now from where this will return? It was falling from here, was falling here, and finally it was falling from here, right? It was falling from here. That's why it is now, what this will be, just see that, as here this was 2 5 was already there, right? Now what we are getting here, I am getting minus 3 from here, I mean hyphen 3, then hyphen 1, then hyphen 1 3, and finally this 5 is remaining, that is this 5. So finally your answer is coming like this. That is your final answer, that is hyphen 2 hyphen 2 5 hyphen 3 hyphen 1 hyphen 1 3 5. Got it? Hyphen 2. See that? Now try to check with the option where it was. Hyphen 2, it was here. Check it. Hyphen 2. Yes, there was hyphen 2. Then hyphen 2 5 hyphen 2 5, then hyphen 3 hyphen 3, then hyphen 1 hyphen 1, then hyphen 1 3 5, then this is hyphen 1 3 5. I hope this is clear to everyone now. That is called recursion. That's why your answer will be this. You are getting this answer. So again, do little bit revision. What is going on here? First of all, you are calling with F5. Whenever you are calling with F5, then you did it. This is expanding like 5. You are putting here 5, all the value n equals to 5. Here it was, right? And when you took this one, after that, when you take this one, n equals to 5, then we get the F2. we call F2. Then we put here n equals to 2, all the value from n equals to 2. Then we are expanding this one with 2. After expanding, when you are getting f minus 1, as it was minus, that's why it was returning hyphen. Got this return first of all. After getting this return, it was coming here. That is this hyphen. Then this 2 was remaining, it was coming this 2. And again this one was expanding. Here that was F0. F0 was expanded like this one, because again this will return hyphen, this hyphen was returning, and finally this hyphen was returning here, and this 2 was coming from here. So finally you got here hyphen 2 here and this hyphen 2 here, means that was your return here, hyphen 2 hyphen. This return was coming from here because it was calling. So I got here hyphen 2 hyphen 2. Then this part was remaining, this part was remaining, that was a return here, that F5, here it was returned. So hyphen 2, then this 5 was remaining, that 5 is concatenated here. Then we have started expanding this part, that is F5 minus 2. Here we have started expanding F5 minus 2. Then this is F3. When we are expanding F3, then again we are putting here n equals to 3. And finally here F3 and all these are there. Again this will be in the stack. And this is expanded F0. When we are expanding F0, there was this hyphen. This hyphen was coming. Now this hyphen was returning here, that is this hyphen, and this 3 was coming here, that is this 3. Now we are expanding this one, this part. When we are expanding this part, that is F1. We are expanding this F1 here, that is this F1 was expanding here, where n equals to 1. We put the value of n equals to 1. Here we are getting minus, that's why the hyphen, because it was minus, hyphen 1. Then again this is minus, that's why again we are getting here hyphen. So hyphen, then this one is here, and hyphen, then this one is here. That's why here we got hyphen 1, hyphen 1. That was coming from here. Was coming from here. That's why this hyphen 3, that is this hyphen 3. Then this hyphen 1, that is this hyphen 1, and this 3 was pending, that is this 3. So here we got the return hyphen 3 hyphen 1 3. So I am returning this here. I'm returning this here. This was calling from ultimately here. He was calling from ultimately here. Means I put here this hyphen 3 hyphen 1 3. And this 5 was remaining. This 5 is coming from here. Finally, you got the answer hyphen 2 hyphen 25 hyphen 3 hyphen 1 hyphen 135. This is the working mechanism of the recursion. Hope this is very clear to everyone. Please let me know in the comment section how you are feeling. Actually, recursion is going on in this way. This will be operating and this will be in the stack. Again, when you are getting return of this, then this will be again operating. As this is again recursion, this will again operate, then again it will calculate. So thank you for watching. Those who are watching till now, please explain you that how this program will print and how many happy will be printed in this program. That is the question here. How many happy will be printed? Now easily you can give the answer, that is 2 to the power n. Yes, this question is very easy. That's why easily you can give the answer. But if your concept is not clear how the fork is working, maybe because always question are not asking this direct question. They are asking the question in different way. And that's why I'm showing you another question also. I will provide you homework also. But try to understand the fork, how actually fork is working. How? Maybe you will give the answer yes, 2 to the power n, as there are 3 fork. So that's why there it will be 2 to the power 3, that is 8. But how the 8 is coming? So if you want to clear your concept, then watch this video till the end and definitely subscribe to the channel. Click the bell icon to get all the latest update and notification. So come to the concept now. Here first of all, how the fork is working, how the program is working. Program is going one by one. One program is starting with the int, and always remember fork is creating one parent and another child, right? Always every one fork there will be one parent and another child, and they are sharing one pointer only. Parent, child, everyone is sharing one pointer only. Means whenever the pointer is going down one by one, the fork program is also, the program is also going down. How it is? See that in the main first line is now the program counter is here. This is your program counter. So from here fork will create two child. Now how the two child will be created? As my program counter is here, so the remaining part, what is the remaining part? This is my remaining part. This remaining part will be printed. Where? Not printed, it will be created two child. How this is creating two child? Just it is taking this part, it will take this part, including the bracket also. That's why I'm taking the bracket also. So including the bracket, it is creating one child here and another child will be here. Same way two child is created now. Got it? Now see that what it is going on. So from here two child we have created. Now your program counter is where? Now in this program counter is here. Here also program counter. This is now your parent and this is now your child. Now here where it is coming? See that. Now the remaining part of the program is, this is the remaining part of the program. So that's why here it will create again two copy from this fork. So that's why it is creating this copy. It will take this copy here and this will be, it will create here one copy. It will create here another copy. It will create here one copy and it will create here another copy, right? So that's why now how this is created. From this one, and from this one, this two is created. There are other program. Now here it is, all the program counter is here. There are 4 program running. It is one program, this is another program, this is another program. 4 program running. Now whenever this fork is calling, again they will create two child. They are creating separate two child. Remaining part of the program they will be created. How? The remaining part of the program, this is the remaining part that will be created now. So here this print will come here. Again this print will come here. Again this print will come here. Again this print will come here. How many print will be there? See, actually the space is not there, so that's why I'm writing here. So how many actually there is, it will be some may be missing. So because of the space, this is 1 2 and here this is 1 and this is 2 and this is 1 and this is 2 and here this is 1 and this is another 2, right? So 1 2 3 4 5 6 7 8. Because of the space I am writing in this way. So this one is this 2 and this one is this 2, right? Means here also it will be print hello. Now all the program counter is here. All the program counter is here. Now they are printing in this all the program counter. Here also it is printing hello, not sorry, happy. This is not hello. So this will be happy. This is also printing 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 happy. Here also happy. Here also happy. Here also it is printing happy. And here also this is printing happy. So how many happy is printed here? 1, 2, 3, 4, 5, 6, 7, 8. In that way, 8 happy will be printed. So this is, it is statement 1 is telling P1 display happy 8. Yes, that is we have already done in our last video. But how many times this will be printed? It is given that it is printing 12 times. So is it correct or false? Pause the video, try to solve it. After that, try to come to the explanation. Yes. So this statement is wrong. Why it is wrong? If it is wrong, now how many times the happy will be printed? How to do it? What was the concept? The concept is that the main program is starting from the main. And when it is starting, then after that it is the program counter is coming here. Whenever the program counter will come, the remaining part of the program will be created 2 copy. Here it will create 2 copy for the remaining part of the program. Again, for this 2 copy, the program counter will execute. How it is? This is the way that already we have done for the first part. This was the first part, how the 8 is coming. This was the first part of 8, right? Now in the second part, how the second part is working, see that. The fork, this is the first fork. In the first fork, when it is coming, it is creating this part, right? So this part is creating 2 times, this one and this one. Now here, now program counter is coming to here. So whenever program counter is coming to here, now it is printing the happy. This is also printing the happy. That's why happy is printed. Now program counter is coming to here and here also in this location, because always fork is sharing the same program counter. Through the fork, when it is creating two, one parent and another child, both are sharing the same program counter, right? So that's why it is now in this program counter. Now it is a fork here. Here is also fork. So this fork will create the child here, the remaining part of the program. Here also the remaining part of the program. That's why the remaining part of the program is coming like this. That is printf, fork and printf. Here also printf, fork and printf. Here also and here also. Right? So total 4 copies created. From here there is 2 copy parent and child. From here also there is 2 copy parent and child. Now see. Now the program counter is here. For everyone the program counter is here. Printf, printf, printf. So as there is printf happy, it will print one happy. Printf happy, it will print another happy. Printf happy, it is printing another happy, and it is also printing another happy. Now the program counter is moving next. Here, now here, now it is here, and now it is here. So as the program counter is coming to this position, now what it will do? See that here is again the fork. So this fork, it will create 2 times. Means the remaining part, there is only one line remaining part. Printf happy. It will also be printf happy. Right? 2 times. This fork is also creating 2 times. This is printf. This is also printed. This fork is also created 2 times. This is also. And this fork is also creating 2 times. This is and this is. Now all the printf happy, it is printing happy. This is also 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 printing happy. This is printing happy, and this and this. Now total how many happies are there? In the last line, 1, 2, 3, 4, 5, 6, 7, 8. Here 9, 10, 11, 12, 13, 14. Total 14 happy will be printed from this program in this way. I hope now it is clear to you, right? So now I am going to the next program. So please comment in the comment section below that first part is clear or not. And that's why your answer will be statement 1 is correct. It is printing 8 times happy. The first part was this one. It is printing 8 times happy. Second part is printing 14 times happy. But second part is telling it will print 12 times happy. No, it will print 8 times happy. 14 times, right? So that's why it is wrong and your answer will be this one. Now come to the next part. So for the next question, some more concept is required. What is the more concept? That how fork is returning. Fork is returning 3 types of value. Here it is the theory. You can go to the theory. Fork is returning 3 types of value. One is negative value, another is positive value, another is 0. When negative value, when fork is unsuccessful, when it is unsuccessful means when it is unable to create any child, then it is returning negative value. When it is returning positive value it is returning for the newly means parent, because every fork there are 2 parts, one child and another one is parent, right? Parent is returning positive value and child is returning 0. Positive value means it is a parent. Parent will return positive. Now positive means what? Positive means it will be process ID. Whatever process ID, that will be returned. Okay. So it returns the parent in the caller. The value contains the process ID of newly created child. Is process ID of newly created child. And 0 that it is returning 0 for the child process. Whichever child process, that will be returned 0. Okay. And as you all know that they are sharing the same program counter. So this is the theory for the fork. You can write down this theory. You can take the screenshot. Now this is the program for you. This is the question number 2. Here you can see it is stdio.h and all. Now the int min. Now what it is going on, see that here it is fork and this is and then again fork, then there is fork, next there is printf hello, and next there is return. Now tell me how many times hello will be printed? What will be the answer? Please pause the video, try to solve it and let me know in the comment section how many times fork will be created. After that I am telling you that what will be the answer and how the answer is coming. But please try to do it by yourself. Pause it. Okay. Now come to the answer. Try to understand the question. So definitely program counter will start from here. Yes, program counter is starting from here. Now whenever the program counter is starting, now next part is this one. Now it is coming to the if condition, and very carefully remember that whenever there is any if condition and there is no bracket, means by default the next line is under if condition, means the fork is under the if condition. This printf is outside the if condition, is it or not? This printf is not inside the if condition, it is outside the if condition. Okay. So when the inside there is a fork, so when this fork will be executed, if this is true, if inside value will be true, then the fork will be executed. Now how it will be executed? There is a and. And means if this is true and this is true, when both are true, then only it will be executed, right? So when both are true, how to do it? How to do the both are true? See that fork is telling, just now I told that one fork is sending one parent and another one is child, and parent is returning the positive value, that is plus value, child is returning value 0. 0 means false, and other than 0 any positive value or also negative value is also true actually. So as there is positive value, that's why it is true. Now every time when it will create a parent, this will return a true result. When it is creating the child, that is creating a false result, right? So now come to the explanation. So that's why I am here. So when this fork is executing, so this fork is executing means it will create the remaining line. Remaining line means what? That the remaining line of the program, this is the remaining. Now it will create a child, this is a child and this is a parent. Now child is returning 0. Whenever the child is returning 0 means the if condition will be false. As the if condition is false, so it will not execute this fork, because it is false means it is coming out from the if condition. Now this will execute only this line, that is print line will be execute, right? So that's why it will print the hello and it will come out from the loop. It will not execute another fork and this fork, because already I get here false. As there is false, so means other option will be also false, because 0 and 1 and 0 and 0 both are actually false, right? So the condition will be false. So next one, as it is false, so it will be not executed. It will execute only this one. So the hello will be there. Now for the parent part. When it is parent part, when it is coming to the next one, that yes, it is returning now 1 parent. Parent is returning a positive. Now whenever parent will return positive, the next it will try to execute this fork, right? So when this is trying to execute this fork is again creating two child. One is child, another one is parent, and child will return 0. So whenever child is returning 0, then it will not execute this fork. It will execute only this print line and it will print hello, it will come out. Now the parent, that is returning 1. So whenever this will returning 1, for this condition both will be true. This was also parent, this was also parent. Now it is coming to this fork. Now when it is coming to this fork, then it will create another 2, that is this one, parent and child, right? This 2 is done. Now the program counter is here. For the child also the program counter is here, and parent also program counter is here. So child also printing hello, parent also printing hello, and finally it is coming out from the program. So how many times the hello is printed here? 1, 2, 3, 4. 4 times the program will print hello. So here your answer will be 4. Binary search traversal. It is a very important topic of data structure. But most of the time students are very much overconfident about that. And if you want to learn this topic, then this video is definitely for you. Yes ma'am, in order, I can do it in ascending order. Okay, you will do it. But tell me how to do this. I am giving you this challenge. This is the pre-order is given. Do it post-order. Try to do this when this type of A, B, C, D, these are given pre-order, and in order, do the post-order. Even also when this is given to you a expression, from here you have to do the infix, how to do. And here this type of question, when binary search tree is given and some root is removed, what will be my left subtree? How to do this? For that, you need to watch the complete video to understand the topic, and after that only you can comment in the comment section. And if you are new to this channel, then definitely subscribe to the channel and click the bell icon to get all the latest update and notification for this type of video, because you can understand in this channel you can get topic wise video, concept wise, with basic to advanced. Everything you will get here. Yes, see that here is the in order. First of all, there is a difference between normal tree and binary search tree. Here most of the time students are doing mistake. Normal binary tree, there is no rule like that left hand side will be less than, right hand side will be greater than. If it is binary search tree, then only there is the rule that yes, and if it is given in number, then only the rule is there, that is root. All the less than element will be in the left hand side, all the greater than element will be in the right hand side. This rule is there for binary search tree only. Don't mix for all the tree. This is very important. Now here we will learn the traversal. So whenever we are doing traversal, in order means what? First of all, you have to visit left subtree, left child, then you have to visit the root, then you have to visit the right child. Pre-order, first have to visit the root, then left, then right. Post order, first you have to visit left, then right, then root. How to do? From this one I am telling you. See that. First of all, in order is very easy. Just do the free fall and you will get the in order. Just do it like a free fall and you can get it. See that? It is D, B, E, A, F, C and G. This is the in order. How it is? You can see here left, root, right. Left total subtree is done. Then I will go to this root. Then after that I will come to the right subtree. Before visiting that I have to visit the left, then root, then right. It's done. So what will be the in order? You got the in order here. D, B, E, A, F, C and G. It's done. Now we will do the pre-order, and I am doing here only, and that's why I am erasing it. Okay. So pre-order means what to do? First of all, I have to visit the root, then only I can visit left, then right. So always root will be the starting. So start with A. First of all, A will be there. After that I can visit left. Whenever I am coming to visit left, this is the root. So visit this one. After that only I can visit the left child. Yes, and it is no, they don't have any child. So I can write it now. So it's done. After that, see that root left. So it is the root, left child is done. So I need to visit the right of B, which is there in right of B, that is E. So I can write E now. Now left part is done. So see that the root was A and left part of A is done. What to do now? Now I have to go to the right part. In the right part, this is the root again. I have to visit the root, right? So I have to visit C first. After that I can go to the left, that is F. Then I can visit the right, that is G. It's done. Post order. So now we will do the post order. How to do the post order? post order means here you can see that root will be in the last. So when root in the last, how to do it? How to do this? See that. Here first of all I will visit the left. Here this is the left, right? Extreme left. Come to the extreme left. Extreme left is this one. So extreme left I will visit. After visiting left I can visit right only. So for this child in the left subtree only right. You came to the left subtree. After that in the left subtree you visit the left. Then this is the next one. That's why I have to visit E now. Now see that for this subtree you already visited D and E. Now you can visit the root, that is B. It's done. Now can I do the A? No. Till now for A right subtree is remaining. So I have to come to the right subtree. In the right subtree till now I cannot write C, because before writing C I have to visit left, right, then only I can visit C. So that's why write the A first, that is the left part. Right part is G. After that only I can write C. Now right subtree of A is also done. Now I can write A and it's done. This is called the in order, pre-order and post-order. I hope it is clear. So we got the in order here, the D, B, after that E, then A, then F, C and G. And here I got the pre-order A, B, D, E, C, F, G. And I got the post-order, that is D, E, B, F, G, C, A. It's very clear. I hope so. Now see that. Now here this question, the binary search tree is constructed by inserting. Now how to insert in a binary search tree? That is the next topic I have to learn. Right? Then only we will go for the difficult one. So how to insert? Try to remember one thing. Always tree insertion will be in this manner. But for the binary search tree, normal tree, we will go for first of all root, then left, then right, again this way. But for binary search tree, a rule we have to follow. Whenever I am inserting, first one will be the root. After that, each and every time I will check that is it less than. If it is less than, then it will be left part. If it is greater than, then I have to send it into the right part. This is the main rule here. So now let's construct it. So here how to construct? Here I will construct. See that. This is the 60. First of all I am taking 60. After that 25. 25 is less than 60. So that's why I will send 25 here. Then 72. 72 is greater than 60. So 72 will come here. 15. 15 is less than 60 and then less than 25 also. So 15 will come here. 30. 30 is less than 60 but greater than 25. That's why 30 will come here. 68. 68 is greater than 60 and less than 72. That's why 68 will come in the left subtree. Right subtree. 101, that is greater than 60 and greater than 72 also. So 101 will be here. Then 13. 13 is less than 60. It's less than 25. It's less than 15 also. So that's why 13 will be left subtree. 18. 18 is less than 60. It's less than 25 also. It's greater than 15. That's why 18 will be here. Next one is 47. Where will be 47? You can tell me now. Yes. So it is less than 60. It is greater than 25. And after that, it is greater than 30. That's why it will be right child of 30. It's 47. Now next one is 70. Where will be the 70? It is greater than 60, less than 72 and greater than 68. So 70 will be here. Last one is the 34. Where will be the 34? This is less than 62, greater than 25 and greater than 30 and less than 47. That's why 34 will be here. And this is your tree. We already constructed the tree and this is your final tree. Now the question was there that number of node in the left subtree. Now you can count how many nodes are there in the left subtree. This total is your left subtree. How many nodes are there? 1, 2, 3, 4, 5, 6, 7. So total 7 nodes are there. So answer will be 7. It's very easy, right? Now come to the next question. So this question always students are very easy. Yes ma'am, in order means I will do this is the ascending order. Yes, for binary search tree you can apply the trick. For binary search tree, when the post order is given to you, from the post order for the in order you can do it. Yes, because from the option given option you can see this is the ascending order, but you need to understand the topic, because to solve this type of question, when this is the pre-order is given, how to do post order, and sometimes from option also maybe you will not get, and maybe it is not given in binary search tree, then how you will do it. That's why try to understand this one, so that how to form a tree, that is very important. If any order is given to me, then from that order how I can form the tree. If I am able to draw the tree, then any traversal I can do. So let's learn it. So see that here it was given to me, anything else is not given. One thing is given to me, it is a binary search tree. This is a binary search tree given, and pre-order traversal given to me. I have to do the post-order traversal. Now how to do? See that. Pre-order means what it is? That is root, after that left, then the right. That is the pre-order only, right? So 12 is my root, that is to confirm. Now when I got the root, then as it is BST, what is the property of binary search tree? All the less than of root will be in the left subtree and greater than of root will be in the right subtree, and that is a big decision pointer. So 12 is my root, all less than element right hand left hand side, write down here, that is 8, 6, 2, 7, 9, you can see here 10. These all are less than 12. Remaining all are greater than 12. That is 16, then 15, then 19, 17 and 20. This is the first thing. And you can eliminate from the option also. Now you can eliminate, because 12, find out the 12. Here are the, where is the 12s? Here is 12, here is 12, here is 12. After that you can apply elimination method. That before 12 all will be less than, after 12 all will be greater than. In that way you can eliminate. In exam hall definitely you can eliminate. But still I will tell you, you have to learn the concept. Because always this elimination method will also not apply for the alphabetical question. So please have your patience and learn the topic. Yes. After that, what to do? See that next root is 8. That is confirmed. So from here, out of them, I can make that 8 is the root. Whenever I am making 8 is the root, same way all the less than element of 8, that is 2, 6, 2 and 7 will be in the left hand side, and 9 and 10 will be in the right hand side. I got it. So see that next one is 6. Next one is 6 means from here I can make the 6 is the root, and less than is 2 and greater than is 7. It's done. Ultimately this part is done. So you got it that 6, 2, 7, this tree is done. After that next one, this part is done. I will not do again. I am here in 9. So 9 is my root. Actually from here I can make 9 root. So definitely 10 will be the right hand side. So 9 and 10 is done. Next one is 16. So from here 16 I can make as root. Now less than element is 15. So 15 will be in the left hand side definitely. Greater than are 19, 17 and 20. Now see that. Here, so 15 already done. Next element is 19. So 19 will be the root. Definitely. Less than, that is 17. Greater than, that is 20. So ultimately you got your tree. See that your tree is already done. This is your tree. That is 12. After that 8. Then 9. Just erase it if you are getting confused. Now you can erase this part. These are not there actually. You can erase this part. Just erase it. This part is also not there now. This part is also not there now. And this part is also not there now. And ultimately your tree is done now. See that. This is your left, right, and here, here, and ultimate. This is your tree now. Yes. This is the way how to form. So ultimately you got the final tree, and from this final tree, see that here in this way 12, 8, 16, then 6, 9, then 2, 7 and 10, 5, 19, 17, 20. I got this tree, and finally my post order will be this one. This is my post order. How to do the post order? Just I will go to the left subtree, then 2, then 7. After visiting I can visit this one. Then I have to go to the next. Then I can go to visit this one. Finally last one I can visit. Before that I have to come here. That is I have to visit the left subtree. Then again left and right. Then again come to here. Finally I can visit this. Then finally I can visit this one. That's why it is my starting point. This is my starting point. 2, 7, then 6, then after that 10, then 9, then 8, then 15, then 17, 20, 19, 16 and 12. And it's done. And that's why it will be the answer. And after knowing the concept, it's very easy, right? After knowing the concept, you can understand, yes, 12 here, 12 is my definitely root. So definitely less than element will be in the left hand subtree and greater than element will be in the right hand side subtree. That is in order. But it was post order. It was post order. How to do? Without doing the tree, can you do the post order? In order you can do, but post order how you will do? That's why you have to draw, right? Now see that. Here this one, same way you can do it. as it was BST was given, that's why we can apply the rule that is less than element and greater than element. Here these are alphabet and it is normal tree, it is not the BST. It is a normal tree, it is not a binary search tree. How to do it? Here another trick we have to apply. How to do? See that. Here actually pre-order means I know that pre-order means first one is my root. After that first one is my root, then left, then right child. That is I know. And in order means I know that root is the middle and left subtree is here and right tree is here. Right. Now we will do by comparing both. How it is? See that. Pre-order, from here I know that A is my root. That is clear. A is my root. Now from in order I will find out where is A. Here is A. Now see that. From in order I know that root, before that all element in the left subtree. Now see that. Actually this all element will be in the left subtree here. This all element will be in the left subtree. That is E, I, C, F, J, B, G, D, K, H and L. All element will be there in the left subtree. Means it is a left skewed tree. In the right subtree there is no one. Right. Now see that. Now what will be the next? Next will be again from the pre-order, try to see which one is the next root. Next root is B. So what I can make? B I can make the next root. Whenever I am making the next root B, then and there I will find in the in order where is B. Here is B. So before all the element will be the left subtree, after all the element will be in the right subtree. So that's why before B all these element write down in the left part. That is E, I, C and F and J. After that what are there? After B G, D, then K, H and L. Already A we did, right? So no need to write A again. Already A we did. So just we will check till this part. It's done. Now again go to pre-order. From the pre-order see the C. C is here, right? So what to do? C is my root now. Whenever I got the C is the root, now again from in order, where is C? Here is C. You can see EI and FJ. So EI will be in this part and FJ is the right part. It's done. Now again go to the pre-order E. E is my next root. So I got it. Here will be the E. So no need to write here I. Just I will be here. That is because in the in order E, after that I. Your tree is done. Finally I. So from here you got the I already. Next one is F. Next one is F. Means F is my root and J is my right subtree because after F there is J. You got it. Now D. From here I can make D is my root. Whenever D is my root, before that there is G. So before that there will be G. After that there is K, H, L. So here will be K, H and L. Now after that D and G is done. H is my next root. So make H as a root. H is the root now. And before that K and after that L. So here is K and here is L. So ultimately your tree is done. Now just erase this part. If you are getting confused, then no need to do it. Just erase this part. Whatever I took for your understanding, just erase it and your tree is. And you can erase these also. These are also you can erase so that your clean tree will be there. You can erase this one also. So yes, now you got a clean tree. This is your tree actually. And A, there is no right child. There is no right child of A. Actually, it is a left skewed tree. There is no right child of A. Right? It's done. Now what was there? Question was asking that what is my post order? Now do the post order. Come to the extreme left. Extreme left is I. I will start with I. I am writing here. So I. After that, after I, which one I can visit? After I can visit E. Can I? Because post order is what? Left, then right, then root. So same way, after I can visit this one, right? So you can get the answer. I hope there is no confusion. You can get the answer, right? Are you confused? Confused? Achha, let me do it. Let me do it. E, after that I can visit I. Because see that, always remember one thing. In the post order, easily remember. Before visiting any root, I have to complete left and right. Before visiting any root, I have to complete left and right. So I will start from here. There is left. No, I cannot. Here again there is left. I cannot. Here there is again left is not there, but right is there. So that's why my starting point will be here. After visiting this one, I can visit now E. Next one is what? Can I visit C? No, it have child. Can I visit F? No, I have child. I have to visit J first. That's why I have to visit J. After visiting J, now can I visit F? Yes. Childs are done. Now I can visit F. Now can I visit C? Yes. Now I can visit C because all the childs are done. Now what can I visit B? No. Can I visit D? No. It have the child. Can I visit G? Yes. I can visit G because G don't have any child. So that's why I can visit G. After that, which one? After that, can I visit H? No. H have the child, right? So I have to visit the child. K. Then I have to visit L. It is also the child. Both child are done. Then I can visit H. It's done. Now G and H, all the both are child are done. Now I can visit D. Yes. Now you can see the B, all the childs are done. Now I can visit B. Yes. And finally I can visit A. It's done. This is the way of doing post order. Always remember, before I can visit a node, if it don't have any child, I can start from there. If it don't have any child. And first of all, we will start from the left. If the left is not there, then only I can visit the right. So if there is no left, so that's why I am visiting this one first. It is the left subtree, extreme left subtree. Left part is not there, that's why I am visiting I. And I is the child of E, that's why I can visit E. In this way you can do. And you can get the answer now, right? E, I, J, F, C, G, then K, L, then D, H, K, L, then H, D, yes, then B, A. It is the answer. Finally, you got the answer. Easy, right? Now, yes, that's why concept is required. Without learning concept, if you are going for shortcut will not give you success. Always remember. Now see, ma'am, how to do it. How to do? This is also by tree. You can draw the tree and after that it will be easy. See that. Here this is the reverse Polish notation for the infix. Reverse Polish means nothing but it is postfix. Postfix means what, ma'am? Postfix means post order. Postfix means post order. Prefix means pre-order. And infix means in order. That is, whenever expression we are doing, then we are telling like that. Postfix means post order. Prefix means pre-order. Infix means in order. So here what to do? A postfix notation you have to do means post order when the in order is given. In order means what? In order means I know that root will be in the middle and here will be the left and here will be the right. Right. So see, in this expression, this is my root actually. This part and this part is separate. So draw the tree. Here only I will draw the tree. This division operator is my root. Here is my left subtree. Here is my right subtree. This is my root. Now both are in this side. This one and this one. Right? Now from the left subtree, try to find out the next root. This one is the next root. So that's why star is the next root. Before that, here is A. So here is A. Got it. Here is the A. Now see. Now remaining part is this. From the remaining part, what is the next? Next is the plus. So here is the plus. Before that there was B. So before that here is B. Now see. After that what is there? After B what is there? There is C star. Can I directly write C? No, because the star is also here, right? Which is my root. It is in order. So the root will be here, the star. After that, before here is C. Then only I can do, right? C star. D plus E means what? Plus is there. Here is D and here is E. This is done. Now this part I will do. So for this part, what is this? This is the star. So make the star. Before that there is F. Before here it was F. After that G plus H. So plus is your root and G is the left subtree, H is the right subtree. Always remember, this is the binary operation. Whenever I am doing star, before that one operand, after that another operand. This is my root, another operand is my left and another operand is my right. So that's why always I will write like this way. I will try to find out, it is the expression. I will try to find out the operator. Operators are my root. Operator are my root. And child means these are the operand. Now you got it. Now postfix is very easy for you. What will be the postfix? First of all, left subtree. There is A. I will write down the A. After that, what I can visit? Can I visit directly right? No. I can visit B. I can visit B. After that, can I visit star plus? No. I have to visit C. I have to visit C. After that, can I write star? No. I have to visit D. I have to visit D. After that, can I visit E? Yes, I can visit E now. After that, what? After that, the plus. Plus. Then what? Then the star. Star. Then what? Then the plus. I can visit the plus. Then what? Then the star. Star. Can I visit now this one? No, 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 no. It have the right subtree also. Can I visit F? Yes. Now, can I visit G? Yes. Can I visit H? Yes. Now, can I visit this one? Yes, you can visit. Now, can I visit this one? Yes. Now, finally, can I visit this one? Yes. So, is it the answer? Am I did mistake? I hope no. A, B, C, D, E. A, B, C, D, E. Then, plus, star, plus. You can see here, I read plus, star, plus. And finally, plus, star, plus. Then, star. Another star is here. This is the star. Then, F, G, H. F, G, H. Then, plus, star and slash. Means division. So, you got the answer. This is the way you have to do. Yes, I hope it's clear. At least you can comment here. At least you can like. Right? Press the like button. Press the comment. Something you can comment so that I can get some motivation. I am teaching from a long time. If you are not commenting, then how I will get the motivation? And please share with your friends also so that they can also learn. Ultimately, sharing is caring, right? Yes. So try to share. So here, whenever this is the binary search tree, it is very easy. Now you can do it. What is that? What will be the answer? You can do it, I hope. Is it a homework? Can I give you homework? No, no, no. I am telling you the answer. It is very easy. When I am removing the root, then from the left subtree, which can be my root? Easy one. Because from the left subtree, which one is the greater one, that is can be the root, because I have to follow the property. The root, all the less than element will be the left hand side, greater than element will be the right hand side, because it is binary search tree. If you are taking root from the left subtree, then take the highest element. If you are taking a root from the right subtree, then take the lowest element. That is the trick here, and your answer will be 16. After that, how to identify the normal form 1NF, 2NF, 3NF, BCNF. What is the minimal cover? How to do functional dependency with the question, yes, how to solve it, because practical knowledge is very, very important. I am showing you the question. If you are able to solve, then after that no need to watch, because your concept is already clear. So this is the first question. Are you able to identify the key or not? This is also the next question. It is the theoretical question from normalization. Are you able to do it or not? Next one is, this is which normal form. Next one is, again it is which key, which one is the primary key. Next one is which normal form it is. Again the next one, after breaking the table, which normal form it is it dependency preserving or not. This is the coming to redundant attribute, redundant functional dependency. This is the basic of minimal cover. Next one is, which one is the minimal cover now. Again the next question is here, which one is the minimal cover here. So I hope you can start now, right? So just I need your concentration and time. You need to watch the video till the end, and definitely subscribe to the channel, click the bell icon to get all the latest updates and notification. Be with me till the end. After that, definitely comment in the comment section that what you feel. So let's start. First thing is, we have to do how to identify candidate key, because candidate key identification is very important. Question are also coming, and for normalization you have to understand prime attribute, non-prime attribute. That's why identifying all possible candidate key is the first step. So here we will do this question only. You can see here, this is the question, and from this question the dependency is given and what are the candidate key. How to do it? Easy thing. Just write down all the dependency one by one. U to V, VW implies X, and Y implies W, and X implies U. Now check the right hand side. In the right hand side, which one is not present? In the table, U, V, W, X, Y, Z was there. Out of them, which one is not present? You can see here, V also there, X is also there, W is also there. Not present, that is Y, Z. This is not present. So means it have to be the part of candidate key. Because which one is candidate key? Candidate key means that attribute which can identify all other attribute. Means through which you can, if you are doing the closure, what is closure? Means just from the functional dependency we are able to get that attribute or not. So YZ you are not able to get through any attribute, means YZ have to be the part of candidate key. So write down YZ here. YZ closure. From Y, which one you can identify? From Y, from here you can see I can identify W. From W you can identify anything. Total VW, if the VW coming, then only you can identify X. So it is getting YW, you cannot do. Next one is Z. From the Z, can you identify anything? No. So YZ is not able to do all that. If I am adding anything, is it possible? See that X, Y, Z, if I am adding with this, then you can see X can identify U. Yes, now X already came. With that, U is also coming from here. You can identify V also. So from E I can take V also. Now you saw that all are came, right? X, W, Y, V, Z. Everyone came here. So means it is done, right? You got your candidate key. But no, don't stop. Here it can be multiple candidate key also. What are the multiple candidate key? How to get it? Check here. From X, who can determine X? You can see VW can determine X, right? So let's try with V also. If I am replacing X with V, is it possible? You can see that Yes, it will be possible because through the X you can do U, right? So through the V, can you do anything? Through the V, see that through the Y you can do, Y is there, Y you can do W. Now when V is came, V is already there. From the VW you can do X. And now from X you can do U also, that is U. Now after that Z is there. So U, V, W, X, Y, Z, everything is done. No, don't stop. Here V also, can I replace with anyone? See that V can be identified with U also. So that's why I will replace V with U. And after that I will try. U though can able to identify V. Now U, V is done. Now you can check Y is already there. So Y can identify W. So now VW together can identify X also. Now X can identify U also. And Z though already there. So everyone is done. Now can I stop? Yes. U. Here U can be done. See that U can be replaced by X. And it is now a cycle. So this is the time to stop. You got all the candidate key. This is the way how to identify all possible candidate key. Always go for all possible candidate key for doing normalization. This is the first step. And this question, after learning the concept, this question you can solve within 30 seconds. Because why? Because you can know that is YZ is the what? YZ not present. So here you can see only Y. It is not possible. Here you can see only Y. It is also not possible. YZ is there. YZ is there. Here is no YZ. It is not possible. So this is definitely my answer. After learning the concept within 1 second you can do the question. It's easy, right? Let me know in the comment section. Next question I am giving you and you can do it. I hope so. It's very easy now. Within 1 second you can do it. Right? Let me know. You can do it. Yes. What will be the answer? It's easy. Very easy. Just see the right hand side. A, B, C, D all are present. Which one is not present? E, F is not present. So E, F have to be the part of candidate key. Here is E, F, here is E, F. E, F is not there. Here is E, F, here is E, F, here is E, F. Here also not possible. These are not possible. So definitely it will be my answer here. You can do it. It's super easy now, right? So एक बार like तो कर दो. Now we will learn normalization in 1 minute. Yes, it is possible in 1 minute. Just stay with me. It is the most confusing topic, but it will be super easy now. See that. Normalization. What to do in normalization? First of all, in normalization, you should start with BCNF. Because normally 4NF, 5NF, it is not our part. They are not asking that much. In exam hall, they will ask you BCNF, 3NF, 2NF. See, already we did here the candidate key, right? In the last question, whatever the last question we did just now, this question we got our candidate key. So your candidate key is AEF, BEF and DEF. From these you have to prepare the list of prime attribute and non-prime attribute. What is prime attribute? Prime attribute means which are the part of candidate key. Which are the part of candidate key? A is there, E is there, F is there. And from here B and D. B was there and D was there. These all are your prime attribute. What are the part of candidate key? Everyone is the prime attribute. After that, which one is the non-prime? Which is not the part of candidate key. A is already there, B is already there, D is also there, E is also there, F is also there. Only non-prime is the C. C is only non-prime here because C is not the part of candidate key. That's why C is non-prime. So it is the next step. After identifying candidate key, you have to identify which one are the prime and which one are the non-prime. This is done. Next thing is what? Next thing is BCNF. See that. When anyone is in BCNF, then it will be automatically in 3NF and then 2NF, because there is more constant. In BCNF, constant is more. If you are satisfying the upper constant, then definitely lower border will be also satisfied. So what is the constant? Constant is that left hand side must be candidate key or super key. Super key means what? More than candidate key. With the candidate key, if some extra attribute is there, that is called super key. So if candidate key is satisfying, then super key will be already satisfied. So left hand side we have to check all the dependency, the candidate key is there in the or not. So see there. In this question only we will do. What are the candidate key? A, E, A, B, E, F, D, E, F. See the dependency. Is there A, E, F? No. Is there D, E, F? Is there anything? A, E, F, D, E, F, all are there in left hand side? Not there. Just check the left hand side. If these are not candidate key, then it cannot be in BCNF. Simple rule. Check all the functional dependency. If all are the candidate key or super key, then no problem. If any one is not the candidate key or super key, then it is not in BCNF. So this relation is definitely not in BCNF. It is clear. Next part is, so we will come to 3NF. 3NF is checking only here the constant is little bit less. Okay, you are not able to satisfy BCNF, then try for 3NF. 3NF is telling that I will not allow non-prime to non-prime attribute, non-prime to non-prime dependency. This is not allowed here. This is called the transitive dependency. Another name is transitive. This is called transitivity. Why this is called transitivity? A implies B and B implies C. This is actually transitivity. When we can say A implies D, because this is non-prime and non-prime, that will be not allowed. It is not allowed. Remember one thing. Non-prime to prime, that is allowed here. In the right hand side, if there is prime attribute, then no problem in 3NF and in 2NF also. Right hand side prime, no problem. But non-prime to non-prime only we will check here. This is the simple thing I have to check. Is there any one? Which one is non-prime to non-prime? You can see here. In this dependency, what are the prime? You can see prime list A, E, B, D. So you can see A, B, E, D, all are prime. Actually these all are prime. So there will be nothing non-prime to non-prime. Means, is it in 3NF? What do you think? Tell me. Anyone is not violating rule. Non-prime to non-prime, anyone is not there. Everyone is prime. After that, whatever in right hand side, no problem, because in left hand side I already got all are prime. So in left hand side there is no non-prime. Is it in 3NF or not? Definitely it have to be in 3NF, because non-prime to non-prime is not. There is no problem. Right. Now come to the 2NF. If this one was satisfying 3NF, but in another question it can be 3NF is not also satisfied, then we need to change the 2NF also. So for 2NF what to do? For 2NF, see that previously it was not satisfied. 2NF is little bit less constant. Okay. In 2NF, non-prime to non-prime we are allowing. What was not allowed in 3NF, we are allowing. Okay, non-prime to non-prime can be there. Now which we are not allowing? We are not allowing here prime to non-prime. That is called partial dependency. What is partial? Partial means part of candidate key. And one trick I am telling you. Partial means it can be happen when there are more than one attribute in candidate key. Like your candidate key together, like A, B, D. Like just now you saw that their candidate keys together. A, E, F, B, E, F, D, E, F. In each and every candidate key there are 3 attributes. Then only chance of partial dependency can come. then only chance of partial dependency is there. If there is only one attribute in candidate key like A or B or C, then there is no problem in 2NF because there is no chance of partial dependency. There will be no chance of partial dependency any time. Got it? Always remember, this is very important. If you saw that only one attributes are there in candidate key, so it have to be always in 2NF. If there are multiple attributes, then only we have to think, because prime to non-prime is not allowed here. See this question only. See here, A to B. What it is? It is actually prime to prime. Is it or not? Because A, B both are prime. Here it was B, C. B, C together, and I did a mistake and you did not notice it. Right? If you saw this one, is it actually allowed in 3NF? If you saw here, you are not telling anything. Sometimes I am doing mistake by knowing also that you are checking or not. See this very carefully. B, C implies D. Here C was a non-prime attribute here. The B was prime but C was a non-prime attribute. So is it possible in 3NF? Here it is coming actually the C, B, C together implies D and C is the non-prime attribute. But the D is the prime attribute. C is the non-prime attribute but the D is the prime attribute, and that's why no problem. Because right hand side is here prime. This one was prime to prime, and this one for C you can say it is non-prime to prime. No problem. E to C. E to C is what? E is prime. C is non-prime. Here is the problem. E is prime and C is non-prime. So is it possible? It is in 2NF. Is it possible? It is in 2NF. Non-prime to non-prime was not allowed. Prime to non-prime, this is coming to prime to non-prime. Is it allowed in 2NF? E is the part of candidate key. E is a prime attribute and this is so definitely a non-prime attribute. So here it will be not in 2NF also. D to A. D to A, what is happening here? D is the prime attribute and A is also the prime attribute. There is not a problem. Problem is in E implies C. Because E implies C, E is the part of candidate key, E is the prime attribute here and C is the non-prime attribute here, which is not allowed in 2NF, and that's why it will be not in 2NF also. That is a problem here. I hope you can understand. And for 3NF, this is also the constant. For 3NF, we are checking non-prime to non-prime. With that, this constant is always there. That is prime to non-prime. This constant will be always there. So, in 3NF, what are the things we need to check? Non-prime to non-prime, that is also not allowed. Prime to non-prime, that is also not allowed because it is the part of 2NF. And if right hand side there is prime, here it can be non-prime, it can be prime in left hand side, that is not a problem. This is allowed. Right hand side prime, that is allowed. Here also the right hand side prime, that is allowed. Okay. In 2NF, non-prime to non-prime will be allowed, but prime to non-prime, that is not allowed. So these are the things what we need to remember. Just remember one thing. I will check for BCNF. All left hand side should be candidate key or super key. 3NF, non-prime to non-prime not allowed. Prime to non-prime also not allowed. 2NF, non-prime to non-prime will be allowed, but prime to non-prime not allowed. So be careful about this one. I hope you can understand. Now go to the next question. So already you learned it, right? What is BCNF, what is 3NF, what is 2NF and what is 4NF? I will say. But without that also you can match the question. Without this also you can match the question. Yes, match it. It's very easy. Right? Yes, you know that the 3NF is transitive dependency. 2NF means no partial dependency. It is partial. 2NF means partial. Actually, the partial. This one remove the partial dependency. So, 2NF is here. Partial and this one is here. So, your answer will be what? You already got it, right? This is the partial. Transitive. This one not. Yes. Now, you can see the next thing. That is BCNF. BCNF was what? No need to do. Actually, from the 3NF and 2NF, you already got the answer. For 3NF, B will be with the 3 and you can got the answer. But other than that, you can do it. See that the multi-valued dependency, it is actually the part of the 4NF. In 4NF, we have to remove all the multi-valued dependency. That is the part of 4NF. And for BCNF, it not always dependency preserving. BCNF is not always dependency preserving. This is also you need to remember. Now try to solve it. It is more easy. Whatever I solved, it was difficult. This one is more easy. You can do it. I hope so. There is 3 part. What is it in first normal form? Is it in second normal form? And which one is the key here? Solve it. And I am telling you, those who are UGC NET candidate, these are all UGC NET previous year question. Yes, these are all UGC NET previous year's question. So, it will be fruitful for you. So, what to do? It's easy, right? Which one is not present in the left hand side? Right hand side, that is X and Z, and it have to be the part of candidate key. If I am doing XZ plus, then I can get X implies Y. And Z is there, Z implies W, so I can identify everyone. So definitely which one is my candidate key? XZ is my candidate key. Now it is in which normal form? Which one is your candidate key? See that XZ together. And X is a part of candidate key. And Y is the non-prime attribute. When you are taking X implies Y, this is actually prime to non-prime. And that is not allowed. X implies Y, that is definitely not allowed, and that's why it is not in second NF. It will be in 1 NF, and primary key is this one, and this one is wrong. One thing, primary key and candidate key, that are same actually, means there will be lots of candidates who will be selected in the election. They are the candidate to be the prime minister. Out of them, any one of them can be the prime minister. That is the primary key. So whenever you are able to identify the candidate key, if there is only one candidate key, that one is your primary key. And if there is multiple candidate key, out of them, any one of them can be the primary key. Otherwise you will ask me, ma'am, they ask primary key. We know it is candidate key. How we can say it is primary key? In this way you can say it is primary key. Clear? Now do it. Read it and do it. I think you are getting right. You can do it now. Yes. So A, B, C, D, E, B, C, D and A, D. Do it. See here. One thing. Which one is your not there in right hand side? B, C is there, D is there, E is there. I can easily say A is not there. And if I am doing A closer, from A I can get A, B, C. And after that from B, C I can get D also. From D I can get E also. A can determine everyone. A is my candidate key. So definitely A will be my primary key. It's done. Next one, which normal form it is? Pause the video, try to do it by yourself. You can do it and let me know in the comment section. Just now these are actually comprehension type question. From the last question only it is the sequential question. Just now we solved that A is my candidate key. And I told you when only one attribute is there, then by closing your eyes you can say 2NF have to be there. It cannot be in 1NF. 2NF so definitely. Now we have to think, is it in 3NF or not? In 3NF, non-prime to non-prime was not allowed. Here prime attribute is only A. There is other, all are non-prime. And D implies E, that is a non-prime to non-prime. D is also non-prime attribute. E is also non-prime attribute. That's why it will be not allowed in 3NF. And this is not allowed in 3NF. And if it is not 3NF, it cannot be BCNF also. So it have to be in 2NF. And your answer is done. I hope you can understand. Next one. So the next one is here. This relation is break into two parts. After that it is asking, is it which normal form and is it dependency preserving or not. For that I am telling you how to understand dependency preserving. First of all, whatever dependency is given, from that dependency try to get all the hidden dependency also. How to get all the hidden dependency? See that. Try to do the A closure. From A closure you can get A, B, C, D also can come, E also can come. These are actually hidden dependency, means A can determine B also, A can determine C also, A can determine D also, A can determine E also. In that way you will got all the dependency. And here you can see D is already determining E. Try to do the D closure also. D closure is coming DE only. So D can determine E. Try to do the BC closure. From the BC closure you can get B, C, D and E also. So here is a hidden dependency that BC can implies D and BC can implies E also. Another dependency, if you are checking that BC implies D, already we did. A implies D. So here we already did it. So this is called the F closure. Try to find out all the hidden dependency also. But after doing all the hidden dependency also, they already provide here. Sometimes they are not providing. Sometimes they are not providing. Then what to do? Whenever they will tell you that I am giving it to R1 and R2, then distribute it. In R1, what are the attributes is there? Put that dependency in R1. And what are the attributes are there in R2? Put that dependency in R2. This is the way. But here it is mentioned that in F1 we are giving AB, AC and this is given to you. What are the next part? After distributing, try to do the union. And then again do the closure. If anything deriving again some transitivity or something, you can derive extra dependency or not. After that, if you are getting the same dependency, first you are distributing. After that you are adding. After adding, if you are getting the previous one, then dependency preserve. Otherwise, dependency will be not preserved here. So now do it. Now you got. You can do it. Yes. So which one is the answer? Answer is this one. Because it is not dependency preserving. You can see A implies B, A implies C here. From the A, I can determine only BC. That is done. And from here also A implies D, D implies. Can you determine BC implies D from anywhere? If you are adding this both dependency also, BC cannot determine D anyhow. Why? Because actually B and C is here and D is here. Anyhow, you cannot determine by doing plus also, means by doing union also. If you are doing F1, if F2, then closure, then also the original one is not coming. And that's why it will be not dependency preserving. Next part is, it is in which normal form? First one, which is candidate key, and always remember after dividing also again you have to find out the candidate key. Here which one candidate key? A. Here also which one candidate key? A. So you can see both are actually left hand side candidate key. Left hand side candidate key means it have to be in BCNF. This is in clearly BCNF. And here this is the candidate key, it's no problem, but D, it is actually prime to non-prime. And this one is non-prime to non-prime, that is not allowed in 3NF. So it is in 2NF only. Now in option there is no BCNF. If anyone is BCNF, then that was is automatically in 3NF also. That's why we can choose the option it will be in 3NF and this is in 2NF. Clear? I hope so. Now do this one. Which one is redundant? This is the part of minimal cover. How to do the redundancy, you know. Redundancy means again same thing. The closure is the ultimate fundamental is the closure. Through the closure only you can play the game. Try that. Can I remove some extra thing? By removing also I can get the same closure. Means try to do the A closure. In the A closure, from the option you can go through the option, or another way is that try to see that in the right hand side this one is also identifying D, this one is also identifying D. Now your target will be by removing any one of them, can I get it? See that. First you can target A implies D. This one I am going to remove. Means in my hand only these three are there. By these three can I get A closure with D? Means you can see A can determine BC. From here I can do. BC can determine D. From here I can do it. From D it can be determined E. You can see in A closure without this one also I can determine everything. Means it is very clear that A implies D is my extra one. It is the redundant one. So I can remove this one. But BC implies D I cannot remove, because if I am removing it, after removing I cannot get the BC closure. That's why I cannot remove this one. And your answer will be this one. By removing this one also I can get in the A closure everyone is coming, D is also coming. So it is a redundant one. Now tell me which one is the minimal cover. Minimal cover means after removing the redundant one, which one is left? That is your minimal cover. Means it is the minimal dependency which you cannot remove. These are the mandatory. Just now you remove the redundant one. So what is the minimal one? Easy, right? Yes, correct. Here this one is the A implies B, B implies C, BC implies D. This is the correct answer because A implies D I already removed. Now you will ask me, ma'am, here it is A implies BC, here it is A implies B, A implies, how it is coming? It is coming like that. A can determine B and C both. This one I can write A can imply B and A can imply C also. But one thing I am telling, if anywhere is written A, B implies C, then never do that A implies C and B implies C. Please don't do that. A, B together can imply C. A alone cannot do it directly. B alone cannot do it directly. Don't do that. It is possible. I can determine you also. I can determine your friend also. So I can determine both. That is okay. But this is no. And that's why your answer is this one. Clear? Now the next one. Which one is the minimal cover here? Remove the redundant one and tell me the answer. You can do it. You can do it. I know that. Or go for the option also. From the option also you can check. Check it from the option. Yes. See, this is the answer. Why this is the answer? Try with this one. See that A, C, D, F implies E, G. If I am removing this one, after removing this one also, can I determine EG? Can I determine EG or not? You can see yes, because A, C, D, F, if all are coming. So A implies B. From A I can determine B. And after that already from C already there. So C, D, F already there. Now A, B, C, D together can determine E. E, F together can determine G. So everyone can be determined. Without this also I can determine. I am not taking this one. Without this also all are coming. So no problem, I can eliminate this one. And here why I can eliminate B? Because A can determine B. If I am taking A, C, D, from A already can determine B also. And that's why from this A, B, C, D I can remove B. Because from A automatically B will be generated. and that's why ACD implies E. This one I cannot remove. This one also I cannot remove. So finally this is your answer. So I have to know why it is what is addressing mode. Addressing mode is that in a instruction there is normally in a instruction one part is there that is a opcode and another part is there that is called operand. Okay, so opcode means the instruction. In this opcode part is telling you instruction name, what you want to do, add, you want to do addition, you want to do any other work, you want to do complement, what you want to do, that is a instruction. And if I am telling you that add is a operation, I want to add. Now what you want to add? You add means there will be two variable, right? That a plus b, that is only the addition is possible. Now where I will get a and where I will get b, CPU, how CPU will understand that where I will get A and where I will get B, because A and B is the two variable. That variable you have to store somewhere, means your computer is storing into a memory or register, where that is the storage capacity. Two types of storage capacity is there, that is one is register, another is memory. So either your computer is storing that variable in a register or in a memory, that is a possibility. So now where it is stored, that is the first question. It is in register or it is in memory. Now the second question is there, that how I will access it, means in the operand part something is given. What is that? It is a direct value. It can be also there in the operand part, directly you are giving the value, no need to go anywhere. This is the operand part and here only directly I am giving the value only, no need to go anywhere. That is also possible. Another possibility is there, I am giving here an address. It is a address of some location, maybe you have to go to that address. Or it can be also there that maybe it is a address of another address. Means now this is a confusion is coming to CPU, that what is this? This part is telling operand, but what is this? That is telling you that CPU have to know the effective address. Effective address means actually where my operand is. Exactly where is my operand A and B, where is my operand, from where I can get the value so that I can do the operation. That is the concern and that is the thing what we are going to learn in the addressing mode. So let's start. First of all, first addressing mode is implied addressing mode. Implied addressing mode or implicit addressing mode. The name itself telling you it is implicit. Implicit means what? In the operation. Implicitly, no need to extra, no need any extra thing to do. That is where my operand is. Means what? Like I am taking an example of CMA, complement accumulator. It is telling you the complement accumulator, means this instruction itself telling you what to do. No need to specify any operand, no need to specify any address, no need any other instruction. Nothing extra instruction, nothing extra information is required. CMA itself telling you that you whatever value in accumulator, that accumulator value, maybe here it is 101, I will do the complement, so complement will be 010. Got it? So implied means no extra information required. In the instruction itself it is telling you what to do. Correct. Next one is the stack addressing mode. Stack addressing mode means here another operand, the operand we are telling from the stack. How? It is a stack. Think like that. This is a stack. In the stack, first I will take top element. Next I will take another element. If I have to do the add operation, then first element I will take and I will do the operation. That is called the stack addressing mode. These are not coming in the exam that much, but the next one is very important, that is immediate addressing mode. And here students are getting confused between implied and immediate. What is the difference between implied and immediate? Always you are getting confused here. Try to understand. Immediate means here it is giving you a value. That is a immediate value. Means in the operand part, if I am writing here, I am adding here some page. Just let me add some page here so that I can discuss it clearly. Just excuse me so that I can discuss this one clearly. I am taking some blank pages. Yes. So in this blank pages, I am discussing here the implied we have already discussed. Now we are going to do the immediate. Okay. So here this one we have already discussed. This one we are going to discuss. Stack is already done. So immediate. Immediate means how? That maybe I have to do add. Okay. Add. Now I am doing here 20. This is your opcode part and this is your operand part. Okay. Now see that this add 20, this 20 is your value. Immediate means this is your value. Means my 1, that is I have to do 20 plus. What is 20 plus? Plus means what? That I will take from the accumulator, because by default whatever operation we are doing, that is we are doing in accumulator. Accumulator is a special type of register where we are doing operation and where we are storing the result also. If one operand is mentioned, then another operand will be in accumulator. So that's why now CPU will understand that 20 is my value. It is my immediate value. And I will do the operation with the accumulator value. Maybe in accumulator there is 30. So it will be 20 plus 30, that is 50. And this 50 will be also stored in accumulator itself, because the result is also storing in accumulator. This is called the immediate. And try to recall what was the implied. What was implied? Implied was there was nothing mentioned. It was only the instruction like complement accumulator. This instruction is itself telling you that what you have to do. There was no value, nothing. Here you can see the extra part is there. The extra information is there. In this type, the no extra information required. Implicitly it is telling. That is the difference between implied and immediate. I hope it is clear to you. Now the next one is that the direct. So see, here direct, indirect, register indirect. You can see this 4. So actually what is that? Actually I told there is 2 types of memory. One type is means storage, where the computer is storing. 2 types of storage is there. One is memory and another is register. So there is a register set, that is user, where user can store, and the memory means here the memory, there are some memory address will be there. In the memory address, maybe this is 2000, then 2001, then till this memory address are there. And register set means there are some name of the register, like maybe there is register 1, register 2, register 3, register 4. In that way some user defined register are there. So here when you are doing any operation in memory, that is normally called the direct, indirect. When you are doing operation in register, that is called the register. Okay. Now we will learn what is direct and what is indirect. What is the difference between register direct and register indirect? See that. First of all, I am telling direct. Direct means what? It can be like that. So we are dividing into a memory direct and another is that register direct. Okay. So memory direct means I will do same one, that is add. So it is my opcode. In the instruction there are 2 parts. this is my opcode, and this is my operand. Here also in the register there is also one opcode and another is operand, right? So see, add 2000. If I am giving, what is this 2000? This 2000 is telling you it is not a value. Previously here we have done in the immediate, it was a value. This 2000 is not a value. This 2000 is telling you you have to go to the memory address 2000. This is the memory location, and here the address is 2000, means you have to go to this location, and maybe here it is given 50. So your operand value will be 50. And what is your effective address? Your effective address is here 2000. 2000 is your effective address from where you get the value, and 50 is your operand. So you will get here 50, and maybe in accumulator some value is given 20. So you will do here 20 plus 50, that is 70. This is called the direct. Direct means here one memory reference. If here in the we are doing one memory reference in the direct. Register. Now when you are coming to the register, so register can be written like that: add R1. Add R1. What is the meaning? This is telling you that R1 is a register. In a register set there is a register R1, and in the R1 what is the value? Maybe the value is given here 20. This 20 is my value. Means what is your effective address? Your effective address is here R1, and what is the value? Value is 20. So maybe in the accumulator also there is 20. So I will do here 20 plus 20, that is 40. So got it? What is the difference? This was the memory reference, memory, and it is a register. It is telling the register name. You are going to the register and you are taking it. This is the memory direct and register direct. Now we are coming to the indirect. Indirect. Register, again also there we are dividing into memory indirect and register indirect. So see, I am taking same example. Same example means that is add 2000, and here I am telling add R1. Now what is this? Indirect means here there is two memory reference, and here one register reference plus one memory reference. What is that? This is telling you that this 2000 means again you have to go to the location 2000, memory 2000. Okay, I will come to this location. Now this is here also, maybe it is given 5000, means now I have to go to the location 5000. Maybe this is my location 5000, and here maybe some value is 40. So this is my value and this is my effective address. That is two memory reference we are doing. So effective address is here 5000. This is your effective address, and what is the operand value? Operand value is 40. And same way, maybe in the accumulator the value was maybe here 20. So we will do here 20 plus 40, that is 60. Okay, so a main target is that what is your reference, how we are doing reference. So it is two memory reference. Here it is doing one reference, and after that another reference. Finally we are getting this one. Now in the register set, when we are doing R1, so see that here is the register R1. I will come to this register R1. In the R1, maybe here given 1000. So then I will go to the 1000 memory location. Here in the memory location, maybe this is my 1000 location. So I will go to this 1000 location, and maybe it is here 50. So my effective address is coming 1000 and operand value is coming 50. Got it? So here one register reference, that is in this R1. After that, whatever value is given, that value is telling you the memory address. So we are coming to this memory address. This is register indirect. I hope it is clear. Please let me know in the comment section that it is clear or not. So till now we have discussed all, that is direct addressing mode, indirect addressing mode. It is actually the memory, it is also the memory, and here register direct, register indirect. Last these four you have to remember, these three you have to remember same way. Relative, index and base. What they are doing, they are adding some extra. Adding some extra means it will add some extra value with the operand field, relative, index and base. So I am writing here, that is relative, another was index, another one is base. Sometimes base is telling displacement also. This is telling sometimes displacement also. So here what we are doing, here I am taking the instruction, that is add maybe same 2000. Okay, this is my instruction. This is my opcode part and this is my operand part. Okay, so now what I will do in index and what I will do relative, what I will do base. So with the operand part, we will add something extra. What I will add? Here this is doing the operand value, whatever given in the operand, plus the value of the program counter. Here this is doing operand value plus the value of the index register. Here this is doing operand plus value of the base register. Okay, so now what will be the value of the program counter? Program counter is always taking the address of next instruction. Always program counter will be taken address of the next instruction. How I will get it? Maybe your current instruction is given, it is a 2-byte instruction, because 1 byte there will be opcode, another byte there will be operand. So maybe here it is running from maybe 4000. Okay, so 4000 and 4001 means your opcode is here in 4000 location and your operand is here in 4001 location. So here is your opcode and here is your operand, right? My next instruction will be this. So next instruction location will be 4002, means your program counter value will be 4002. Got it? So in the program counter, what is the value? 4002. Program counter always storing the address of the next instruction. Remember that. So you have to check it. What will be the address of the next instruction? After that what it will do? So in the operand field, what it is value? Value is 2000, means it will do 2000 plus here it is getting the program counter value is 4002. So here your answer will be 6002. That is your effective address. Your effective address will be 6002, means I have to go to 6002 location. Okay, got it? You have to go to 6002 location. Got it? Just wait 1 minute. I am coming. Sorry for the disturbance. You know that I am a housewife and I have some responsibility. So I am not stopping this video here. I am continuing. So here 6002 is my effective address. You got it, right? Now where I have to go, that 6002 location, and there may be some value is given, that will be my operand. So my operand will be here 40 and 6002 is my relative address, that is I got in relative. Now what to do in index? Index register is, maybe there is a index register, it will be given to you. What is the index register value? Maybe in the index register value it is given 200. So just directly you will do the addition. So what is the operand? Operand is 2000 plus in index register there is 200. So I will do 2200. Got it? Clear? So this 2200 is your effective address. So maybe here is 2200, this location. I will go to this 2200 location, and here maybe the value is 30. So the value will be 30. Now the base register. So here it will be mentioned also base register. Maybe base register value is 400. Okay. So what I will do? Operand there is 2000 plus the base register value is 400. So I will do here 2400. So maybe this is the location 2400. I will go to here, and maybe the value is here 50. So 50 will be my value. So my effective address I am getting here 2400. I hope this is clear. When you will learn in comparatively, then you can remember this is the mind mapping. Relative, index, base or displacement, these are actually relative means operand plus program counter value, and index plus index means index register plus operand value, base means base register plus operand value. So these three we have already done, right? See that the relative, index addressing mode and base addressing mode, this three is done. Now the last two is auto increment and auto decrement. So auto increment and auto decrement, here very important thing, remember that auto increment is post increment and auto decrement is pre decrement. Why I am telling this? Please be careful, I am telling you. So see, here I will do the auto increment and the auto decrement. See, here same way there will be some register set will be given. Okay, auto means that is a specific register set will be given. From the register set there will be some register name will be given through which you will get the value. Okay, so maybe there it is given add R1. So from the register set R1 you have to go to R1 location, and whatever value is given you have to work on it. This is the way of auto increment and decrement. Now in the R1 maybe the value is given 2000. That is the value. So my R1 register value is 2000 when you are doing the auto increment addressing mode. What I will do, auto increment will do that it will go to the 2000 location only. Effective address will be 2000 only. There will be no change. But why the name is auto increment? Because after fetching the location, so there is the memory. Same way there is the memory. Means in the memory it will go to the 2000 location and it will fetch the value. The effective address is 2000 only. After that this will be incremented. After that this value will be incremented. How much incremented? That is depending on the size of the data. This is depending on the size of the data. So what is the data size? Maybe data size is 2 byte, then it will be incremented by 2. Data size is 1 byte, then it will be incremented by 1. Got it? Means now if I am taking 1 byte, this will be incremented 2001. Now in the R1 value is 2001. Got it? But this 2001 will be useful for the next instruction. This is not useful for this instruction. Current instruction for the auto increment, no extra for calculating effective address, no extra information, means no extra ALU operation is required. I will show you the question there. From this concept, question is already asked. So for the effective address, we are not doing any calculation. After fetching the effective address, after getting the value, we are doing increment of the register. Got it? Now the auto decrement. How the auto decrement is working? It will do fast decrement. It will be decremented by the size of the data. So maybe the data size I am taking 1. So now here same one if I am taking. So current value of R1 is here 2001. Okay, this is 2001. See that. So now it will be decremented. How it will be decremented? 2001 minus 1, that is 2000. So now again it is decremented to 2000. Now my effective address will be here 2000. Okay, so see that this 2001 was not useful for this one, but maybe just next we took the auto decrement, then we are decrementing, then after that it is fetching the address. So that's why I'm telling auto increment is just like post increment. After operation it is post, and this is pre decrement. First do the decrement, then get the effective address. I hope it is clear. Is it clear? Auto increment, auto decrement. I hope this is clear to you. So finally we have done all this auto increment and decrement, all this addressing mode concept is very clear. Now do the question. From the question your concept will be more clear. Just read the question, try to solve it. I will request you that try to solve this question by your understanding. It will be better. Don't watch the solution first. Read it, do it. After that, check the solution. Okay. Yes. Now I am telling. See that what it is given in the question. The first part here. Consider the 16-bit processor in which the following appear: main memory starting at the location 200. So memory, here is a memory. Then and there, draw that. There is a memory 200 starting at 200. So the first part of the first word indicates the instruction, load and value in the accumulator. So there is the, in the 200, there is the instruction it is given. The mode of field specified the addressing mode, if appropriate, indicate the source register, assuming that when used, when it will be useful, then we will go for the register. So source register is given here R1. R1 value is given 400, right? There is also a base register. Base register value is also given. So now one base register is given, that is also given 100. The value of 500 location is the value of 500 in location 201. So in the location 201 there is 500, means you got your, actually you got your operation. Here is the opcode and here is the operand. Operand value is 500 actually. Opcode is in 200 location, operand is in 201 location. So this is your actually total operation, right? Now this is useful for the address calculation. See that. Now assume that 399, so the location 399 contain that 999 and the location 400 contain 1000. That is given, and so on. And so on means the remaining value you have to fill. How? That is 401 will be 1001, then 500 will be definitely 100, 1100 and so on, means in that way you have to fill. Why it is required? Because it will be required to do this. Okay, now do the effective address. It is asking effective address and the operand. So first of all, direct. So direct one. So now see, I have filled this one. This is your instruction opcode. Here this is one, this one was given. So it is actually your instruction and opcode. This is in 200 location and this is your 201. So my next instruction is this. So from the next instruction, I got the value of program counter. Program counter value is 202 because program counter is taking the instruction of taking the address of the next instruction. And I fill the remaining part also in that way because this location will be useful. Why? I am telling it. See that. First one is direct. Direct means what? Here it is 500. So means I have to go to 500 location. That's why the 500 was required. So for the direct means 1. For the direct is, what is my effective address? Effective address will be 500. And what is my value? Value will be 1100. Right? Effective address is 500 and this is my effective address and this is my value. Okay, now the next one is immediate. Immediate means telling you immediate value. This value is actually your immediate value, means your operand is itself 500. So what is your effective address? From where you get that 500? It is stored in 201 location, right? It is stored in 201 location, means here your effective address will be 201 because it is the immediate value itself. So answer of B will be this. Next one is indirect. Indirect means to memory reference. So for the indirect, 500 was given. I have to go to 500. After that, in the 500 there is 1100, means I have to go to 1100. So my effective address will be here. For that effective address will be 1100 and what is the value here? Value is here 1700. Right. This is for C. Now D. Now come to the D. What is D? D is PC relative. PC relative. PC relative means what we have to do? The address part plus the program counter value, right? In the address part, value is given 500 plus the program counter value we got 202 because the next instruction. So it will be 702. So my effective address will be 702. I have to go to 702 location and what is the value here? 1302. So 1302 is my value, that is the operand, right? Value I got. Now what is there in E? So E is there, see that E is here displacement. What I told, displacement means base register. So the base register value is given 100. It was given base register value. So base register value is 100 and here value is 500. 500 plus 100, that is 600. So displacement effective address will be 600. I will go to this location and here this will be my value, that is 1200. Right. Now next one is my register. Register. So there is a register R1 only. Register, only register means what is my effective address? I have to go to R1. This is register direct. Register direct means what is the effective address? Effective address itself R1. And what is the value? Value is 400. Register R1 and value is 400. So R1 and value is 400. Now next one is register indirect. Register indirect means I will go to register Then what is the value? Then I have to go to the memory. So here is the register value, then I have to go to the memory. So one register reference plus one memory reference for the indirect. So that's why here it will be 400, the G is 400 and 1000, right? That is my register indirect. And finally, auto indexing with increment using R1. We are using R1 for the auto increment. So R1 value is 400 itself. What I told, auto increment means whatever value in the register, that will be my effective address itself, right? So that's why effective address will be same, 400, and I will go to the 400, operand value will be 1000. After that it will be updated to 401. That will be not required for this one. Okay, is it clear? I hope this is clear, and I hope now this is your answer. You can see the answer, you can match the answer. I hope this total addressing mode is clear to you, and there implies where to use and where to use or. You are getting confused, right? So if you are getting confused, then definitely this video is for you to know all the answer perfectly, and not only the correct answer, why the other answer are wrong. You have to understand that also, why the other answer are wrong. Someone will tell you this is correct answer, but you are getting confused, why this is correct, why this is wrong, right? So that's why in this video I will tell you the total understanding from basic to advanced level, all the basic concept. With that we will solve these all question, and after watching that your total concept will be clear from propositional logic and predicate logic, because propositional logic and predicate logic is a very important area from where so many questions are coming. Whatever exam you are preparing, if it is your college exam, UGC NET exam, GATE exam, any other competitive exam, in discrete math, this is a very important subject, and it is related to artificial intelligence also. That's why you cannot leave it. So let's start. Must watch till the end. Don't leave in the middle. If you are living in the middle, then your concept will be not clear. So let's start. So here you can see in the propositional logic, first of all, what is propositional logic? Propositional logic is working with true and false. Yes, there is no middle. How are you? I am good or bad. There will be no answer like that. I am so, it's going on. No. Either yes or false. Either true or false. There will be no in between result. This is propositional logic. So excluded middle means in between anything will be not there. Not false means true, not true means false. And here are some table we have to remember, and these are the table actually just related with the digital logic also. Same thing are here. 0, 0, 0, 1, 1, 0 and 1, 1. That is the OR. You did the OR, right? That is called disjunction. OR means disjunction. AND means conjunction. And we did that. PQ AND. This is the AND table. How this is working? In the OR table, when there was OR table for P and Q, when there is OR 0, 0, it will be 0, 0, 1, 1, 1, 0, 1 and 1, 1 will be also 1. That is the OR. That is actually we are writing in this way. This is the symbol of OR in propositional logic. Predicate law, in here the what is AND? AND is how we are writing AND. Same way, 0, 0 is 0. In AND, when both are 1, then only it is 1. That's why that is true. Instead of 1, we will write here true, and instead of 0, we will write here false. Actually, propositional logic, if you are learning through digital logic concept, and sometimes the problem can be solved, most of the time the problem can be solved in digital logic format also. because propositional logic, this type of symbol, we are getting confused. What is this? What is that? Other than that, if I am writing this one like this way, P bar plus Q, then we are feeling so happy, right? So this is one trick. Whenever you saw the propositional logic question, just change it into digital logic format. Like Boolean algebra, we will solve it. It's very easy for us. So here is something extra also. What is not there in digital logic? That is the implication and the bidirectional. Implication means P implies Q. Means if P is true, then Q is true. Like that type. Means if then, when we are telling if then we will apply the implication symbol. What is then double implication? Double implication is like if and only if. Because when I am telling that if today is Monday, then I will take the class. It does not mean that I am taking class means it's Monday. It can be any other day also. So here the problem is, if I am telling P implies Q, that does not mean Q implies P also. But in double direction means when we are telling bidirectional double implication, then it is actually if P equals to P implies Q and Q implies P, both are correct. That's why if and only if. What is the truth table here? Here the truth table is very interesting. You can see when both are false, means P is also false, then Q is also false. If today is not Monday, I will not take the class. So both are false. That's why P implies Q will be true. Here if P is false but Q is true, it can be happen. It's not Monday but I am taking the class. It is another weekday, Tuesday, Thursday, Friday. It can be any day. I am taking the class. Yes. So when P is false, Q can be true. That's why it is also true. P implies Q. Now P is true, it is Monday, I am not taking class, it is false. Normally it will be false because P is true here, so you have to take the class, right? So that's why it is false. True, truth, always true. When both are true, the P it is Monday, I am taking the class, implies is true here. It implies, implication is true here. So this is the truth table for the implication. What is the truth table for bidirectional? Bidirectional means both have to be same. That's why for false, false it will be true, and true, true also it will be true. These are the main truth table what you have to remember. So it is and, or, implication and bidirectional. Now here is another next important thing, that is P implies Q means what? P implies Q means not P or Q. This is a 5-star formula from where means always you have to apply this formula for solving propositional logic, predicate logic, everywhere. P implies Q is not P or Q. This is, please stick in on your mind, everywhere it will be required. Now the next type of question are coming, what is called tautology, valid, identically true, satisfactory. What is that? I am telling you simply, tautology or valid or logically true or identically true, these all are same. When it is, when all the combination is true, all combination true means any expression will be given to you, like maybe P or Q and P bar, like something. Then if I am telling this two truth table PQ, there are two variables. Using this variable, if I am putting in this expression, if for all combination I am getting true result, all the combination I am getting true result means it is true. Otherwise, another way also we can solve, just by solving the expression. If I am solving the expression P plus Q dot P bar, it is like that. After solving, if I am getting expression giving result 1, then it will be true. Otherwise, it will be false. Means then it will be tautology or valid. What is then satisfiability or contingency? Satisfiability and contingency means when you are solving this expression, if you are getting in the truth table, some of them are true, some of them are false, like this way, combination of true and false, then that is called satisfiability or contingency. When you are solving the expression, you will get a value in a terms of variable. Expression give any value other than 0 or 1 in a terms of variable, like either p, p bar, q or pq or something. It will be not 0 or not 1. It will be in a terms of variable, then it is satisfiable. What is unsatisfiability then? Unsatisfiability or contradiction means when expression gives result 0 after solving. How it is? P dot p bar, but the expression will give you 0. So when you are getting expression result 0, then that is called contradiction. This is simple. Now think, here there are called the disjunctive syllogism and conjunctive syllogism. What is that? Disjunctive syllogism, it is the format of syllogism. What is the format? Here actually whatever given in the upper side, there are two statements will be, these are given true. And in the lower side it is the conclusion. You have to prove that from the given true, is it coming true also? Always. If it is the conclusion coming true always, then we can say it is valid. Otherwise it will be not valid. So you can see here what is going on. P or Q is given true. Means what it is? Actually P plus Q equals to 1. P plus P or Q given true means it is 1. Another one is also given, that is not P is true. So what is another one? Not P equals to 1. So what is P? P equals to 0. So if I put here 0 plus Q equals to 1. So what is the value of Q? Definitely the value of Q is 1. Right? So that's why Q is true. Yes, the conclusion is correct here. And that's why it is a valid one. Same way is there, that is P plus Q equals to 1 given, not Q is 1 given, means Q bar is 1 given, Q equals to 0, so P will be 1. And when I am doing conjunctive syllogism, what is conjunctive? It is given that P dot Q bar equals to 1. P dot Q complement means bar equals to 1. Right? And here the P equals to 1. So when P equals to 1 and its bar equals to 1 means what? Actually PQ equals to 0. So why it will be 0? Then Q bar is true means Q bar is 1 means Q equals to 0. So Q equals to 0, that's why PQ equals to 0. This is the conjunctive syllogism. Something is given to you, from the given thing am I getting the conclusion? If I am getting the conclusion, then that is called the syllogism is valid here. This is the format. Now we are going to another thing, that these are also three important, most important. P implies Q equals to not P implies not Q. It is inverse, it's not same. It's not same. When I am adding inverse, that is not same. That I am telling that if it is Monday, I will take the class. Not Monday, I am not taking class. No, it can be true. It's not Monday, but still I can take the class. So inverse is not same. P implies Q. I cannot say Q implies P. This is called converse. This is also not same. But the contrapositive, it is same. P implies Q equals to not Q implies not P. That is same. How this is coming? P implies Q means I can write not P or Q. I can write it. Now here you can see, if I am doing this one, not Q implies not P. What it will be? Not Q, because P implies Q is negation. So not Q or not Q. Not P means it is not Q or not P. So double negation means what? That is Q or not P. Now same thing I can write like this, because or see that here if I am writing Q plus P bar, that is same, I can write P bar plus Q, right? So that's why I can write here not P or Q. So it is same, not P or Q, not P or Q, it is not P or Q, it is same, means it is actually P implies Q. So that's why P implies Q equals to not Q implies not P. This formula, that's why every time you will apply this formula. And double negation means the same value, double negation means it will come to the same. So this is a very important, always remember this 3 rule in propositional logic. And these are the rule of logical equivalence. That rule is same as the rule of the digital logic. In digital logic you learn that P dot 1 equals to P, right? And P dot 0 equals to 0. Even also you learn that P plus 0 equals to P. And P plus 1 equals to 1. Anything plus 1 is 1. Right? So that these are the identity law, dominance law, you know that. And idempotent law means when I am doing P dot P, that is P. P plus P, that is also P. These are the law. Double negation, P double bar equals to P. Commutative law also you know. Associative law means what? P plus Q plus R, I can write P plus Q plus R. That is the associative law. Same thing, digital logic, think like a digital logic way. Distributive law and De Morgan's law is very important in digital logic also, in propositional logic also. When you are doing P Q bar, then it will be what? P bar plus Q bar. And when I am doing P plus Q whole bar, then it will be P bar dot Q bar. Right? This De Morgan's law is another one where it will be required for always simplification. And the absorption law is also very important. When I am writing P plus PQ, then it is actually P. P plus PQ. If I am doing P dot P plus Q, then also it is P. P plus PQ and P dot PQ, these are absorption law. So P plus PQ will be P only and P dot P plus Q also will be P only. These are the some very important. And another one, negation, that is P plus P bar equals to 1 and P dot P bar equals to 0. So these are the simplified rule, simplification rule what you have to apply for digital logic, propositional logic, everywhere. Now I am going to solve the question one by one. Please let me know in the comment who are here till now. Write down in the comment section. Yes, now we are going to start the question. Write down that yes, I learned the concept. Now we are going to start the question so that I can understand how many students are actually watching this. Right? So see, here is the question. Consider the following two well-formed formulas of propositional logic. F1, F2 is given. Which one is satisfiable, valid? We have to apply that formula. Which one is satisfiable? How to prove it? Here just same thing we will apply here. I told that, right? P implies Q equals to not P or Q. This is everywhere applied. So here think like that. This is your P, this is your Q. So what it is? Not P or together Q means it is also not P. Now it is what actually? P bar plus P bar. This is actually P bar plus P bar. So your answer will be P bar only. Right? So when it is coming only P bar, it is in a terms of variable. In a terms of variable means what? Is it valid or it is satisfiable? Which one? Tell me. Next one, how to solve this one? P implies P bar. So it will be not P or again not P because it is my P, it is my Q. Here is or, then not P or P. Now P bar plus P bar, it is actually what? P bar plus P bar, that is actually P bar. Or means plus, it is double negation, P double bar, that is P actually. So it is P plus P means P only. So P plus P bar is 1. P plus P bar is 1. So you got here 1. Expression giving result 1, that is what? Yes. That's why it is valid. This one is valid and this one is satisfiable. So answer will be F1 is satisfiable, F2 is valid. Simple, right? Easy. Now do the next one. Now you can do it. Right? You can do. Yes. You can pause the video and you can try. Yes. Let's do. So what is given here? P double implication Q or Q bar. Q or Q bar means what? That is 1 actually. And Q double implication R means in the place of Q I can write R. In the place of R I can write Q. So from here two things I got. In the place of P I can write 1 actually. And in the place of Q R I can write vice versa. Now I need to solve this equation. How to solve? Let's try it. What I am getting. So first of all I will write in the form of digital logic because it is very much good for our eyes. We are very happy. We are feeling very happy because these symbols are really feeling bad. When I am writing in this way, it will be easy for us. So I am writing in this way. P dot Q. It's done. Implication. Here the implication was there. Now after that we will do here P dot R plus S. This is here simple. It's done. Now see that. Can I change anything? Is it possible to change anything? In the place of P I can put 1. So in the place of P I am putting 1. Here also in the place of P I can put 1 plus S. So ultimately what is coming here? Q implies R plus S. That is coming, right? Q implies R plus S. Now can I apply this one as P and this one as Q? I can do it. This one as P. So it is what? Not Q or R plus S. Means what it is? Q bar plus R plus S. Right? Now you can see R double implies Q means in the place of R I can put Q. That is Q bar plus Q plus S. So Q bar plus Q is what? That is 1. 1 plus S. Q bar plus Q is 1. 1 plus S means 1 plus anything, whatever it is. 1 plus infinite number of terms, infinite number of variable, whatever it is, it will be always 1. Why it is? Because 1 plus 0 is also 1, 1 plus 1 is also 1. Is there any other possibility? There is possibility only 0 and 1. So 1 plus anything is always 1. And that's why for the time of simplification, try to get 1. If you are able to get 1, then you can do 1 only. So that's why this will be 1. And you got your answer. Your expression is giving result 1 means what it is? It is definitely true. Yes. It's very easy, simple, right? Now go to the next question. Here it is, if X then Y unless Z. Think it. You can do. Think it. Yes. So you can see here X and Y implies not Z. X and Z, this one and this one. What is the meaning? Think like that. If X, if it is Monday, then if it is weekdays or if it is Monday, if it is Monday, then I will take the class. Unless I am ill. What is the meaning? It is Monday and I am not ill, then I will take the class. Is it or not? It is Monday, X, and I am not ill, so I will take the class. Yes, it's done here. So, this is your answer. Clear? Clear? Yes. Now go to the next. Yes. So this is the question where you have to do the consider the vocabulary. Here this is what is the model? How many models are there? What is model? What is model? Yes. Model is nothing. Model means if I am solving this expression, how many variables are there? We will make a truth table. Now in the truth table, how many true are coming? That are called model. So ma'am, there are 4 variables. I will create the truth table. That will be very lengthy truth table. It is like that. How we can do in exam hall? No need to do it. How to do? Think logically. Think logically. Here how many variables are there? A, B, C, D. 4 variables. Using 4 variables, how many combination we can take? 2 to the power n combination always. So combination will be 2 to the power 4 means 16 combination. Now think that these all are plus, right? Means OR. In the OR table, what is going on? When all are 0, then only I will get 0. Otherwise, for every combination, I will get 1. That's why I will do 16 minus 1, 15. That is going on here. Because all will be true here. Only when all are false, then only it will be false. So do it logically. Think it logically. Tell me one thing, in this state, if I am doing here and then what will be the result? Tell me in the comment section. Let me know in the comment section. If in this place I am doing like this, then what will be the result? How many models you can create here? What will be the result here? I know, I want to know the comment section. What will be the comment section? Okay. See that here the question number, some different question number are showing because I copy the question from exactly from the question paper. These are the some question of UGC NET, some question of GATE. That's why this question number is showing. No need to bother. Just write down like that. These many models are possible. That is why I can get the answer. Okay. Now here this question. Do the question. Yes, do this. And let me check one thing. Technically, I am thinking, is it recording going on or not? Let me check once. Do it. Let me check. Sometimes I am doing that mistake also, that yes, ultimately recording is going on. Yes, it is getting my voice. Okay, good. So I am right. Sometimes I am also feeling crazy. Okay, do it. So here, do this one. How to do? A person who is radical and electable if he or she is conservative but otherwise not electable. What is there in if? Think it. Yes. The answer will be this one and this one. Ma'am, why this is the answer? Because see that. What is if? A person who is radical. A person is radical, that implies he is electable. So this is my P, this is my Q. So implies, who is implies? The person, if the person is radical, that's why the person is radical, implies electable. Implies electable. There is another condition also, that if he is conservative, that's why if he is conservative, it is actually if and only if. The person is electable, then he is conservative, and conservative means electable means it is radical. So that's why this is correct. Why this is not correct, ma'am? It is telling you the person is radical and electable. That double implication conservative means here it will be a conservative person is always electable and radical. It may not. I told you always that when I am telling P implies Q means it does not mean Q implies P. A person is radical, is electable if he is conservative. So there is a person who is conservative, radical, that person is electable. That does not mean that every conservative person is electable and radical. That's why this is wrong. Now ma'am, how to get D? D, see that it is actually the implication going on here. What is the implication going on? R implies E, double implies C. It was there, right? So R implies D means this is your P, this is your Q. Inside the Q, what it is? Double implication means E implies C and C implies E. That is the meaning of double implication. And outside there is R. So it is your P, this is your Q. Means not R or this part. Again, this will be not R or this part. So it is actually the expanded format of B. That's why answer will be B and D. Clear? I hope this is clear. Now see that here it is another question that f equals to x. Some of my friends are not perfect. Some of my friends are not perfect. What to do? These are actually the predicate logic question. So I am telling you predicate logic. After that we will come to this. And these are some home tasks for you. You can do it. And this is the answer now. Now you can do this question. So this one is a syllogism. Do this one. What is a syllogism? How to prove it? Actually, these are given to you. When these are given, then what will be the value of y? That is you have to do. What is the value of y? P implies Q and R implies S. And it is given that P or R. What is this actually? Not P or Q and not R or S is true given to you. And another one is given that P or R equals to 1. So see that. This total is 1 means this part also have to be 1, this part also have to be 1, because and means when both are 1 then only it is 1. Now when P is 1 then P bar will be 0, then Q have to be 1. When R is 1 then R bar have to be 0, then S have to be 1. So what is the meaning? Either R or S, either Q or S are not Q. Either Q or S have to be 1. Otherwise I cannot get it 1, right? When this part is 0, it have to be 1. When this part is 0, it have to be 1. So that's why either Q or S have to be 1. Yes, got it. Now we will do the predicate logic. In predicate logic there is two things. One is there exist, another is for all. There exist means at least one element is true. Some of them or one element is true. For all means everyone is true. All the students of this class who are watching, they are the computer science student, right? Or they are the mathematics students, can be also, because in discrete mathematics is there. Those who are these, they are the discrete mathematics students. There exist means there exist some students, some are male, some are female. There exist, that is there exist. Some of them, and it is all of them. So all means for all. We are writing in this way. There exist means there exist in this way. Now whenever I am writing for all, there exists, then we are comparing with a variable. X is a variable. That variable will be compared with a domain. That domain is the class. So in this class, all students are discrete mathematics students. In this class, that is PX, some of the students are female. That is the comparison. Always we are comparing with a domain. In the specific domain we are comparing. So now here there are something what we can do. For all means lots of things are possible. All of them, for each, given any, for arbitrary, for each, for any. These all the meaning are actually for all. And we can write like this way. Another one is existential, that is there exist. So for there exist means at least any one of them is true. So many different way we can express that every student in the class has studied calculus. The same thing we can express like that for every student in the class that studied calculus. For every student X in the class, X has studied calculus. So if I am telling Cx is the predicate that X has studied calculus, then how to represent? For all X, Cx. This same thing we can represent in another way if we are trying to do for the total world. For every person X, means any person in the world X, if the person X is the student in this class, then they studied calculus, then they studied discrete math. If I am telling the same thing, we can represent like this now, for all X, if the student, if it is the student of this class, then they studied this calculus, means I can say discrete math also. Got it? So it is a trick. Remember, whenever we are using for all, most of the time for all will be, we can represent in the there exist format, means this implication format. Here only this is the trick. In this trick you can apply everywhere to solve the question. With the for all we can use the implication. And here whenever we are doing there exists, but here with the for all we cannot use the and. We cannot use the and with the for all, because this meaning is different. This statement will say all the people are student and the class studied calculus. All the people throughout the world I am telling they are my student. No, right? That's why with the for all we cannot use and. But in there exist, whenever I am writing there exists, some of the student in the class visit Mexico. Some of the student in this class are female. Then we can say there exists MX. So MX means visited Mexico. This one we can apply and. There exists some, there exists X. They are the student and they visited Mexico. So with the there exist we can apply and. This is the trick. If you are able to remember, then so many predicate logic question will be easy, because here only students are getting confused where to use and where to use implication. Where there will be if then condition, then we will apply implication, and where we are trying to combine two statements, then it is and most of the time with the there exist and will be applied, and with the for all implication will be applied. This is the trick to solve this type of all question whatever I shown you. Now you can see here that is this is when it is true, when all are true then it will be true. When it is false, when any one is false then it will be false, right? There exists when it is true. If any one is true then it will be true. If everyone is false then it will be false. Now see, these are the three very important rules. If I am applying negation with for all px, then this will be changed to there exist and this will be changed to not px. If I am applying negation with there exists, this will be changed to for all and this will be changed to negation. And this P implies Q, actually not for all will be changed to there exist, and this one is changing to and. Why it is? Because just expand it. It is not px or qx, right? Now I am multiplying not, so negation px will be px only, and or negation will be changed to and. When I am negating or, means negation is doing with or, then it is changing to and this will be not qx, and that's why you will get this one. These three are very important for doing the predicate logic, right? So let's do now the equivalence of this one. Just now I told. Yes, you all are correct. Just now we did it. It will be for all and this domain will be multiplied with this one. Now see here, for all x, this one and this one not logically true. This one are not logically true. Which one is correct? Yes, both are correct, because why? I am comparing with this domain. These are the domain of male. So all x are male here, or these are all x are female here. I cannot say there is a specific person I am telling and it is male or female. This is not true. Means this domain, it is according to this domain, this is according to this domain. I cannot say. Maybe these are the computer science student, these are the x are the computer science student, these x are the economics student. Now I am taking a person and I am telling no, it's not equivalent. Here also there exists x, there exists, so I am comparing with this px, here it is comparing with this qx. I cannot say and means both is true. No. These are also actually very important to rule of predicate logic. Note it down. Now we can do the question, some of my friends are not perfect. Some of my friends are not perfect. How to do? Yes, there exists x. They are my friend. They are my friend and not perfect. Ma'am, why this is not the answer? It is telling you for all, it is not some. So it cannot be the answer. Here I am telling not, here is no x. X should be compared with the domain. And this predicate is totally wrong. Here I am telling there exists, they are not my friend. The person have to be my friend. They are not my friend and not perfect. This is not implying this. The person is my friend, then only I can say it's not perfect. It is not my friend. How it is possible? That's why this is wrong. Got it. Now do this. Who are watching till now? Give me comment section. Yes, this time I am here, I am present ma'am, because from a long time I am talking. You are listening or not? Some real number are rational. How to do? Some real number are rational. Some real number. Yes. Some means there exist. It cannot be for all. Now, should I apply implication or and? I told that with the there exist, we should apply and. This trick will be applied. You can see. Yes, there exists x. This is the real x and rational x. Real x and rational x. It's done, right? With the trick, it's very easy. Otherwise, you will think that why it is not. Because there is no if then and there exists, we should not use this. You learn it. Now see, correct formula for not all rainy days are cold. How to do? Not all rainy days are cold. Yes, not all. It's not all. Not all means negation for all. That will be changed to there exist. Not all. Some of the days are cold. Some of the days are not cold, maybe. So not all means that will be there exist. And whenever I am telling there exists, then it is a rainy day. And it's not cold. You are telling here it's not a rainy day. It is not correct. Here I am telling for all it's not correct. It is the correct one. Now the next one. Do this. Very carefully understand it. Tiger and lion attack if they are hungry or threatened. Tiger and lion attack if they are hungry or threatened. How to do? Here you all are doing a common mistake. By looking this and, you are searching the and symbol and you are doing here mistake. Yes, this is wrong. Why, ma'am? Because see that tiger and lion means either tiger or lion, they will attack. It's not like that a tiger is hungry, it will call the lion, lion please come, we should attack. It's not like that. What is the inner meaning? Either it is tiger or it is lion. They will attack if they are hungry or threatened. That is the meaning. Understand the meaning of the student or meaning of the question. It's not and, it is or actually. So either it is tiger or it is lion. If it is, then they are hungry or threatened, then they will attack. Right? Why this is not? Because for all there exists. Attack, then it is opposite. P implies Q does not mean Q implies P. Because they attack, it does not mean they are hungry or threatened. Maybe it is for any other reason. Maybe you are attacking the child of that, or maybe any other reason can be also there. So we cannot say P implies Q means Q implies. That is hungry or threatened, then only. It is your P part, it is your Q part. This one is, that's why not true. And these are too definitely not true. It is not for all or. I am telling here all are or. No, it's hap. If then condition is there. If they are hungry and threatened, then they will attack. So with the or we cannot. Got it. This is a very interesting question. I hope you can understand. Now do this one. Yes. Not every graph is connected. Read the question very carefully. Yes. There was a not. Very carefully check that. It is does not represent this one. Which one does not represent this one? So not every graph means what? That is not for all. Definitely it is not for all. So not for all x. If it is a graph connected, it's true. Not all graph connected. Not for all is changing to there exist, so that's why it is there exist. If I am doing just solving it as P implies Q, then it will be this one, right? And not for all x, it's not a graph or not connected. That is also from here I can implies. But here for all graph not connected. Here I am telling all graph are not connected. No. Not every graph means some of the graph can be connected. So I cannot say that all the graph are not connected. That's why this was wrong. It is asking you does not represent. Means out of them which one is wrong? This one is wrong. That's why answer will be this one. Yes, now this is a very popular question. 2 times it asks in UGC NET. You can see here. There is a country that border of Nepal, India and Nepal. What will be the answer? Think it. There is a country that border both India and Nepal. Yes. There is a country, and with there is, we should apply the and. This trick will applied everywhere. Here it will be no, there exists, it's not if else. There is a country and it is a specific country. That country is the border of India also, that country is the border of Nepal also. Here it is telling there is C, border of country, it's totally a wrong predicate. It is also implies, here implies will be not. With the there exist, it is and. So that's why this is the answer. So it's now end of the class. I hope you understand everything. Predicate logic, propositional logic, how to solve. So many questions we solve there. These are the GATE question, UGC NET question. Most of them are UGC NET question. Some of them are GATE question also. But whatever exam it is, but question are good quality question. And I hope after doing this question, your total concept is clear. So please let me know in the comment section and stay tuned with this channel, and I hope you did not forget to subscribe. So definitely subscribe to the channel. Stay tuned with me to get all this type of video. See you soon. Bye bye. How to identify CFL means context free language. How to identify context sensitive language, and in detail what is the exactly procedure we have to follow to identify irregular language. And in CFL also there are two parts, DCFL, NCFL. How to identify which one is DCFL, which one is NCFL. Next thing is this type of question, how to solve, which one is subset, which one is superset, how to do it from the regular expression. And from this type of question, when it is there, then how to understand how to do it, because it is able to solve using closure property. These are the types of question when they are giving it is which type of language, how we will solve it. This is also which type of language. And here it is a very important chart from where always questions are coming. What are the different types of language, which language is coming under which grammar, and what are the machines supporting by the language, means which machine is able to understand which language. And even also the ordering is very important, which one is higher power, which one is lower power, which one is subset, which one is superset. Students are getting confused here. That's why I will make it super easy. Just continue the watching. And after that, the closure property. Here, ma'am, we are not able to remember it. How to remember? I will give you the tricks how to remember the closure property. And after that, how to solve this type of question. Because they are not asking now direct question. This type of question, union, intersection, how to do. I will tell you easy tricks you can do every question. After that, this is decidability. That is a long chart, lengthy chart. How to remember this decidability chart? And after remembering, how to solve the question, how to apply that chart in the question. That is also we will discuss here. And before starting, if you don't know the basic, that basic is very important. Some important points of basic means what is language, what is here epsilon, what is sigma, what is alphabet, how to create the regular expression, what is the difference between A star, B star, AB whole star, AB star, what are the difference here. And after that, how to design ADFA. These are the some example I provide you so that for your rapid revision will be done. These are the very important DFA what you have to do. These are also I am giving you. But these are the part, this basic part, even also this question is also very important. How to design this DFA, odd, even, odd, all the combination. So if you are not able to understand this part, for that I am telling you, please go to my TOC playlist. I am giving in the link in the description also, and in the top also. Even also you can search the playlist also. In the home page also you can see the TOC playlist is there. I will request you, please watch that TOC playlist if you don't have any basic idea of TOC. Then your basic idea will be clear, and your means you will get the interest to learn the subject, because this is a rapid revision. This is for the students, those who are going for exam. Before exam, it's required. Here, regular. How to understand the regular? Actually, regular language is not able to compare anything. And when it is an infinite comparison, that is not able to do. Means, what is comparison? Comparison means if the number of A equals to number of B, and number of A is greater than number of B, number of A equals to 2B, or maybe number of A equals to B plus 1, like these are all comparison. If it is finite, means there are 5A, 5B. When there will be 1A, then there will be 2B. Like these are there, then it will manage because finite. But if it is infinite, then it is not able to do. What? That's why you can see how to identify regular. Regular means when it is 5, means nothing is there, it's null. Then no problem, it is regular. If it is finite, there is no problem. If it is infinite, then we have to think. You have to ask yourself two questions. If there is no comparison, only ordering, means what? A, after that B, after that C will come. There is nothing like that, how many number of B, how many number of C, how many number of B. No. Just they are telling A, B, C. Or it may be first B will come, then A will come. or only A is there, that is not a problem. And how to do it? Here the power will tell you comparison is there or not. The power. Because here you can see if I am writing M, N, P. These are the different power. Means there is no comparison. But this one, if I am writing A to the power M, B to the power M. It can be M, it can be N, it can be any letter. When the power are same, that is meaning that yes, here is a comparison. Even also, it can be like that. Here is M, here is M plus 1. Here is also comparison. Even also, it can be given like that. M and N, the data are different. But here the condition can be given like that. N equals to M plus N. Then also it is a comparison. So you have to check anyhow two variable are dependent, anyhow the power are dependent, and is it infinite? What is infinite? When the variables are greater than 0, means it is an infinite condition. If I am writing like that, less than 2, less than 10, means it is finite. This is a finite comparison. When I am writing this one, A to the power N, B to the power N, but here it is less than, that's why it is finite. But same thing, if I am writing A to the power N, B to the power N, greater than N greater than 0, that is infinite. That's why this is not possible in regular, but this will be possible because it is finite comparison. Although comparison is there, but it is finite. So this is not regular, but this will be regular. And if there is no comparison means how it is? Just I will write like this, you can see. If there is no comparison, only ordering, then it's confirmly regular. So I hope it's clear. Just let me know in the comment section, yes, it is clear. Next thing, I will go for now how to identify DCFL, NCFL, means how to identify CFL. First of all, you have to think how to identify CFL, that is context free language. What is the full form? Context free language. So as you saw here no comparison was possible, but here at a time one comparison is possible. At a time I can do one comparison. One comparison means power will be same. Just now what I told, here this is A to the power N, B to the power N. This is a power are same and it is infinite. I can do at a time one comparison. Or this type, this is also at a time one comparison. Or this one, it is also at a time one comparison. These all are possible using CFL. Because CFL is using stack. How it will do? CFL is using stack because it will push all the A's. After that it will pop and it will compare with B. That is A to the power N, B to the power N. Whatever number of A's are there, because it have a infinite stack. Capacity of the stack is infinite. Any number of A, any number of B it can take. So it will push it and after that it will pop. That is the mechanism of CFL. Now what is difference between DCFL and NCFL? Difference is there when push and pop is clear. Means by watching you can understand how many A I have to push, after that where to stop and where I can start popping. That is clear to me. But when I am writing this, that is A, B, 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 A, it's very confusing. Here is some A, then B, then again B, then again A. Here machine will be confused where how much I have to push and how much I have to pop. Where to stop? What is the middle area? What is the middle area between push and pop? That is not clear. That is called, we will go for NCFL. Means it is NCFL means non-deterministic context-free language. Now how we will do it? It is possible using push and pop, using stack, but here it is creating multiple copy of machine. Here it is creating single copy of machine, but here it is creating multiple copy of machine. One popular example of NCFL is WWR, means it is actually mirror a word and reverse of the word. You can see here, you can imagine here is a mirror, just ABB, this BBA, means the reverse of the word. That's why this is a very popular example of NCFL. Now see, after that next thing is coming CSL, and another thing also very remember, it is have to be in LIFO order. LIFO order means last in first out. If I push the number of A, I have to pop it. That should be in LIFO order. So I am telling an example of LIFO order. Here is A to the power M, then B to the power M, then C to the power N, D to the power N. You may tell me that ma'am, here is 2 comparison. Yes, here is 2 comparison, but at a time I will push all the A, then I will pop and compare with the B's. Then again I will push all the C, I will compare with D. That's possible, and it is in LIFO order. But if I am telling A to the power M, after that here is B to the power N, then C to the power M, then D to the power N. Is it in LIFO order? It is not in LIFO order, because here the comparison between this A and C and B and D. How I will do it? I will push all the A. After that I have to compare with C, but here is B. What I will do with B? I have only one copy. I have only one machine. Then it is a difficult thing for you. Okay, so this is very important. Now thing is that what is CSL? At a time here I was able to do one comparison at a time, but if it is like that, when it is linear bound automata, here it is using the tape. Using tape it will be able to do when there is more than one comparison, and if it is not in LIFO order. If it is not in LIFO order, then we can do it. Okay, so this is CSG, context sensitive grammar or context sensitive language, means it is able to do more than one comparison. It's done. Now see, now we will go for the question. So let's do some question. After that I am coming here. So here you can see this is a regular expression. How to understand which one is superset, which one is subset. How to solve this regular expression. This regular expression, try it. You can pause the video and you can try. After that you can see what will be the answer. So here it is starting with A. A will be there. After that B or A. What is the meaning of plus? That is B or A. B or A. So A is there. After that it can be, and as there is star, means whenever there will be star, then it can be, you can take it, you may take it, you may not take it. Means it can be lambda. It can be lambda. This understanding if not clear, I am telling you, please watch the recording. Okay, that is the video is already there. So here it can be lambda. So what is my minimum string? My minimum string is A only. That's why A. After that, what are the possible? That is AB, AA, and so on. Means at least one A is there. After that, anything have to be, and it will start with A. Here what it is? here is a plus, means inside the bracket, if there is plus, means it's a mandatory part. And as this is a plus, means either A or B, anything you have to take at least one time. So that's why here minimum letter will be this A is not possible. But here minimum letter will be A, B. Is it possible? Yes. A. Is it possible? Yes. After that anything. That is possible. Now for this one, what it is? Here is A, here is B. Means only one A, not possible. A, not possible. But here it is possible. It is starting with A, ending with B. This one was not possible. This one was not possible. This is not possible. Starting with A, ending with B. In between, you may take A, you may not take A. Because there is the star. You may take, you may not take. So it can be AB. It can be A. After that, so many A, then B. These are the possibilities are here. So you can see now it is very clear which one is superset. Whatever I am able to do, whatever string able to do here in T, that string is already here. But it is able to do something extra, that is AA. That was not possible here. And whatever I am able to generate here, that string is already there. But here is the extra A. That was not possible here. So definitely R is greater than, then S, then to T. So which one is the superset? R is the superset. After that S, then T. That's why your answer will be this one. R is greater than S, then T. I hope it is clear. So please let me know in the comment section. It's clear or not? Now think. Now here this is another one. How to do it? Here this one is regular expression A star plus B whole star, and here it is A plus B. Then which one is correct? Pause the video. Think it. With the same thing, what type of string we can generate? You can see here, as there is star, the star is very important. Whenever there is star, I can accept lambda. After that, A star, any number of A, and or B, it can be B, it can be A, B, and all. Everything I can generate here. This is also, here is lambda. After that A, then B, then AB, and any number of AB. No problem. So ultimately this is also giving you any combination of A or B. This is also giving you any combination of A or B. That's why both are same here. Ultimately both are same here. Don't be confused. Don't think that as ma'am here is A but here is A star. Why? Same thing. Lambda is accepted here, right? Because of a whole star is here. Repetitively I am telling, if you are not getting what is the meaning of star, whole star, plus, please watch the video. The video is already there in my TOC playlist. Please watch that. Now think what we have to do, how to do this one. This one I am coming little bit later, because this one you will be not able to understand now. Do this one. Try to understand this one. How to do it. Here, this one is, which one is correct? All are telling you, all are asking you context free, context free, context free. Means ultimately I have to understand which one is context free and which one is not. What I told, when there is comparison, at a time one comparison, then that is context free. And when there is at a time more than one comparison, that is not possible. And you have to check the power. You can see here all the power are same. This all the power are coming same. N plus M, right? You can think like P. So it is ultimately A to the power P, B to the power P, and again A to the power P. Number of A equals to number of B, and number of B equals to number of A. That's why it is CSL. It is not CFL. So it is not CFL. Now the question is with this one. Is it CFL? Is it CFL? See that what is going on here? Number of B and number of A, it's equals to this number of A. Means ultimately I can represent like that. A to the power 5 if I am writing. This is B to the power 3. This is A to the power 2. Like that. 3 plus 2 is 5 and this is 5. How can I do it? Yes, I can do it. A, 1, 2, 3, 4, 5, 5A, then 3B, then 2A. It's ultimately like that. I will push all the A's here because all the A's is ultimately equals to this one plus this one. That is also 2 comparison, 1 comparison. I will pop 1 by 1A and I will compare with this all. That will be done. That's why it is also CFL. So L1 is CFL but L2 is not CFL. So your answer will be this one. Now see, next thing. Next thing is L1, L2, L3, L4. These are 4 languages. From these 4 languages, you have to understand which one is CFL or not. That is ultimately asking CFL. Because questions are coming from CFL only. All your question will come from CFL only. This is the fact. Now see. Pause it and tell me in the answer. What you think? Think it. Think it fast. Pause it. Think it. Then check the answer. Yes. So see. Here you will think that only this one is CFL. Because here I equals to J. It is your known thing. Yes. A to the power n. B to the power n. It is like that. So I will do it is CFL. But these are not CFL. What I told. Comparison means not only equal to, guys. Comparison means not only equal to. This is a common mistake of all the students. You are thinking that comparison means only equals to. No. Comparison means it is a not equals to, that is a comparison. It is 2j plus 1. This is also a comparison. It is not equals to 2j. This is also a comparison. So these all are ultimately comparison. And that's why at a time one comparison, this is also CFL. All are CFL. Be careful. With this one example, your total concept will be clear how to understand CFL. Video I am going to discuss about this type of question. In this type of question, they are asking that this is the NPDA or PDA will be given to you, and after that you have to identify what type of language will be accepted. So actually students are getting confused here because your concept is not clear. So I will explain in a easy way, and after watching this video there will be no confusion in push down automata. So must watch this video till the end and definitely subscribe to the channel. Click the bell icon to get all the latest update and notification. So here how to do it. See that to understand this transition, first of all you have to go to some basic understanding of PDA. What is PDA? PDA is actually push down automata. So this is a one type of machine. As we saw, the finite automata is there to understanding the regular expression. In finite automata, you saw there are some number of states. We are taking some alphabet and we are going to some state. And I will suggest you, if you did not watch my TOC playlist, then definitely go through my TOC playlist. From the basic, some videos are there, you will understand that and it will be helpful to you. And I am uploading the TOC videos here. So now push down automata. Push down automata is actually required to understand the CFL language, that is the context free language. There are two types of push down automata. One is DPDA, that is deterministic push down automata, and another is NPDA, that is non-deterministic push down automata. The difference is there in deterministic, and both are using stack. We have to use stack here. Here is the stack and it is the infinite capacity stack. Problem on finite automata was there. It was not able to do the infinite comparison. Means what type of comparison? That is a to the power n, b to the power n. If n is greater or equals to 0, then this type of comparison was not possible in finite automata. That number of a, what is the meaning here? Number of a equals to number of b. This was not possible in finite automata. That's why we came to push down automata. Push down automata have a infinite capacity stack, and through the stack it will be able to understand the language. Actual, what is the how it is working? First of all, you have to know that. After that, I am coming to the states and all, so that you can get some interest here. Just see that if I am taking a to the power 3 and b to the power 3, how it will work? It will work simply. A, 3a is there. After that, 3b is there, right? Means number of a and number of b are equal. So it will push the all a, after that another a, after that another a. Then it will pop 1a, it will compare with b, again it will pop 1a, it will compare with b, again it will pop 1a, it will compare with b, and ultimately at the end, if the stack is empty, then we will say that yes, it is accepted. This is the ultimate funda here. This is the ultimate concept here. And there are two ways of acceptance, that either through the empty state, or I can reach to the final state also. Each and every machine is accepting the language if it is reaching to the final state. Means as per the finite automata, we saw that final state is double circle. When we are able to reach to final state, means the language is accepted. So this is also another way. If after doing push and pop operation, after that doing the comparison, if finally at the end of the string you reach to the final state, means it will be accepted. Okay. So now here is a difference, because the problem is that here I have to work on stack. In finite automata there was no stack. So in transition function, how to write the transition function, that is actually the problem, because in this question you can see the transition functions are given. So if you are not able to understand the transition function, then you will be not able to do the question. So that's why here, first of all, what are the, how to define a PDA? You can see Q is the number of states. Means in this question it is given Q0, Q1, Qf. These are the three states are given. So in this question, these are the three states, that is Q0, Q1 and Qf. Three states are given to you. Sigma is the input alphabet or symbol. So here is the sigma. This is your sigma. A and B are the input alphabet. Okay. So Q is here. These are the number of state. And next one is sigma. This is the input alphabet. Next one is the tau. tau is the set of push down symbol which can be pushed and popped from the stack. Means for push and pop operation, after push or pop operation, we will use some symbol, extra symbol, what are not using in alphabet. These are the some extra symbol we are going to use here. These symbols are 1 and Z. You can see this symbol. Actually, these are called tau. So here you can see this is the tau. Next one is the Q0 is the initial state. So yes, we can see here this is Q0, it is the initial state, and Z is the initial push down symbol. Means actually when we are going to start the work, so Z will be the initial symbol in the stack. This will mention that it is your initial state, that is Z. And QF is actually the final state here. Okay. Other than that, here it is the Z is the final, F is the final state. It is mentioned. Now I have to understand that transition function. How the transition function works. How we should write. We are writing transition function in this way. Q. There is the symbol. We are taking a symbol, that is sigma or epsilon. Then we are reaching to another state. It will be more clear from here. Actually, we are writing this transition function like this. You can see this transition function. What we are writing? P, then B, then T. After that, we are writing W and alpha. What is the meaning here? The meaning is here, this implies that while taking a transition from state P, means I am in state P. In this P state, it's not Q, I am in P state. In this P state, I am going to Q. When I am going to Q, this is my current state and this is my next state. When I am going to the next state, if I am getting the input symbol B, if I am getting the input symbol B consumed and the top of the stack, now currently in the top of the stack, there is T. So this is the condition here. Top of the stack there is T and I am taking the input B. Where I am in the state P now. In this situation, where I am going to the state Q, and another some extra work also I am doing here. I am going to the state Q, and what is the meaning of W? What is the meaning of W here? Actually, we are going to insert W on the top of the stack. Means when I am getting P, when I am getting B, I will insert W in the top of the stack. That is the meaning. Got it? Is it clear? And is replaced by the new string this one. This is replaced by the new string this one. That is the meaning. Now see. Now come to the original question and try to understand what is going on here. So first of all, Q0. When I am in Q0 state. And what is the situation? This is the situation that in the top of the stack there is Z. And what is I am getting input? I am getting input lambda. Lambda means actually no input. It is a length 0 input. That is, we know from the finite automata concept also what is lambda. If you don't know that, then please go to my TOC playlist. So I am getting lambda. Means actually nothing, no input. Then what I am reaching? I am reaching to final state actually. From Q0, if I am getting lambda and top of the stack is 0, then I will reach to final state. So QF is my final state. So I will directly reach to the final state in this situation, and top of the stack will be as it is, that is Z. So we are not going to insert anything. We are not going to push anything into the top of the stack. This is the meaning of this transition. Now what is the meaning of the next transition? So next transition meaning is like this. If I am in Q0 and at that time, this is actually not alpha, this is A. Okay, here is, don't be confused, it is A. In this Q0, top of the stack is Z. If I am getting A, if the input is A, Now I will go to Q1 state and I am going to insert 2, 1. Now what is the meaning of 2, 1 and Z? The meaning is that previously there was already Z in the top of the stack. It was there. Now I am going to insert 2, 1 here. So for 1A, I am going to insert 2, 1 in the top of the stack. That's why now in the top of the stack there is 2, 1 and Z. That is the meaning of this line, that yes, you are going to Q1 and now in the top of the stack there is 2, 1 and Z. So 1A, if in Q0 for 1A you are getting 1A, you are inserting 2, 1. Now what is the meaning of third line? Now I think you can understand what is the meaning of third line. When I am in Q1 and if I am getting again another A, then what I am doing? I am actually coming to Q1 only. I am not changing my state. And here I am inserting again 2, 1. Because in the top of the stack there was already 1. This 1 was already there. Now I am inserting again another. So already I got one input A. For that I insert 2, 1. And another A if I am getting, then I am inserting again 2, 1. So that's why we are writing here 3, 1. It was already 1 was there, and after that whatever I am inserting. That's why here it is written 3, 1. That is the meaning. Now after that in this Q1, if I am getting B. Now if I am getting B, what I am doing? I am there in Q1 only. I will be there in Q1 only. And after that, what is going on? What is the meaning of this lambda? Lambda meaning is actually we are going to pop. Either it can be epsilon or it can be lambda. This meaning is actually I am doing a pop operation. I am not doing any push operation. I am doing here a pop operation. This is the meaning of this lambda. Lambda or epsilon. If lambda or epsilon anything is given, the meaning is I am doing here the pop operation. So means but I am going to pop, and always pop operation is always a single operation. You can pop from the top of the stack. So for this 1B, I will pop 1, 1. Means in the top of the stack there was 1. That is I can do if I am getting B. And the last line is Q1, from this Q1. So here, last line I am explaining, after that I am coming to the option. Q1, if I am getting lambda means actually nothing. Lambda means actually nothing. If I am getting lambda, with the lambda, then I can reach to the final state. From here, I can reach to the final state actually by lambda. And if the top of the stack is Z. But till now, my top of the stack is not Z. My target is how I can do the top of the stack Z so that I can reach to final state and I can accept the language. So to do it, you can see there are more 3, 1 are there. So how I can pop this 3, 1? From this transition, actually I can pop this 3, 1. That if I am giving another input B in this Q1, if I am giving another input B, then this 1 will be pop. If I am getting another input B, then this 1 will be popped. If I am giving another input B, this one will be popped. And now if I am getting the Z in the top of the stack, now Z is there and lambda means there is no input, and after that I can reach to the final state, means ultimately this string is accepted according to this given machine, right? So now check the option and tell me the answer, what is correct. Is it a to the power 2n b to the power n? Is it a to the power n b to the power 2n? Is it a to the power 2n b to the power n? Or it is a to the power n b to the power 2n? What is this? And here actually you will see that these are same, ma'am. No. Here it is n is greater or equals to 0. Here is n greater than 0. This is also very careful. So I am telling you one thing. Here you can see it is actually a to the power 2. means there are number of A is 2 and number of B is 4. Means what it is? It is very clearly it is A to the power n and B to the power 2n, because for every A I am inserting 2 1 and for every B I can pop only 1 1. So for 1A I have to put 2B, then only I can pop. So that's why always number of B will be double of number of A. Now is it greater or equals to or greater? It will be equals to 0. N equals to 0. What is the meaning of n equals to 0? When I am writing A to the power n and B to the power 2n and n is greater or equals to 0 means it can be possible A to the power 0, B to the power 0 also, because I am accepting n equals to 0. Means why? Because here you can see the first transition was there. If there is lambda, A to the power 0, B to the power 0 means what? That is actually lambda. A length 0 string means lambda. No A, no B. Number of A is also 0. Number of B is also 0. No A, no B. That is actually lambda. So with lambda I am able to reach to final state. So it is accepting lambda also. As it is accepting lambda, that's why n will be greater or equals to 0 and your answer will be this one. Your answer will be not this one. Both are same. You can see A to the power n, B to the power 2n. It is also A to the power n, B to the power 2n. But answer will be this one because it is accepting lambda according to this one. Other than that, you can see, yes, it is working for each and every A. I am inserting 2 1 in the stack and for each 1 B I will pop it. And in this way, this is working. I hope you can understand it. And if you understand, then let me know in the comment section. Now see, we are coming to the closure property. Next topic is closure property. How to remember the closure property. You can see so many areas you will get a long list of closure property that is not required to remember. If you remember this, that is enough for you. How to remember it? Just in the exam hall, write down first of all the operation. What are the operation? Union, intersection, complement, then concatenation, then star, then plus. This way, remember it. Union, intersection, complement, concatenation, star and plus. Now, regular, all are closed. What is the meaning of closed? Closed means that if you are doing a language with operation, whatever operation you are doing with another language too, then the same language will come. Means if you are doing regular, union, regular, then it will be also regular. Regular intersection, in regular, it is regular. Regular complement, it is regular. Regular concatenation, regular, it is regular. Regular star, it is regular. Regular plus, it is also regular. That is the thing. After that, next, DCFL. So when you are coming to DCFL, you can see it is only closed under complement. Remember only the exception. That is DCFL only closed under complement. Remember only that, all other are no. Now, CFL is not closed under intersection and complement. Write down that CFL means it is ultimately NCFL. Don't be confused, okay? NCFL and CFL. NCFL is the higher one and that's why it is not closed. Right? Next thing is CSL. CSL means that is context sensitive. So it is also all are true. So CSL and regular both are closed under all. Here also you can see recursive also under all. Easy. And here DCFL and the recursive enumerable is just opposite. Here it was yes, here it was no. Other than that, these are no, here these are yes. These are no, these are yes. So easily, what is the coming? regular, then CSL, then recursive. All are closed under, all operation, everything. Next thing is DCFL. DCFL is closed only in complement. Remember only that. Then only CFL, that is not closed under intersection and complement. And after that recursive enumerable, that is also not closed under only complement. Just remember the exception. Other than that all are easy. In that way, if you are remembering, then all the question will be easy for you. I hope it is clear, and please practice it every day. This is very, very important chart. Now see that. How to solve it? Which of the following is true? Pause the video and try to recall. Here this is the option 1, option 2, option 3, option 4. Which one is correct here? Yes. So answer will be definitely this one, because the union of two context-free language is context-free, because you can see, and whenever it is asking context-free, definitely go for this table, don't go for this one. Don't do it. Context-free means definitely go for this one. If it is specifically given that DCFL means deterministic context-free, then only go for this one. If it is given context-free, then obviously go for this one. Don't do that mistake. So under union, it is closed. It is not closed under union. Why? Because when you will do DCFL union DCFL, then it may come to NCFL. That's why they are not closed. Okay, that is the meaning. But when you are doing DCFL, NCFL or NCFL, NCFL, it will be always under NCFL, means it will be under CFL. That's why this difference is here. So always remember, when there is CFL, context free they are asking, then always go for this one, don't go for this one. So under union, CFL is context free. This was not correct, this was also not correct, this was also not correct. Intersection, no. Clear? Now for this type of question, how to do this type of question? That is, here is regular language, CNF, something is there. How to do it? How to do it? It is easy thing, I am telling. Whenever you will see union or intersection is there, always go for the higher one. Always go for the higher one. Now how to remember which one is higher, which one is lower? For that, here remember it, the order. Recursive enumerable is the topmost. After that, recursive. Then CSL. Then CFL. And actually NCFL. Then DCFL. Then regular. This is the ordering. So means you can see here, actually recursive can complement. Whenever you are doing the recursive complement, what is this? Recursive under complement. It is recursive because it is yes. Yes means if you are doing complement of recursive, you will get recursive only. That's why it is coming recursive. Union, recursive enumerable. The higher one is recursive enumerable. That's why answer will be recursive enumerable. Now it is CFL. Under complement CFL we don't know actually. Under complement it is what is it is not closed. But here is a question mark. Definitely here is a question mark. But which one is higher one? Recursive is the higher one. So that's why we will go for the recursive. Here regular star. Regular under star it is regular. Intersection CFL. CFL is the higher one. Answer will be CFL. It's easy, right? So that's why your answer is this one. I hope it is clear. Write down in the comment section. Now the last thing here, it is decidability chart. How to remember the decidability. Achha, before coming to decidability, I told you this one I am coming later. That is this one. This chart. That is I just now I told which one is higher one, This is, you can see recursive enumerable, after that recursive, then CSL, then CFL, then DCFL. CFL means it is ultimately NCFL and regular. And these are the machines also very important. Regular is able to understand by finite automata. And remember one thing, DFA, that is deterministic finite automata, and non-deterministic finite automata, they are both same power. But NPDA, DPDA power are different. Always NPDA is higher than DPDA, because what are the means, when push and pop is not clear, that is able to understand by non-deterministic push down automata. That's why this is higher. And DPDA, that is deterministic push down automata, it is lower power. So that's why they are not same. LBA is more higher. Halting Turing machine is more higher. Turing machine is more higher. Okay. And remember one thing. Whatever DCFL means, when you are coming to this DPDA, DPDA is able to understand CFL, and means NPDA is able to understand NCFL. NPDA will be able to understand DCFL also. It is able to understand regular also. So means, if question is asking that NPDA, it is able to understand which type of language, it will be able to understand NCFL, it will be able to understand DCFL, it will be able to understand regular. So all the higher power machine, Turing machine is able to understand all these ultimately. But opposite is not true. Means when you are telling finite automata able to understand only regular. They are not able to understand the higher one. How to remember? Just remember that a class 1 student can solve the question of class 1 only. He will be not able to solve the class 2 or class 3. But a class 4 student will be able to solve the class 4 question also, class 2 question also, class 3 question also, class 1 question also. So when your class is more, you are able to solve the down class also, right? But you cannot solve the upper class. If you are in class 3, you can solve class 2, class 1. You will be not able to solve the question of class 4. So that's why, just see that LBA, all the lower one I can solve, higher one I cannot. Halting Turing machine, all the lower one I can solve, higher one I cannot. Remember in this way. That's why all regular language is CFL also, but all CFL is not regular. And this is your subset and superset. Type 0 is the superset, then type 1, then type 2, then type 3. Remember this is very, very important. Okay. And what can be done by finite automata can be done by PDA also, and vice versa is not true. Clear? Remember it. Achha, now I am coming to the decidability. How to remember the decidability? See that in the decidability chart, here the first of all problem you have to remember. What are the problems are there? Problem is, it is called membership problem. What is membership? Any word is belongs to that language or not. Means take a word like that, AA. It is belongs to the language A, B star or A plus B star. Is it or not? That is called membership. Membership means W belongs to that language or not. L equals to null. L equals to null. Null means what? That is it a phi? The language is phi or not? That is called emptiness problem. L equals to E star. E star means actually all possible combination of your alphabet. That is meaning, right? Sometimes we are writing like this way also. That is sigma star. Means when I am telling that A and B all possible combination, is it supporting by the language or not? That is called the completeness. Next one, L1 equals to L2 is same or not? Just now we did an example, that is A plus B whole star equals to actually A star plus B whole star. Both are same. This L1 and L2 was same. This is called L1, L2 is same or not? Now L1 is a subset of L2. We did here. That was the A, B star is ultimately the subset of A plus B whole star, because here I am taking all combination of AB. That is also we did, right? That is called subset. Intersection is phi null or not. Intersection of two language means ultimately what? That is right, A to the power m, B to the power n, m. Intersection of A to the power m, B to the power n. This is two language. Intersection is null or not. Is there any common part is coming or not? Next thing, when I am coming to this one, so L1 is finite or not? Finite. Is it finite? That is, if I am telling the language L, n less than 10, that is finite. But when I am telling n greater than 0, it's not finite. So is it finite or not? Is complement L of the language same type or not? Means that is same thing. Means when I am writing A B star, what will be the complement? It is starting with A. It is starting with A. Then what will be the complement? It will not start with A. That is the complement, right? So complement is coming same or not. The intersection of the language are same or not. Intersection of two language means that CFL, regular intersection is same or not. It is exactly means some of the concept are coming from your closure property. The L regular or not. Any language is regular or not. These are the problems. Now definitely all this problem, this lengthy chart you will be not able to write down in exam. Here also see that all regular are decidable. Regular is decidable under all the problem. Just all. Next thing, all the exception. This is undecidable under subset problem. It is undecidable under intersection problem. It is undecidable under intersection of two language. Means ultimately you can see where you are comparing two language, that is actually CFL is undecidable. Here CFL is undecidable. Here all this undecidable. You can see ultimately CFL is most of the time undecidable. Only it is decidable under finite or not, and here, that is membership and null. Other than that all are undecidable. So remember only the exception. Remember only the exception. For CSL also all are undecidable. Here is also you can see for CSL this is also undecidable, this is also undecidable. Only this one and this one is decidable. That is complement of language and intersection of language, and this one, that is membership. Exception. REC all are undecidable. Here also undecidable, here also undecidable. Ultimately REC and CSL both are same. REC and CSL both are same. No difference. Both are same. Recursive enumerable all are undecidable. All are undecidable for recursive enumerable. That's all. That's why here you can write like that. Regular, here you can write like that. It's decidable under all. CFL emptiness, where it is decidable. CSL is there, REC is here, and CFL is there. In that way you can remember. Because it's definitely, if you are trying to remember in this total, it is very confusing. Try to remember only exception. Write down the exception list, others are all true. That's done. Now here the question, how to solve the question. It is asking you, which of the problem is decidable under recursive language? Recursive means REC and recursive enumerable means RE. Remember it. It's asking you recursive. Pause the video, try to think which one was decidable under recursive. Yes. So see that chart. Here it was recursable. L is phi. L equals to phi. L equals to phi. It was undecidable here. It is completeness, that is sigma star. Sigma star. It was also undecidable. Next thing. L equals to R. It is a regular or not? Where R is the regular set. So is it a regular language or not? It is also undecidable. Next thing. Membership function. W belongs to L. That is membership. So under membership it was decidable.
under membership it was decidable, and that's why your answer will be under membership it is decidable. That's all. So you have to remember only exception. That is only exception. If you are able to remember, you can do the answer, right? Next thing, L1 L2. Here what is the L1 L2? Intersection phi means L1 intersection L2 equals to phi is undecidable for the context sensitive language. Recall it, under intersection context sensitive, is it decidable or not? And it is ultimately membership problem, context sensitive. So go for context sensitive, right? Check the context sensitive here. What was there under context sensitive? If you see the context sensitive under intersection, it is asking you intersection is phi. So intersection of two language is phi or not. Where it was? That was here. L1 equals to subset intersection of two language. L1 intersection L2 is null or not. That is ultimately L1 intersection L2 equals to phi or not. Under context sensitive it was undecidable. So that's why this statement is true. It is undecidable. And this is your membership problem. Membership problem is decidable. Membership is decidable here. Context sensitive. Whenever you are coming to the membership problem, W belongs to this language, that is decidable. It is W belongs to L. It is decidable. That is also correct. It is decidable. So that's why here your answer will be this one also correct, this one also correct, because it was asking undecidable. Yes, it is undecidable. It is decidable. Yes, it is decidable. Both are true here. So I hope you understand everything. All these are clear to you. Thanks for watching. Join our Telegram channel Unify Study Computer Science, and if you want the paid course, complete course with the PDF, complete PDF of TOC with all the previous year's question in detail, you want to learn, like you want to make the TOC total clear, and not only TOC, total computer science, any subject of computer science. If you are preparing for exam and any type of exam, if you want to crack it, then you can WhatsApp me in this number 8697365460. And it's a request, please don't disturb me, please don't call me unnecessarily, please don't send unnecessary message. If you are really interested to study, then only send me message, and maybe I will try to reply you, but please, it is a request, don't disturb me, please. So if you like this video, then please let me know in the comment section. There's all the other question we did, and here one question was missed, I think. This question, right here. No, this question also we did. One question we missed. Anything question? This question, that was intersection. So how to understand intersection? Because L1, what type of language it is, and it is what type of language? Tell me, let me know in the comment section. Here it is, no comparison is there, it's definitely regular. Here comparison, here also comparison. So which type of language? That is CFL. Whenever you are doing CFL intersection regular, then I have to take the higher one, and that's why it will be context free, not regular. I told you from the closure property also, whenever you are doing intersection, then we have to go for the higher one, and you have to understand the language also. This is comparison, at a time one comparison. That's why answer will be this one. I hope you like this video. 22. Okay, so let's start this discussion. First of all, here the first question, if you come to this first question, this first question is telling you that this is the language given, and from this language which of the string are not generated, which string you cannot generate. So it is the easy way. First of all, you have to think L star means what? L star means what are the string given here in the language. This string I can repeat multiple times. As per my requirement, I will take the string, and if it is required, I can repeat also. So if you go to the option, first of all check that what are the starting of the option.
You can see this is the starting with BAA, means definitely I have to start with BAA, this one. This one is starting with AB, means I have to start with this AB, it is possible. AA is here, I can start with this AA. BA is here, means I can start with this one. Now I will try with one by one option, that is the good way. So BAA I generate. After that next part is AA. Can I generate this A? Yes, from this A I can take this A, no problem. Next part is AB. AB. Yes, AB is here. This one I can take AB, no problem. Last one is AA. Again AA. So this A I can repeat. Again AA I can repeat this A. But after that one A is remaining here. Now I cannot take any 1A because there is no string available which will give me only 1A. And you can see that after checking only the option A, it is not able to generate, and that will be your answer. But option 2, just I am showing you option 2, it can be done. AB, after that AA, if I am generating this, so AB I will take after that AA. Then can I generate BA? BAAA. So I can take BAA. So BAA. 3A. After that AB, I will take this AB, it's possible, and after that finally AA, it's possible AA. So these are just like a game of kids. Just play the game and it is easy, right? So that's why your answer will be this is not possible. Next one is consider the production rule for the grammar and which of the language L generated by the grammar G. This is the question. Now how to do this question? For this type of question, what to do? You can try for the minimum string. Which is the minimum string you can generate from this grammar? That is the best way. So how I can do the minimum string? First of all, I have to start with S. S is doing A, B, B. Now this small letter is the terminal, capital letter are the variable. Now this variable I need to replace with a terminal, and I will try that this is the A production. This is taking A, capital A, B, means it is a repetition coming from this capital A. For this B also, B, capital B, it is also repetition will come. But here the terminal I can see lambda. So means A can also be replaced by lambda. B can also be replaced by lambda. Lambda means actually it is the length 0 string, means ultimately only B is coming here. So my minimum string is only 1B. Now come to the option. Now in this option, if you see that A to the power n, B to the power m, n greater or equals to 0 and m greater than n. Now just you have to check, see that all are actually A to the power n, B to the power m. This is not your means problem. Problem is ultimately in the condition. You have to think about the condition. So you can see n is the power of A and m is the power of B. As you can see, only one B is possible. So definitely m will be greater than n. It's clear, right? Because when I am taking A to the power 0, B to the power 1, that is actually I am getting B, right? So your n can be also 0 also. It can be greater or equals to 0 also. From here I can see that it can be greater or equals to 0. And m have to be greater than n. It is also very clear because I am getting this B. How? A to the power 0 means no A, and B to the power 1 means actually 1. Don't do that. A to the power 0 means 1. It is not the mathematics, okay? A to the power 0 means number of repetition of 0. A is 0 times. A to the power 1 means number of repetition of A is 1 time. So I am taking only B, means number of repetition of A is 0. So A can be 0, means n can be greater or equals to 0, right? But m cannot be 0. M have to be greater than 0. It is sure. Now check the option and you can get the answer very easily. Yes, this will be your answer. N is greater or equals to 0 and m should be greater than n. That is only we came to the conclusion, and your answer is this one. It's easy, right? Next question. Consider the language a to the power n, b to the power m. Now, n greater or equals to 3, m less or equals to 3. n greater or equals to 4, m less or equals to 3. Now from here, which of the regular expression represent the language? So after this question, now you can definitely try this question. You can pause the video and from this try to generate the minimum string. Which is the minimum string? Try to generate it. After that, check it. Are you able to do it or not? That will be better. So now see, a to the power n, b to the power m. n is greater or equals to 4 means ultimately n value minimum you have to take 4. m is less or equals to 3. Less or equals to 3 means it is maximum 3. So minimum I can take anything. Is it or not? It is maximum 3 means minimum I can take anything. Minimum means I can take 0 also because m is less or equals to 0. Now what is this? So b0 means I will not take any b. a to the power 4 means there are only 1, 2, 3, 4 a is possible. 4a have to be there. This is your minimum string. 4a have to be there. After that you can take any number of a because after that if I can take a to the power 5, b to the power 1. I can take a to the power 6, b to the power 1. I can take a to the power 5, b to the power anything. b to the power 2 also possible, b to the power 3 also possible and b to the power 4 not possible because n is less or equals to 3. So minimum is 4a. 4a is minimum. After that, after 4a I can generate 5a also. 1, 2, 3, 4. After that any number of a I can take. That's why this is mandatory. After that any number of a I can take, that is a star. And what are the types of b you can take? So here I am not taking any b. Means this part is actually lambda. So with this 4a, after that I can take any number of a. Then I can take lambda, that is no b. I can take 1b. I can take 2b and I can take 3b. This is only possible. There is no other possibility. Any number of a after 4a, you can repeat any number of a. Then either I will not take any b, I will take 1b, I will take 2b or I will take 3b. And plus means this is or. Plus means or. This is telling you or. So definitely my answer will be this one. There is this 4a is mandatory. After that a star, that is any number of a you can take. Then lambda plus b, bb or bbb. That will be your answer. I hope you can understand. Now see. Now in this question, the reduced grammar equivalent to the grammar whose production rules are given below. What are the production rules are given? See this production. Now after that you need to do the reduced grammar. Reduced grammar means what? Reduced grammar means which part is actually not required. That is also you can remove. That is called reduced grammar. So from here also you can try that what are the strings are actually generating here. And if I am removing someone, after removing that also, can I generate the same thing? If I am able to generate the same thing, then it will be my reduced part. And here options are also given to you. And from this option, you can try that yes, which one I can remove. Starting is doing with AB and it is CA. After that B. B is BC, again AB. A is coming to small a, C is coming to AB and small b. Now this is the best way to go from the option and get the answer. You can see this option. Why I can see the first option, why this is correct? Because A is taking with CA, then CA I can replace with A and C I can replace with B. Why it is? Because what string you can generate? If you see that A, if I am taking AB, if I am taking this AB, then what is this? After taking AB, A can be replaced with small a it's okay. After that, B have to be replaced with either BC or B can be replaced with AB again. So B will be again repeated because there is no terminal for B, and it will be a repetition. It is ultimately coming to recursivity. You will be not able to end the string, right? So using this production, I am not able to end it. But if I am taking this CA, using that, you can see here that C have a end terminal also, A have a terminal also. Using this string, actually I can generate with C, I can replace with B, C can be replaced with B, A can be replaced with A. After that, it can end. So means with this production, I can end with BA. It is possible, I can end it. But with this AB production, I cannot end. So that's why definitely from here, I can remove this AB and I can take this CA. That's why I am removing this part. And after that, actually what will be required? The C will be required and A will be required. So that's why I will take A and I will take C. And from C also, this production is also the repeated production. Here also it is never ending production. If I am taking from C, A, B, again this B will be repeated. So it will be never ending. So that's why I can remove this one also. And after removing this one, I will get this production. This is the way how you can get the reduced grammar. Equivalent to this grammar, because ultimately from this grammar, others are repeated. Only this is only possible through this production. So this production actually giving me value utilization, and that is my reduced one, and this will be my answer. Now next one. This is actually the question from type list. But at the type 0, type 1, type 2, type 3. This is the area from where always you will get the question, and this is very important area to understand the grammar, language, machine. So for that, this chart is always helpful. Those who are connected with me, you know that always I am giving you this chart, and this chart is very helpful chart. Regular language can be understandable. It is recursive language. It is not regular. Recursive language, recursive enumerable language, this one. This is recursive. This is context sensitive, context free, DCFL and regular. You will start from here. Regular, then DCFL, then CFL, then CSL, then recursive enumerable. Recursive enumerable is the highest power. Recursive enumerable is called type 0. Recursive enumerable and recursive together is type 0. CSL is type 1, that is called context sensitive grammar. CFL and DCFL, it is actually NCFL and DCFL. These are called context free grammar. Okay. And the regular is regular only, that is called type 3. So type 0, type 1, type 2, type 3. These are the grammar according to the language. Now what are the machine? Recursive enumerable can be understandable by Turing machine. Recursive halting Turing machine, context sensitive LBA, linear bound automata, context free NPDA, deterministic push down automata, that is DPDA, and non-deterministic push down automata, that is NPDA. And it is finite automata, that is regular. And the highest power machine is always Turing machine is the highest one. And here the power are the DPDA and NPDA, the power are not same. But DFA, NFA power is always same. And according to the subset, superset, if you are thinking, type 0 is always the superset, then type 1, then type 2, then type 3. And all regular language is CFL, but reverse is not true. Regular will be CFL also, but CFL cannot be always regular. So these are the very important chart, must go through it. Always you will get one question from this chart, and that's happened here. Yes, type 0 is what? Type 0 is recursive enumerable, and recursive, that is coming under Turing machine. That's why Turing machine is the answer.
Type 1 means that is context sensitive grammar. This is linear bound automata. Context sensitive grammar means linear bound automata. You can see here. Type 2 is push down automata. There are two type of push down automata, NPDA and DPDA. Ultimately these are push down automata. And type 3 is finite language, finite automata, that is regular language. So this is the final answer. Now here the question was from the closure property. Next important area of TOC, from where you will get always question, and you can see the question is here in 2022. These are the 2022 question. So you can see here the CFL is closed under homomorphism. CFL is closed under complement. For that you need to go for the chart, and this is the very important chart for you. And how to remember this chart? Easy thing is go for only the exception. These are the exception that I have marked here. Only remember the exception, and that is easy. Regular is closed under everything. Closed means what? Actually, if you are doing operation of one regular language with another regular language, what are the binary operation and what are the unary operation like clean closure, clean plus, means with a language I am doing plus, with a language I am doing star, with a language I am doing complement. So if it is a regular, if I am doing the operation, then I will get regular only, and for all these operation it is closed. CFL is not closed under intersection, set difference and complementation. Only these three it is not closed. That is only enough to remember. DCFL is closed under, it is closed under only these two. And CSL is not closed under homomorphism and substitution. And CSL and REC, that is CSL and recursive, are both are actually same. Recursive enumerable only not closed under these two, other than that all are yes. This is only you can remember. And as per the question, CSL, it was asking CFL. So see that CFL, actually CFL means it is NCFL. So under homomorphism, it was asking you under homomorphism it is closed. CFL is closed under homomorphism. Yes, that is true. CFL is closed under complement. That is false, because you can see under complement it is not closed. Only in these three, intersection, complement and set difference, it is not closed. Other than that all are closed. So homomorphism, from here only you can do the answer, and this is not closed, so it is false, and this is true. So your answer will be statement 2 is false and statement 1 is true. Must remember the closure property chart. It is very important. Next one is this one. This is actually came from decidability chart. Consider the properties of recursive enumerable set, finiteness, context freedom, emptiness. Which one is true? So which one is decidable and undecidable? You can see here, this is the decidability chart, and you have to remember the decidability chart. Here also this is the trick to remember decidability chart. These are the all problems. So many problems are there under decidability, but regular language is decidable for all. DCFL is not decidable under this two and this one. CFL is not only decidable under this two and this one. Only go for the exception. CSL decidable under this one and this two, and actually CFL and REC here also actually both are same. That is only you have to remember. For closure property and decidability, CSL and REC both are same. And regular means recursive language, REL, that is recursive language, is undecidable under all. For all this problem it is undecidable. So that's why your answer is very easy. All this problem it is under recursive enumerable, it will be not decidable, and you can easily go for the answer, because you know that recursive enumerable is everyone is undecidable, and that is your answer.
So I hope you can understand this. Layers. What are the layers? In the WSI layer, there are the 7 layers. In the TCP/IP protocol, there are 4 layers. But what are the layers? So think like that. You are the sender. You are sending an email. There is the email. You are sending the email. That email is received by the recipient. Maybe it is the receiver. Now, whenever you are typing the mail, means from where you are typing, maybe you are using your application, mail server application, that is Gmail. Normally we are using the Gmail. So through the Gmail you are typing the mail, right? That is the application layer. Means through which specific application, if you are using your phone or laptop, that is the device. But in the phone and laptop, you are using a specific application to writing the mail. That is the application layer. Next one is presentation. Presentation means whenever you are writing the mail, you are using some color. You are using some format, some heading, some body, and sometimes capital letter, small letter. You can use some smileys. You can attach some image. You can attach some PDF. This is the presentation of the mail, how you are presenting. That is the work of the presentation layer. Next one is session layer. So whenever session means without internet connection, you cannot send a mail. Why? Because you have to connect to the server, because Gmail server is there and you are doing from your home, means you have to connect with the Gmail server. How you are connecting with the Gmail server? Through your login user ID and password. Whenever you are logged in to the Gmail server, means you are connected with the Gmail server. Whenever you will log out from the Gmail server, means your session is end. Without successful login, you cannot send the mail, right? So that is the session is created for you. Then only you can send or receive any email. This is the purpose of the session layer. Next one is transport layer. So you have created mail, you have connected with the server, and you already send the mail. After sending, means it is out from your mailbox. Now it is transporting through the network. Then your from where you send the mail, the receiver will receive. Means it is transport is going on. Next one is the network layer. In the network layer means there are different network. From your network it is going to another network, then it is going to server, from the server again it is going to another network, middle network, finally it is received by the receiver. So there are different network. It have to be travel through different routers, switches, gateways, so many things are there, right? Now come to the data link layer. Data link layer and the physical layer means actually the physical level when it is coming to your network, means in your router it is coming, and after that it is coming to your laptop, your mobile, your application. So it is the in physical layer it is going on. And same way, whenever it is transmitting, it is starting from the application layer to the physical layer, and again one by one from the physical to application. Finally receiver is receiving. This is the way of transmitting message data through the network, through the layer, different layer. And here you can see the software layers are application layer, presentation layer, and the session layer. These are the software layer, and transport layer is the heart of the WSI model, and network, data link, and the physical layer, these are the hardware layer, right? And sender is from here in this direction, from application to physical, but receiver is receiving from physical to application. This is your quick revision note. And here comparison between WSI and TCP/IP. Whenever you are comparing with WSI and TCP/IP, then you can see here are 7 layers, but there is 4 layers. How we are doing it? Actually, WSI is a theoretical concept and TCP/IP is the practical implementation. So application, presentation, and session, as the all are the software layer, this all the software layer is combined and totally we are telling as application layer in TCP/IP. Transport layer is same for both application for OSI and TCP/IP. Both transport layer are same. And finally, network layer is also same because that we cannot change. Again, the hardware level, that is the data link and physical, is combined together, and here we are telling it's network interface. So remember that this is very important to remember actually what is the comparison between the OSI and TCP/IP. Now come to the different layer. Now the functionalities will be very clear to you, and what are the data name. These are very important. These are the functions, these are the data name, and these are the example. If it is asking website, then you have to go for it. That is where application presentation session. If it is asking about TCP/IP, then you can see all are the application layer here. Transport is transport, network is network, and this is the network interface. But the functionalities are actually same. So in the application means user application like the Gmail, SMTP. SMTP is the example, that is simple mail transfer protocol. Here the name of the data. Why the name are changing? Actually we are sending data, but different layer to layer we are calling it in different name. These are the different name layer wise. So in the application layer we are telling it's data. Presentation layer for the data formats, right? It is formatting, means encryption, decryption, how it will be. It is image, GIF, HTTP, JPEG, GIF, HTTPS, SSL. These are the example of the presentation layer, how you are presenting your data. It is the name also data. Next one is the session layer, that is establish the connection, that I already told. It is establishing the connection, right? So it is the data, and here example is net bias and PPTP. Finally, transport layer, that is error handling. In through it is transporting, when it is transporting. So error handling is the main task, and the transport protocol like TCP and UDP. We will learn the difference between TCP and UDP also. Here the data is calling as a segment. This is called segment. Remember that. Next one is the network layer. In the network layer means it is working on IP address, because router to router it is changing, IP to IP it is changing. It is working on the IP address transfer packet from host to destination using IP address. And here we are telling it's packet. So router, 3-layer switches, these are the devices we are using here. Next one is data link layer. In the data link layer, it is actually one hop to another hop in the same network. Here in the same network, one hop to another hop. What is hop to hop? What is node to node? What is end to end? I am coming to this topic. And it is physical addressing. This is the logical addressing, and this is physical addressing. Here we are telling it's frame, and this is the one useful devices are the switches, and physical is the sending the physical, where it is telling bits like the repeater and hub are the devices here that we are using. So our quick revision for different layer functionality, name on the different layer, and what are the example, that is also done. Now I will go to the question. Before going to the question, let's little bit go through the devices, because devices are also very important. Hub, gateway, router, repeater, bridge, and switches. So what are the exactly going on? Repeater is working on the physical layer, because where it is working, that is also remember. It is doing one-to-one port. Repeater means it is regenerating signal. Why? Because when you are sending a signal from a sender to receiver, this type of signal is going on. But as it is traveling for a long distance, then time to time the strength is getting down. Whenever the strength is getting down, then through the repeater it is regenerating the signal so that the strength should be same. That is the working mechanism of the repeater. And here it's called with the signal. It deals with signal. Next one is the hub. Hub is also in physical layer. It is used for broadcasting. There we are using one-to-one because sender to receiver only one port are there. Broadcasting it is using for the beeps, and basically it is a multi-port repeater, nothing else. You can send to a multiple receiver. That is the broadcasting, and main functionalities are same, but here it was one-to-one. This is the multi-port. Next one is the bridge. Bridge means it is just like the bridge. Bridge means from what is bridge? This is a river. From the river you are connecting from the one part to another part. That is actually the bridge, right? Same thing. Same thing in the network also. Send data to the destination using the MAC address. Means you are connecting to the destination through the bit, and this is working on the frame, and here it is using the MAC address. Remember that. Switch is also using the MAC address, and it is store the data buffer. Difference between bridge and switch is there. In the bridge there is no data buffer and there is no error checking. Functionalities are same. Both are using MAC address. Both are useful to send the data to the destination. But here the buffer is there in the switch and the error checking is also there. But in the bridge that functionality is not there. Router is working on IP address. That's why it is working on the network address. There we are telling it's packet, and it is working connected LAN and WAN. Means your local area network is connected with the wide area network, right? That's why it is working with the IP address. Gateway is also in network layer. Here also we are using the IP address and the message. But what is the difference? Difference is when the network architecture is totally different. Gateway is just like the check post from one country to another country. If you are traveling in single country, if you are traveling in India, then there is no problem. But when you have to travel India to any other country, then you have to pass through the check post, right? That's why the passport is also required. And you have to change the currency also, because here whatever currency we are using in other country, currency is different. That's why gateway we are using for different architecture of the network. Totally architecture of the network is changing. Maybe here we are using different architecture, that country is using another architecture. So same concept, one architecture and to another architecture of the network, in that we are using the gateway. So this is the all the difference between all the devices what we are using in the network, and I hope it is clear. Questions are coming from here also. Please don't stop, don't pause. We have to do more tasks. So here it is, you can see the hop to hop. See that hop to hop. This is your phone. Through the phone it is going to next hop, means it is a next router. Again from the router it is going to your mobile. That is hop to hop. What is end to end? End to end means specifically from your mail app. In your device, so many apps are there. You have sent it from your mail app. From your mail app, you are sending a mail to me, to my mail app. My mail application. Like when you are chatting in WhatsApp, your chat should be come to my WhatsApp only. It should not be show in Facebook, right? Because Facebook is the different application, Facebook Messenger is the different application, WhatsApp is the different application. So if you are writing any message in WhatsApp, that will come to my WhatsApp only, not in Facebook or not in mail. If you are sending in mail, so that will come to in my mail application only. That is called specific application to your specific application, means that is the end to end. Got my point? So that's why hop to hop or node to node, that is working with the MAC address. What is MAC address? MAC address is a media access control. So it is the unique identifier assigned for the network interface control the devices. For the specific devices, there will be the unique identification number. Because why? In your home, there are so many mobile. So if my friend is doing WhatsApp to me, it will not come to my father. It will not come to my mother. I only receive that. How I only receive? Because that is the MAC address is required, right? It will not come. Maybe we are using same router. IP is same. You can see the router. If you are using any router in your home, if you are connected with same router, you, your mother, your father, your sister, brother, all are connected through a router, it is the same IP. But the MAC address are different. That's why the router can identify in which device I have to go. Got it? Next one is host to host. Host to host is working on IP address only. Means it will come to your router. After that, router take the decision where I have to send for the MAC address. Right? So that is called the host to host. IP. It is working on the IP address. End to end means IP address plus the port number. Port number is related to your application. From my WhatsApp to your WhatsApp, that is connected with the port number, right? This is called the end to end. I hope it is clear to you. Hop to hop, host to host, and end to end. So now do the question. Try to see the question. This is the question of little bit pause you can take. Read it and do it. Yes. So data link layer, network layer, transport layer, and presentation layer. In the list 2, there is encryption, connection control, routing, and framing. You have to match it. Yes. So say that your answer should be 4. Because why? Because data link layer we are doing framing only, and encryption, decryption we are doing in the presentation layer, right? That is encryption. Encryption is in network layer or presentation layer. Network layer we are doing routing. Transport layer is the connection control, and presentation layer is the encryption only. So that's why we can match it. This is a previous year's question only. Next question. Read the question and do it correctly. Where it is telling end to end. Which one is working in end to end? Yes. Correct. Transport layer is working on end to end layer. Right? Next one. This is Wayside model offers the token management in the session layer, dialog control, token management, and whatever extra. Yes. Yes, that is synchronization only, because you have to synchronize with the server. You have to connect the connection. Synchronization is the part of the session layer also. So next one, from the device. Forward the destination node using base MAC address. Using MAC address, you are transferring the data, which device it is, hub, modem, switch, or gateway. Yes, that is definitely switch, because switch is working on the MAC address only. Right. Yes. And it is next one. TCP IP model. For the TCP IP model, encryption, decryption, it is, remember, it is asking you TCP IP. The TCP IP where the encryption, decryption is working. Yes. So see that actually encryption, decryption in the, it was there in the presentation layer for the Wayside, but presentation application was together, 3 layer are together. We are telling application only in the TCP IP. So that's why your answer will be application layer. Next one, P and Q. Read the statement. Yes. At the link layer, a packet transmitted information called frame, and network layer packet transmitted called segment. Just now we have discussed. Yes. So here definitely only P is true, because segment is telling in transport layer. In network layer, we are not telling it's segment, right? And frame is in data link layer. Link layer means it is actually data link layer. So data link layer frame, that is correct, but this is wrong. So P is only correct. Now here you can see there are some lines That's serial line IP, border gateway, and user data protocol, user datagram protocol, simple network management protocol according to different layer. What will be the answer? Yes, you can match border gateway, border, where we are using border. Yes, border gateway is in whenever they are in the data. Here it is the border gateway will be in the network layer only, because network architecture is changing, then it is only the border gateway, and through that only you can do the answer. No need to do any other things. Right, and UDP was definitely, it is the transport layer protocol. UDP is the transport layer protocol. That is also, you know. And other than that, that will be the answer. Now come to the difference between TCP and UDP. What is the difference between TCP and UDP? Main difference between TCP and UDP is that TCP is using the connection oriented protocol. This is connection oriented. And UDP is the datagram protocol. It is the not connection oriented. It is not a connection oriented. It is here opening a connection, maintaining the connection, that is okay. But to the sender, I am sending the packet. After that, I am not bothered about that you have received or not. That is, I am not bothered about that. Okay. So it is establishing the connection before transmitting data and should close connection after the transmission. But here UDP is connecting also, because without connecting you cannot do. So opening a connection, maintain a connection, and terminate the connection. UDP is efficient for the broadcast. I have sent my data. After that, I am not bothered about anything. I am not reliable that destination it is received or not. That is not bother. But TCP bother about that. So here it is, you can see the difference. TCP provide the extensive error checking mechanism is also there, but here basic error checking is there. And whenever sequence of the data for the transmission in order, it will be in order. But here for the UDP, if the order is required, has to be managed by application layer. Normally it is not managing. TCP comparatively so slow because it have to manage so many things. It is not managing that much thing, that why it is faster. And the lost packet retransmission for the lost packet is possible in the TCP, because it is maintaining the order. Which packet you lost, that packet I can send again, because I am maintaining the order. But UDP it is not possible. No retransmission for the lost packet is possible. Here it is 20 to 60 byte length header is there. So we will learn the TCP header also. And 8 byte fetch packet is there. UDP is very heavyweight. It is lightweight. It does not support the broadcasting, but it is supporting the broadcasting. Some example: HTTP, HTTPS, FTP, SMTP. These are the example of TCP. And UDP, DNS, DHCP. These are the RIP. These are the example of the UDP. So now do the question. Do the question here. What is the difference? Yes. So here you can see TCP handle both congestion and flow control. Yes, it is correct. UDP handle congestion but not flow control, because I am not bothered about that you have received or not. It is not handling. So is it congestion, not flow? It is not doing about, not bother about congestion also, not bother about flow control also. So that's why this one is not correct. This is correct only. Now come to the ARP, RARP. This is also very important. ARP, RARP. What is main difference? ARP means address resolution protocol. RARP means reverse address resolution protocol. Means that it is actually working for the logical address and physical address. Means IP to MAC, MAC to IP. Mapping is IP to MAC address, and MAC address to IP address. So here the mapping maps IP address of the node to its MAC. When you are doing IP to MAC, that is the tasks of ARP. When you are doing MAC to IP, that is the task of the RARP. Remember that, and this is very important. You can go through other chart. It will be useful for you. Now go to the next, that is the question is here. Do the question. Yes. So here it is telling that the message with its MAC address and receive an IP address. So from MAC to IP you are converting, means this is RARP. Right. Now what is the difference between Telnet and FTP? This is also very important. Telnet stands for the telecommunication network and FTP stands for the file transfer network. So what is the main difference? Telnet for use for the chat operation. Here it is for the downloading files. FTP is actually we are connecting, or you can upload, you are connecting to the server, you have to upload something to that server, you have to download something from the server, then we are using the FTP service. So Telnet used for one connection only, and here it is established two connection. Remote login is necessary for the Telnet, but here no remote login is necessary for the Telnet. So normal difference, main difference between Telnet and FTP is this one, and here it is doing one connection only. Here two-way connection is required. And here the no security does not provide any high security for the Telnet, but FTP is providing high security because it is authorized two-way, right? And remote login system, here this is transferring file from one system to another, no remote login is required. This is the connection oriented protocol, and this is also a connection oriented protocol. Next one is DNS. DNS means how whenever you are trying to open any website, example.com is a website. So whenever you are opening that website, then how it is actually working? It is the name of the website, but through the name of the website, how network will understand where I have to go and what is there, from where I have to get the file. That's why it is going to the DNS resolver. Domain name server means it have to find out where the server is for that domain. So DNS resolver is going to the root resolver. Root resolver means is it .com, .in, .org. These are the root. Okay. So .org. Through that route it will be understand, okay, I have to go to that TDL server. Now it is coming to that TDL server. Now after finally TDL server is giving you, okay, example.com is here. This is the IP for that example.com. That is the server. Now it is getting the server. Now it is going to again to your browser, and your browser is connecting to the server. Finally it is getting the data to the server. That is the way how the DNS is working. And here the difference between POP and IMAP. This is also very important difference. POP and IMAP. So POP and IMAP both are using for means mail service actually. These are using the mail service. But POP is the simple protocol that allow the downloading message from inbox to a local computer. Actual main difference is that when you are reading your mail in the server, you are using gmail.com in the server itself, you are reading the mail. That is actually the IMAP. Whatever changes you are doing, if you are deleting something, if you are adding something, whatever changes you are doing, that is affecting in the server main copy. But whenever you are downloading to your local machine through the POP, then it is in your local machine only. That is not affecting in the server. So there are two modes, that is keep mode and the delete mode in the POP. So keep mode means delete. Here delete mode means delete from the mailbox after retrieval. Keep mode means mail remain in the mailbox after retrieval. That you can choose. I have downloaded it, now it will be deleted or it will be keep into the server. Here multiple or redundant copies are there in the mail server. So there is no loss of message. So whatever in the local server you are doing, it will be in the main server for the multiple copy. POP3 mail can be for the single device at a time. That is a problem. If you are using the POP, means in your home computer it is installed. So whenever you are going out, if you are going to your friend house, if you are going to your office, then you cannot access that because it is a single device. But here you can use multiple device because you are using the server. So download in the local system, and here mail read partially before downloading, because whenever you are watching your mailbox, some part is showing, right? This is the mail body, some of the title you can see, right? Even also if there is any attachment before downloading, you can see the body also, and the whatever files are there, that name and something it is showing to you. But here you have to download, after that only you can read, otherwise you cannot read anything. User cannot mailbox of the mail server, that is you cannot, but here you are using in direct mailbox. So this is the difference between IMAP and POP3. Now next one is the SMTP, Simple Mail Transfer Protocol. So for the simple mail transfer protocol, there are mainly two agents, that is user agent and local agent. And here it is using two methods, that is end-to-end and store and forward. This is very important. End-to-end model that used for communicate between the different organization, whereas the store and forward method used within the organization. This is a main difference between end-to-end and store and forward method. So how the SMTP is working? This is actually the sender. After the sender, it is going to the user agent. Then it is coming to send mail queue. Then MTA means mail transfer agent. It is doing everything. Then TCP connection have to be made, because whenever you have to send it to the server, then without making TCP connection, you cannot send it. So TCP connection, after that it is coming to the server, then server is again send it to the mailbox to the user, means receiver, then it is coming to user agent, and finally to the user terminal. This is the working mechanism of a mail transfer, how the transferring mail is going on. Now come to the IS, PAS and SAS. This is very important difference between PAS, SAS and IS. SaaS means software as a service, PaaS means platform as a service, and IaaS means infrastructure as a service. So SaaS, that everything actually they are providing. No need to manage anything by yourself. Here the blue color is telling you managed, and orange color is telling you other managed. So in the SaaS, we are not doing anything. Everything service provider is giving you. So that is everything for the SaaS. But for the PaaS, means they are giving you a platform. They will provide the platform, and you have to manage the application and the data for the PaaS. IaaS means they will provide you only the infrastructure. These are the infrastructure they will provide you, and the application, data, runtime, middleware, operating system, everything you have to manage for the IaaS. This is the main difference between SaaS, PaaS and IaaS. This is the actually cloud computing, means where the service provider is giving you all the access through everywhere you can connect and everywhere you can do your job. It is a server to where you are connecting, and whatever requirement, as per your requirement, you can get it from your service provider. Is it required software as a service? Software as a service means, what are the example? Like when you are using Google Drive, or Google Worksheet, or the Google Word, so online Google Word, Google Excel, Google PowerPoint, these all are the software as a service. Platform means whenever they are giving you a platform, means that is actually used by the developer. They will provide you a platform, a framework. There you can build your own application. And IS means only infrastructure, means your in your home or in your office that much high level configuration is not there, but you need a high level configuration, that infrastructure you need, that high level server you need. So virtually you will be connected with the server and you can do with all the work. So these are the example of SAS, PaaS and IaaS. You can see that Google Apps Engine, these are Dropbox, these are the example. PaaS example are this and IaaS example are this. Throughput, totally confused how to do it. That's why this video is for you, and here I am going to tell you in detail from beginners, means I will think like that you are totally beginners here, and that's why I will explain the concept. After that we will solve this question. Here you can see all this question I am going to discuss here. For this question, 5 question was there. It is actually I took this question from UGC NET 2022. Yes, this question asked on UGC NET 2022. But if you are preparing for any exam, then this question will be definitely helpful to you. So that's why definitely watch the video till the end. Please don't stop in the middle. I saw that it is a habit of some students. They are watching 4 to 5 minutes. After that they are going to stop. Don't stop it. Complete video. If you watch the complete video, after that definitely your all concept will be clear and you will be there will be no scared, no fear. Why? Priyanka ma'am is here. So let's start. Here you can see, before coming to the question, I want to show you some concept that is more required. So that's why I am taking some slides, and let me go to slideshow and let me discuss that concept. This is actually the flow control protocol. In the flow control protocol, there are stop and wait protocol. First of all, there was the stop and wait protocol. And another part is there. These are flow control protocol. And another one, another side is there. This is the sliding window protocol. So how this is working? Main concept, if you know, then only you can relate it. Flow means what? In network some flow is going on. What flow is going on? Actually from sender, here is the sender. Sender is sending some packet to the receiver, right? So whenever sender is sending the packet, it is not a small packet. There are so many parts are there. And it have to load into the channel, means through where it will be like that it is a track. So the track is loading, track have to be loaded. After that track will start the transport, right? So here the concept is coming of transportation time, means actually the TT. TT means transportation, not it is transmission time. So here what is transmission time? This is actually the transmission time. What is that? To load it. How much time it is taking to load the data, that is called the transmission time. Means actually you are loading the data into the channel. This is called transmission time. Now what is propagation time? When you are sending it to sender to receiver, this is called the propagation time. To transfer one bit of data to the receiver, how much time it will take, that is called the TP, means propagation time. This is the first concept you need. Now, how to calculate it? What is the formula for transmission time and propagation time? So, transmission time and propagation time is that when we are doing transmission time, that is TT. TT means what it will be? You are loading the total data, right? Means what will be the total data size divided by bandwidth. Bandwidth is the capacity of your network. Whenever you are in mobile also, it is showing that bandwidth 100 kbps, 90 kbps means what? That is per second time how much data I can load, or how much data I can show, how much data I can download. That is actually your speed. So that's why transmission time means length of your packet divided by bandwidth. length by bandwidth, that is transmission time. Now propagation time, TP. What is propagation time? Propagation time is depending on the, it is length of the packet, okay? It is not length of your your sender to receiver. It is the length or the size. You can write down that here also, length or the size of the packet. TP means it is the distance between sender to receiver, because ultimately I am sending the data to sender to receiver. That's why here the total distance, that is here. So this is the distance between sender to receiver, divide by what? Transmission speed. Here it is bandwidth, okay? Bandwidth is different, transmission speed is different. It is bandwidth. Bandwidth means it is actually whatever bandwidth you have. Speed means in how much speed actually working. So this is transmission speed. These are the two main formula. It is not only for sliding window protocol, for networking numerical always you need this. What is transmission time? What is propagation time? That is the first thing. Now come to this protocol. What was the stop and wait protocol? Stop and wait protocol is like that. Sender is sending some data. Here is the sender. Here is receiver. And sender is waiting for that time when receiver will send the acknowledgement to the data. Means it is the data it is sending. And whenever receiver will send the acknowledgement, after that only it will send another data. So you can see here is a wastage of time. This time is actually wastage. So how much time actually it will take to send the data? First of all, to send the data it have to load, means transmission time, plus it have to send the data, means for sending it needs a propagation time, that is a TP time, and to send the acknowledgement also it's need a TP amount of time. So means it is actually taking TT plus 2 TP amount of time. Now come to the efficiency. What is called efficiency? Understand that also. What is efficiency? Efficiency we are writing like this way. Efficiency means, what is our efficiency? Efficiency means it is the useful work, means whatever actual work you are doing by the total work. Like that, if you are watching my video for 20 minutes, within 20 minutes actually how much you are concentrating and actually how much you are learning. Another time you are looking it but your mind is not there. Your body is here but your mind is moving any other work. So that is useful work by total work. So always ask yourself, are you watching this with a full of concentration or not? Otherwise ultimately your efficiency will be 0. So whatever time you are investing, actually whatever work you are doing, I am learning for 2 hours, but after 2 hours, how much is my output? That is your efficiency. So that's why, see here, actually how much time? Here is a wastage. This 2 TP amount of time is wastage here. Sliding window is trying to, because here this time is waiting. This time, this 2 TP amount of time, the network is waiting. That time sliding window is coming to a smart idea that okay, why I will wait for that time. In this time, when I am sending one part of the one packet, then this packet will go, after that I will receive, and this time is exactly 2 TP amount of time. At that time, if I send more data, if I am sending more data, then actually I can utilize this. and my efficiency will improve. That is the concept behind the sliding window. Sliding window can send, here sliding window there are two types actually, the go back in and stop and wait. Stop and wait, not sorry, selective repeat. Selective repeat. Okay. So go back when, how it is working? Go back in is working like that. N number of packet it can send at a time. And this N is depending on this 2TP. This N is depending on this 2TP, means in this amount of time, how much data I can transmit, that will be in this time. Right? How it is I am telling. And receiver side, it is the receiver side. Receiver side can receive only one packet at a time. That is the main thing here. Now, how to calculate it? See that. If I am telling my TP is 1.5 millisecond. So what will be my 2TP? 2TP equals to 3 millisecond. Right? Now, if I am telling that transmission time is 1 millisecond. So, actually to load this much data, I need 1 millisecond. Now, extra time was 3 millisecond. So, in this extra time, how much data I can transmit? Definitely, in this extra time 3 by 1, that is 3 more packet I can send. So that's why, what will be my window size? Already 1 data plus this 3 data. So 1 plus 3 means 4. My window size, that is N, will be 4. That's why window size is coming 1 plus 2A. It is depending on this. A is what? A is TT by 2TP. That is A. That is A. TT by TP is A. Okay. So now come to here. Now we will discuss the concept. Actual concept is here. Now go to this numerical. Otherwise you will think that okay, ma'am is not explaining numerical. So go to the numerical. Basic concept we did it. Now try to solve. Pause the video and try to solve it, because I already told you the transmission time and propagation time how to calculate. Read the question and pause that. You already know transmission time how to calculate, propagation time how to calculate, what was the formula, recall it and do it. A 300 kilometer long trunk operates at 1.536 Mbps and is used to transmit 64 byte frame and uses sliding window protocol. The propagation speed is 6 microsecond per kilometer. Then what will be the transmission and propagation delay? I will suggest please pause the video, try to do it, and after that let me know in the comment section, are you able to do it or not. Now I am showing you what to do. Just now I told you that propagation is what? Propagation speed, this is given, distance is given, this one, these are your given data. Right? Now what to do for transmission delay? Packet size by bandwidth. So packet size is what? 64 byte. Bandwidth is what? 1.536 Mbps. Now here is a big problem. It is 64 byte guys, and this is 1.536 Mbps. Now always remember, whenever you are doing mathematics, then you need to convert in same unit. Mbps means megabit per second. Small b means that is bit. Capital B means it is byte. And that's why I am going to tell you something. That is 1 byte means 8 bit. Remember. And 1 KB means kilobyte means 2 to the power 10. You have to multiply with 2 to the power 10 to convert it in byte. In byte, it is 2 to the power 10 byte. Okay. Next one, 1 MB means 2 to the power 20 byte. 1 GB. 1 GB means 2 to the power 30 and 1 TB means 2 to the power 40. This units conversion is very important and it is byte. Whenever it is byte you need to convert in bit. After that you have to do it. And microsecond, millisecond, if this is millisecond, that is 10 to the power minus 3 second. You need to convert in second. Millisecond. If it is microsecond, that is 10 to the power minus 6 second. If it is nanosecond, that is 10 to the power minus 9 second. Okay. These conversion are very important. And now MBPS, KBPS, GBPS, these are the data in speed or bandwidth is given in MBPS, KBPS, GBPS. KBPS, when you have to convert in bit per second, means you need to multiply with 10 to the power 3. It is 2 to the power 10 and this is 10 to the power 3. Don't mix up. These are the size of the file. When you are working on size of the file, that is KB, MB, GB, TB, that will be multiplied by 2 to the power. And whenever you are working with speed, bandwidth, that is KBPS, MBPS, GBPS, then you have to multiply with 10 to the power. KBPS, if it is MBPS, then it will be multiplied with 10 to the power 6. GBPS is multiplied with 10 to the power 9. These are very important. Must remember, otherwise you will do mistake always. And that's why these unit conversion students are not doing, and here are the problem. Now come to here. Now so that this byte I have to convert in bit. So I told you 1 byte is 8 bit. So 64 multiply into 8. Now this is converted into bit. MBPS I have to convert in bit per second. That's why I have to multiply with 10 to the power 6. Now this is both are, it is in BPS, bit per second, and upper is bit. Now you can do the operation. Now it is perfect. And now if you are calculating, after calculation you will get 333.33 microsecond. This will be coming in microsecond because propagation delay. It was question was asking in microsecond and we have converted it. Means actually it is converted in second. Your answer will be come in second. After that, as option is asking in microsecond, that's why we are converting in microsecond, because our option is given in microsecond. Here your answer will be come in second. Okay, whenever you are doing this operation, this will be in second. Now second you have to convert in microsecond. How to convert in microsecond? Because already I told you that microsecond means that is 10 to the power minus 6 second. Okay, so you will get the answer and it will be divided by 10 to the power 6 means 10 to the power minus 6. That's why we can say this is 333.33 microsecond. Now see that. Now we will go to the next question. I hope it is clear to you how to do it. Next question is, so your answer will be okay. Another part was coming, another question was that transmission and the propagation delay. So we did here the transmission. Now what will be the propagation delay? Propagation delay already given here. That propagation speed is given here actually. Propagation delay did not given. Propagation speed is 6 microsecond. So what will be the delay? How much delay? Because distance, it is depending on distance. Delay means what? How much distance you are covering. That distance multiply into speed. That is delay. So distance is multiplied with speed. So your delay will be 18,000 microsecond. That is propagation delay. Okay, be careful. Next one. Now this question is asking you the sender window size to get the maximum efficiency. What should be the sender window size? I told you what was the concept of sender window size. That is, I will send some data. After that 2p time, extra time I am waiting, I have to utilize that time. How to utilize? That is depending on TT, that transmission time, actually how much needed, and in this 2 TP time how much data I can send. And that was, what was the formula? Yes, I hope you can recall. Pause the video and do it. Yes, I hope you did it. Now come to the answer. So answer was 1 plus 2a. That was the formula for window size. And what is A? A is TP by TT. That we did there, right? In that time what we can do? Means 2 multiply into 1.5 divide by TT I calculate, right? That was the 3 by TT1, means that's why it was 3 and 1 was extra. That's why we got that 4. That concept is coming here. So TP by TT, A is this. Now put that TP is, but just now we calculate that TP. TP was propagation delay. It is not the propagation speed. In question it is given propagation speed. Don't do that mistake. Last question only we did the propagation delay. That was 18,000 microsecond. So 18,000 microsecond divide by 333.33 microsecond, that is the TT, you will get here 54. A is 54. So 1 plus 2a, whenever you are doing, your answer will be 109, and that is your optimal window size. How to calculate optimal window size? Why this is coming? I hope it is clear. Now remember that. Okay. And don't do mistake A equals to TT by TP. Please no. It is TP by TT, because ultimately we are checking how much time is wasting. Now in that time how much I can transfer. That is TP by TT. Next one. Now the next question is the minimum number of bit required in the sequence number field of this packet. Now what is the minimum number of bit required? This is the concept I am going to tell you, and after that it will be easy for you. See that minimum number of bit. What is the funda? What is the concept of bit? Bit concept is that, see, if I am sending maybe I am sending 8 packet. Okay, so I can send 8 packet. Now it is 8 packet means decimal system we will say 1 2 3 4 5 6 7 8, but this is working in binary. Computer science is always working in binary, so I have to represent in binary, and binary is always working starting with 0. So 8 packet means 0 to 0 1 2 3 4 till 7. These are your 8 packets. In binary, how to represent? Binary representation of 7. 7 means to represent 7 I need 3 bit actually. 1 1 1. That is the binary representation of 7. 0 0 0 0 0 1 0 1 0 0 1 1 and so on. You have to think about the last number. To represent that last number, how many bits are required? For 8 packet, last number is 7. To represent that, I need how many bit? 3 bit. Right? How it is coming? This is actually 8 means 2 to the power 3. That is this 3 bit. This is the 3 bit. If I am telling you I can transfer 32 bit, then 32 packet, then how many bits are required? 2 to the power 5, that is 5 bits are required. If I can say 1000 packet, then how many bits are required? See that. You have to take a nearby value, that is the upper bound, what can be converted in 2 to the power. So 1024 can be converted in 2 to the power, and that is 2 to the power 10. So how many bits are required? 10 bits are required. So now you tell me that what was my packet? How many packet we can send? Just now we did it in the last question. And from here, now you can understand what will be the bit required, how many bits required for the sequence number. Tell me. You can do it. Pause the video, do it, and after that tell me in the comment section. Yes. The answer will be here definitely, as just now we did optimal window size is 109. Means I am able to send 109. My sequence number is 109. So to represent 109, my near about value, I have to take the near about value, right? 2 to the power 6 is 64. It's not possible. 2 to the power 7 is 128. So nearby value means if I am taking 7, then I can represent 128 number. It is 109. So I have to take 7 bit. And that will be my answer. Clear? Yes. Next one is this one. So this is asking you if only 6 bit are reserved. I saw that for my optimal window size I need 7 bit. But I am not able to give you. Means I have only 6 bit only. More than that I cannot allocate. If I am allocating you 6 bit for the sequence number, then what will be your efficiency? If I am allocating you 6 bit, then what will be your efficiency? For 100% efficiency, optimal window size, we did it. Now it is if I am giving 6 bit, then what will be my efficiency? Efficiency was actual work by total work. Right? Yes. Here the answer will be efficiency is sender window size divided by optimal window size. Means actually what I am giving. That is 2 to the power 6 I am allocating you. Means 6 bit means if I am allocating you 6 bit. What is the size? 2 to the power 6. And originally 7 bit was there, means what is the size? 2 to the power 7. So that's why 2 to the power 6 by 2 to the power 7, 64 by 109. Your answer will be 0.587. That will be the efficiency if I am allocating here 6 bit. Now next question. Next question is maximum achievable throughput. What can be maximum achievable throughput? Do it. Yes. Here throughput means actually efficiency multiply into bandwidth. Throughput means actually work, how much work you are doing. With your efficiency, whatever bandwidth is, efficiency multiply into bandwidth, that is called throughput. So efficiency is sender window size divided by optimal window size, that was your efficiency. Now with that efficiency, if I am doing bandwidth, what is my bandwidth? Bandwidth is 1.536 and my achievable throughput will be 0.901. That is my achievable throughput. So I hope these all are clear to you, and 901 is the last answer. This is 0.901. Let me know in the comments different types of operating system, real time, single user, multi-user, multitasking, all the difference will be clear. What is text section? What is data section? What is heap? What is stack? What is the semaphore? Critical section, race condition? What is the difference between long term, short term, medium term? What is demand paging? What is virtual memory? And what is the difference between pager and swapper? What is the difference between logical and physical address? Page table and segment table. What is exact difference between them? Contiguous, non-contiguous memory. What it is going on? What are the working mechanism of overlay, compaction, page table, segmentation table? Everything we are going to discuss today with the previous year's question also. And I will provide you the difference chart. There you will get the very important chart in this revision series. So must watch this video till the end and definitely subscribe to the channel. Click the bell icon to get all the latest updates and notification. This is about myself. I am Priyanka Chatterjee, UGC NET qualified with 99.46 percentile. I have 2 years teaching experience and 5 years industry experience. So stay tuned with this video without any pause. Definitely watch till the end. First topic, do you know that there are 4 types of operating system? Real-time operating system, single user, single tasking operating system, single user, multitasking operating system, multi-user, multitasking operating system. Although it is looking like very easy. But when the question are coming from exam, then you are getting confused. Even also you are not able to relate because nowadays statement type question are coming. And what is actually doing in the test section, data section, heap, stack. So that's why let's start. I am showing you the question. This is the question. You can see, read the question, try to understand the question. If you are able to do, that's great. If you are not able to do, then I am discussing the concept, and after discussion you will be able to do the answer and I will show you the answer also. So first of all, coming to the topic of different types of operating system. What is the difference between multitasking and multiprocessing operating system? So see that multitask means from the name only it is very clear that it is doing multiple tasks. So here multitasking is a logical execution of multiple programming. How we are doing multi-programming. Here main difference is that you can see the CPU here is only one CPU. That the CPU executes multiple tasks. How there is you are opening your browser. Just now you are watching the YouTube. Maybe there in the background Excel, Word, Excel, PowerPoint that is also open and you are playing a song in the VLC player. So these are the different process you are running in your computer. That's why it is a multitasking computer. Now come to the multiprocessing. What is multiprocessing? Main difference is that you can see here are multiple processor. CPU, multiple register, multiple cache. That is the main difference. Here multiprocessing system has 2 or more than 2 processor in the CPU, that increasing the speed of the system. This is the main difference here. Now come to the chart of the multitasking and multiprocessing. Execution is more one task simultaneously you are doing multiple tasks. Here available more than one processor per system and execute several instructions parallelly known as multiprocessing. CPU is one, here multiple CPUs are there. Moderate amount of time it takes less time as there are multiple CPU. You are parallelly dividing the task, parallelly dividing the process. That's why. So here it is doing one by one job by execution time. Here more than one process you can execute at a time. This is a very important difference of multitasking and multiprocessing. Number of user are one or more can be. Here also number of user can be one or more. Here throughput is moderate, throughput is maximum. Efficiency moderate. Here you can see 2 types, single user multitasking and multi-user, multiple user multitasking can be there. Here 2 types is there, that is symmetric multiprocessing and asymmetric multiprocessing. So now come to the difference between real-time operating system, single user operating system, single user single tasking, single user multitasking, multi-user multitasking. See that real time means it is working on really, means when the live classes are going on, that is a real time operating system, means it is real time you are working. So designed for the real time application. What are the example? Because example are coming in the exam, they are asking you that which type of operating system it is. So remember the example, these are the real-time operating system. Write down in your quick revision note also. Single user allows the single user to perform only one task. Only one task, single user, single tasking. Like you are printing a document, downloading an image, these are singly you are doing. Which type? MS-DOS, Plum, Waste, these are the single user, single tasking. Single user multitasking. It allows single user more than one task. How? Microsoft Windows, what we are using now, that is a single user but multitasking. You can do the multiple tasks at a time. Multi-user multitasking, it performs several users. There are several users utilize a program that concurrently running in a single network server. It is single network server. Single network server termed as the terminal server or the terminal client. These are example is Unix, MVS. These are the example of multi-user multitasking. So here there are more difference. You can pause the video and you can read it. Here main difference of multiple tasks are there and time saving. Don't have make changes in the desktop. And one problem is there for the multitasking, that is if the connection to the server is broken. Anyhow, if the connection of the server is broken, then user cannot work. This is a very disadvantage of a multi-user multitasking system. Now, do you know the process memory are divided into 4 types, that is text section, data section, heap and the stack section. What are the exactly working of this section? So let's see that. Here the process and the programming are divided. Why? Because to perform more good performance for the efficient working. In the text section, it made for compiled the program code. When you are writing the code, that is compiling the program code or read the non-volatile storage. Next one is the data section. It is making like global, static, what are the variable you are using. Variable A, B, C, you are writing a program. Then you are storing it, and especially the global data, static variable. These are using in the data section and allocated and initialized prior to executing the main, because whenever you are declaring the global data, static data, it is initializing before coming to the main. That's why it is using the data section. Now where it is the heap section. The heap section used for the dynamic memory allocation. Like when you are managed via the calls or the new, that are the function call are there. So calls, new, delete, malloc, these are the functions are using for the dynamic memory allocation, and we are using heap for that. The stack, when you are using the stack used for the local variable in the function, in any function, when you are using the local variable, that is using the stack. So space on the stack is reserved for the local variable. So anytime statement type question or any matching type question can come from here. So be careful about different section. Now come to the different states. What are the different states of a process? New, ready, running, waiting, terminated. New means just now it is created, that is a new process. Ready means, don't be confused with the ready and waiting. This is very important. Students are getting confused here. Ready is that the process is waiting to assign the processor. Means I am ready to go to school, but till now bus did not came. I am waiting for the bus. Okay. Running means now you got that bus. Now you are traveling. That is the running state. Waiting means, yes, now the bus is waiting in before my friend house. Now I am waiting in the bus. That is the waiting state. So don't be confused with the ready and waiting state. Waiting means already you have done some work. After that, maybe because of some interruption or because of some input output, you are waiting now. The process is waiting for some event to occur. Your friend, the bus is waiting for your friend. That is the waiting. Now finally it is terminated when it is finished the task. When you reach to the school, your task is done. That is the terminated. So here this diagram is very important for the short term scheduling, medium term scheduling. Here you can see from the ready to running, because of the preemption. Whenever it is the preemption algorithm, means you can take a process before ending the task, you can preempt the resources from the process. That is possible only in preemption algorithm. If it is no preemption, then this is not possible from ready to running or running to ready. That is only possible for the preemption algorithm. Remember that. And this is the short term scheduling, and medium term scheduling is that this one is create. So this diagram is very important. Please go through the diagram for your revision. And here now come to the long term, short term and medium term. What is the main difference? Long term is also known as job scheduler, and the short term is known as CPU scheduler. Medium term is swapping scheduler. Got it? And here either minimal time sharing, it is means when it is going for the job, you are sharing the job scheduler. So job scheduling is going on. That's why it was long term. You can see here actually long term is not there. Means you are when it is there are all the queues are there of the process. Now you are handling the jobs. Which job will come? That is the long term. And it is insignificant time sharing order. Speed is less compared to the short term scheduler. Here speed is faster. Here is for the medium term. Allow you to select the process from load to the pull back into the memory. Means it is already loaded. Now it is coming to the memory. And it selects the process that is ready state of the execution. Ready to execution. That was the short term. Here you can see it is going from ready to running. That is the short term. And the medium term was it helps you to send the process back to memory. That was the medium term. It is back to memory. That's why it is the medium term. For the swapping, I am taking this process, I am taking another process. That swapping is the medium term. Next one is context switching. What is context switching? It is the method of store or restore the state. Means context switching means one process was running. Now you are preempting that resources and you are allocating that resources to P2. After that, it is for P3. This is called the context switching. One process to another process, another process to another process. This is the context switching. So store and restore the CPU in the PCB. Right? Now this is a very important revision chart for you. Last minute revision where that starvation, in which are the CPU scheduling where the starvation is there, where there is no starvation, where is the convoy effect is there, which one is good for the real time. So that's why this is a very important chart. Must remember that. Starvation is possible in STF, LTF, priority based algorithm. And
in round robin algorithm, there is no starvation. What is starvation? For a long time I am waiting, but I am not getting chance. Means I am hungry, but I am not getting the food. That is the starvation. But in round robin, why the starvation is not there? Because round robin is dividing into time quantum. After every time quantum, it is giving the chance to another process. That's why there is no starvation. Convoy effect is in FCFS. Convoy effect means if fast process first come first serve. If the fast process is taking 10 hours time, maybe just 10 hours I am taking, so maybe 10 second time to execute. Another small process after that, another small process came, and it will take only 1 minute time, only 1 second time. But because of that convoy, because of previously there was very long processes, that's why it is not getting chance to execute. This is called the convoy effect. Next one is the most suitable scheduling algorithm for the real-time system. Which is the most scheduling algorithm for the real-time system? That is the preemptive priority scheduling. This is preemptive priority because according to the priority we are doing that. That's why it is very good. Whenever any high priority process is coming, then it is getting chance for the execution. That's why it is the best one for the real-time system. Most suitable system for the scheme like time sharing system, that is the round robin, because here in the round robin always they are sharing using the time quantum. And here minimum average response ratio is SJF, shortest job fast, because shortest one is getting the chance first. So that's why response time is take minimum. And minimum response time for the preemptive, that is shortest remaining fast time. So this chart is very important. Questions are coming from here. So remember that. Now do the question. Now after discussion, now this question is very easy for you. That is with respect to the multiprocessor, which is true. Definitely this one will be true because multiprocessor controlled by one operating system. Yes, and the multiprocessor specified to the multiple data and the stream. This is also correct, but here it is given that multiprocessor multiple computer. No, there was not multiple computer. That's why this one wrong. Right. Now here go to the next one. So the next one is telling you the here the process residing into the main memory, ready and the waiting, which is ready and the waiting kept. Right? So you can do it. Yes. So the answer will be ready queue, definitely. Process residing into the main memory and ready and waiting for the execution. That is, I am ready to go to the school. I am waiting for the bus. That is the ready queue only. Here the question was that preemptive CPU scheduling, according to the preemptive, which one is correct? So read it. Yes. Definitely this one will be correct because process switches from running state to the ready state. This is running to ready, ready to running. This is only possible in preemptive. And the process switches from the waiting to ready. This is going everywhere. From a waiting state, it is going to the ready state. In all the processes, it is going on. So that's why this one will be correct. C and D is not correct. Now come to the CPU scheduling algorithm.
Linux, where we are using Linux. So here in the chart it was there Linux operating system is which type of operating system? Primitive scheduling, and it is a time sharing operating system. So Linux is a time sharing operating system. Now come to the process synchronization semaphore. So it is a question of semaphore. Pause the video, try to do it. If you are able to do, very good. If you are not able to do, then I am here to explain. Next question is that is for the cooperative process, which model is correct. Next one is for the mutual exclusion, which one is correct. This is for the reader-writer problem, which one is correct. So let's do the topic, then only you can solve this type of question. Process synchronization, cooperating process means what is cooperating? I am cooperating with you, means like a friend you are working, cooperating process, right? So process that can affect or affect by other process. When you are doing some work, I am doing some work. So if I am lagging, then it will affect to you, or if I am helping you more, then it will affect your, then our productivity will be more. It is the cooperating. Independent means there is no dependency. I am working like myself. There is no dependency on you. What is race condition? This is very important topic. What is race condition? Race condition is that the several process access and manipulate the same data when you and me are using a same data. Like in our account there is 100 rupees. You want to get that data, maybe you want to withdraw 50 and I want to add 50. Okay. Now in the same time, if it is executing, it depends on that order. Which order? If you are retrieving fast, then there will be 50. That is 100 minus 50 will be 50. If I am doing fast, then it will be 150. So what will be the value of that variable? That is depending on the order. If P1, I am P1, you are P2. P1 is doing 100 minus 50, that is 50. If you are doing 100 plus 50, then it will be 150. So it is depending on the order. Which one is executing fast? That is called a race condition. If you are executing fast, then another result is something else. If I am executing fast, then result is something else. Means it is depending on the order. That is called the race condition. What is critical section? Critical section means it is the common segment where everyone is using the common segment. Now to avoid the problem of the race condition and the critical and other problem, we are using the critical section. That segment of code, changing common variable, updating table and writing. So here we will use the critical section. So at a time the synchronization problem will not come. You are also accessing, I am also accessing, my update is lost, your update is lost. These are the problem can happen. So in the critical section, we are not allowing at a time multiple users who are coming to write. That is we are going to discuss now. And now we are using the variable semaphore variable. This semaphore variable is using for synchronization tool. This is the synchronization tool to deal with the critical section. How? The semaphore variable is a two types of semaphore variables are there. I am going to
discuss how normally, what is the guard against the race condition. Because the race condition was, it is depending on order, that's why the guard against the race condition is that process at the time variable count and process by the synchronization some way. So how to do the synchronization? Here you can see it is the entry section, critical section, exit section. Means there will be some condition checking. Before entering to the critical section, there will be some condition checking. If the conditions satisfy, then only it will get the chance to the critical section. Otherwise, it will not get the chance. So, we will apply that condition according to our scenario, what we want to do. So, here there is the mutual exclusion, progress, and bounded waiting. These are the requirement solution for the critical section. What is that? What is mutual exclusion? Mutual exclusion means if a process PI executing in critical section, then no other process will come. So if I am not allowing anyone, then how the race condition will happen? How the problem can be there? So at a time, one is coming to the critical section, one is doing updating, writing, whatever it wants to do, it will do it. After that, it will exit from the critical section, then only other process can come. So there will be no chance of race condition, there will be no chance of like any false update or lost update. This type of problem will be not there. Next one is progress. What is progress? Progress means maybe there are two processes, P1 and P2. So your condition should be like that. Maybe I am telling I am not interested to go. There is only one washroom. So in that washroom you are sharing a room. So there is only one washroom. So it should not be like that. I am allocating the time for 6 to 7 a.m. is for you. 6 to 7 a.m. is for you. 6 a.m. slot is for you and 7 a.m. slot is for the P2. Now maybe at the time of 6 a.m. there is some urgency of P2, but P1 is not interested to go. P1 is telling no, I am not interested to go now, I want to sleep more. So that should not be like that. If P1 is not interested, then P2 also cannot go. P2 will get the chance only after P1. That type of condition should not be there. That is called the progress. Progress means if anyone is not interested to go, then other one should get the chance. There should not be any dependency like that ki P1 will increase the value and P1 will give the token, then only P2 can go. There should not be like this. This is called progress. Next one is bounded waiting. Bounded waiting means there should be time limit. So it cannot be there ki one is going for some work that he entered to the washroom, after that he is not coming. He is for 2 hours, long time. That is not possible. So there will be some bounded time. Then after ending that bounded time, you have to get the chance. So these are the three very important requirements to satisfy the critical section problem, to do the solution of the critical section problem. Now come to the inter-process communication. A process can be divided into two types. That is
Independent process and cooperating process. So that is, we have already discussed independent and cooperative. Now there is shared memory and message passing. What is shared memory? What is message passing? So shared memory means, see that there is a common memory, both are sharing. P1 is also sharing and P2 is also sharing, right? But direct communication is not there. Between P1 and P2 there is no direct communication. They are only doing through that shared memory. So shared memory model, memory simultaneously accessed by multiple processors. Now what is the message passing? Message passing means they are using same message queue. The message queue are same, but there is no interaction between them. P1 is sending the message to here and P2 is also sending the message to here. The same message queue they are sharing. So this is called the message queue without being connected to each other. They are not connected, but they are sharing the same message queue. This is called the message passing process communication. Now this is the classical problem of a semaphore, wait and signal. How it is doing? In the semaphore there will be two functions, wait and signal. So first of all, whatever semaphore value may be, it is semaphore 1 and this is the 1. So whenever I am interested, I want to go to the critical section. Then what I will do? Then I will do wait. I will call the wait. Wait means it will be decremented. That is s equals to s plus 1, s minus 1. And always it will check if s greater than 0, then only you can decrement it. Otherwise, how you can decrement it? So when you will get the critical section chance, when the semaphore is greater than 0, then only you will get the chance to the critical section. Otherwise, you will not get the chance. Signal means after completing my work, now I am going out from the critical section. I am leaving from the critical section. Then I will call the signal. Signal means semaphore equals to semaphore plus 1. S equals to S plus 1. As I am leaving, so that's why I am incrementing the variable S equals to S plus 1. So here there is two types of semaphore, counting semaphore and binary semaphore. Normally, binary semaphore is there is only 0 and 1. Counting semaphore is it can be anything. It can be 10, it can be 20. It is depending on how many resources are available to you. Like that you are printing. There are, if you have available 5 printer is available to you. So at a time you can allocate 5 process. So that's why there your counting semaphore will be 5. First process is 1 to come, so it will be 4. Second process 1 to come, it will be 3. Third process is 1 to come, that will be 3. 2, then it will be 1, then it will be 0. After the 5 process, when 6th process 1 to come, then it will not get the chance. It will get the chance when anyone is leaving. Maybe one process is done its work, then it will do plus 1. Then another process will get the chance. This is called the counting semaphore. And binary means when it is 1, at a time one process can get the chance. As it is 1, if it is 1, then I can get the chance. Then I will make it 0. After finishing my work, I will make it 1 also. Then I will get the chance. Another will get the chance. So there are the very classical problem of the semaphore problem, that is the bounded buffer problem, that is producer consumer problem, dining philosopher problem, and the reader writer problem. So now see the question. This was the question. Now try to do that. Here the question is telling there are 3 processes P1, P2, P3 sharing the semaphore for the synchronizing variable. Initial value of the semaphore was 1. Initial value is 1. Assuming that the negative value semaphore tells that how many processes are waiting in the queue. Now process access the semaphore for following order. Now see, P2 needs access. So what it will do? P2 will do -1
because it will call the wait. Wait means it will do s minus 1. So that's why now it will be 0. P1 needs access. It will again call the wait. Means it will do again minus 1, that is minus 1 now. 0 minus 1, that is minus 1 now. P3 needs access. So P3 will do it again wait. Again wait means now it will be minus 2. After that P2 exit from the critical section means it will call now the signal. Signal means plus 1. Now this will be minus 1. Now P1 exit from the critical section. Again it will call the signal and it will be again plus 1. So minus 1 plus 1, it will be 0. So finally, what is the final value of the semaphore? Final value of the semaphore will be 0. Clear? Now come to here. Now here you can see the which of the following inter-process model used to exchange the message among the cooperative process. Just now we have discussed when they are cooperative process, how they are exchanging the message. They are exchanging the message through the shared memory and message passing. Now here it was the question for suppose PQR are cooperating process satisfy the mutual exclusion condition, then if the process Q execute into the critical section, then so if it is executing into the critical section, which one is correct? Yes. So here neither P nor R will get the chance because at a time only one process is getting the chance into the critical section. So that's why as Q is working, if Q is executing into the critical section, no one will get the chance. Here this question was that overcome the difficulties for the reader-writer problem. Reader-writer problem means one is reading, another one is writing. So when one is writing, then any other reader cannot come. And when one reader is reading, multiple reader can come. Because reader is not doing any editing, any updation. You can read. Multiple reader can read at a time. But when a one reader is reading, then anyone cannot write. When a writer is coming to the critical section, then anyone cannot read. That is called the reader-writer problem. So here writers are giving the exclusive access for the shared object because writer is only writing. Exclusive means who is getting the permission for the writing. And here it is telling reader, no, reader is not getting the exclusive access. Both reader and writer getting the exclusive access. No, only writer is getting the exclusive access because exclusive means you can write it, you can update it. Next one is that what is demand paging, virtual memory, difference between pager and swapper, logical and physical address, page table, and by speed, fast speed we will do in the next class. But here contiguous, non-contiguous, overlay, compaction, these are we are going to do. So don't stop now, don't pause now. There are so many things till now we will learn. Now come to the virtual memory. What is virtual? Virtually we are thinking that there are more memories that there. Actually memory is not there, but virtually we are thinking. Virtually the CPU is thinking there is more memory. So virtual memory technique allow the execution of the process that are not completely in memory. How it is possible? So here it's enable the user run the program are larger than the actual physical memory. Means maybe your memory size is 500 MB. 500 MB. Now your process size is maybe 700 MB. Now you are not able to execute because it is less than. How I can execute? I will divide this process into different part and I will take some of the part into the memory. I will execute it and after execution again the next part will come and it will execute. So this is the process of virtual memory only. So here we will use the technique of paging, segmentation. Using that technique easily we can utilize it. Now come to the demand paging. Demand paging means as per the demand. Demand paging is the method of virtual memory management that load the page when they are demand during the program execution. Means what it is. Maybe in your program there was three function. There was a function 1, then after that when you are executing the function 1, in the function 1 you are calling the function 2. So first of all you are loading the function 1. Now whenever it is calling the function 2, then you will take the part of function 2, here it is the function 2, then you will take the part of function 2 and it will be loaded. Means according to the demand it is loading to the memory, because memory size was less, that's why it is not possible to load total program together. Whenever it is asking for that, then only I will load it. This is called the demand paging. So what is the advantage of using the pager? What is pager? Don't be confused with the term pager. Pager means actually that is demand paging. Less swap time, because why means unnecessarily if we are doing swapping, if I am taking a part then again I am doing swapping, again I am doing swapping, that is unnecessarily. Whenever the requirement will be there, then only I will swap. That's why less swap time and less input output needed here also. Less amount of physical memory needed. More user can do it and faster response time. These are the advantage of demand paging. Now what is the difference between pager and swapper? Pager means demand paging and swapper means actually swapping. So pager swaps the page into the memory when the page will need, when the demand is coming. But swapper swaps the entire process into the memory. Total process it is swapping into the memory. That is called the swapper. And it uses the demand paging. It is using the normal paging system. Normal paging system when the swapping is going on, that is called the swapper. And especially in the demand paging, which type of swapping you are doing at the time of demand, that is called the pager. Now what is the difference between logical and physical address? So logical address is, there is so many confusion are coming between logical and physical address. What is logical address? It is the address generated by the CPU. When CPU is asking for a page, then it is giving you logical address. But physical address is, it is the address actually seen in the memory hardware, actually where it is. Then it is asking means what is the memory location, that is the physical memory. When CPU is asking, CPU is giving you logical address. So if it is not clear to you this how actually paging system is working, so there is the operating system playlist. I am giving the link of the operating system playlist for the numerical, paging, TLB, all types of question are there in the link, as it is the revision class, so that's why I'm focusing on the main revision. So if you are interested or if it is required, if you have not watched till now the operating system playlist, then watch the operating system playlist. It is given and I will give it into the description below also. Now page table and segment table. What is the main difference between page table and segment table? Main difference between paging and segmentation is that paging is when you are dividing, maybe it is the size of every pages will be always fixed. Means if it is a 100 lines code and if you are deciding that I will divide the lines into the 5 lines only, so every line you will divide by 5. So how many parts will be there for the program? That 100 by 5, that is 20 part will be there for the program. You are not watching that what is the function, what is the total part or not. But according to the segmentation, if it is a 100 line code,
Maybe function 1 is taking 30 lines code, function 2 is taking 20 lines code, and function 3 is taking 50 lines code. You will divide it into that way. This 30 is in segment 1, this 20 is in segment 2, and this 50 is in segment 3. Means according to logically, you will think about logically that what are the part will be, if I am loading it, then this part can execute together. So that's why you will divide it segment wise. And here the contain the base address of each page in the physical memory. It is reading, because in the page table, actually when CPU is asking for that CPU, here it is CPU will send you the logical address and it will go to the page table. In the page table, it is giving the logical address, that is the page number 1. I am searching for page number 1. Now in the page table it will be given, maybe it is stored into the frame number 5, and there will be the offset also. So here it is the page number and there will be the offset also. Then it will give you that okay, you have to go to frame number 5 plus you will do the offset, then you will get the original page. So that's why here base address is given, the base address where it is the starting address. And segmentation contains the segment address of the physical memory. The entries of the page table, page number corresponding to the frame number. How many frame numbers are there? Because at a time in your memory, if the memory size is 100 and if your each block size is 5, then there can be only 20 block, right? Means 20 frame can be there. So that's why in the page table also, here how many frames will be there, that how many entries will be there into the page number according to corresponding to the frame number only, because otherwise how I can get the entry? There are only 12 frames, so entry will be also there like that. But the segment table, the entries of the segment based on the segment limit. Segment limit means how much maximum segment can be possible. According to that limit only, there the table will be there, the data will be there into the segment table. Contiguous and non-contiguous storage. What is contiguous? Contiguous means the program occupies into single contiguous block location. Means if it is starting address is 2000 and if I need 100 size, means 100 maybe 100 byte, so that's why it will be 2100. That is the contiguous. But non-contiguous means maybe here you got this is your starting address 2000, here you got 20 byte you will be allocated, after that there is something already blocked, then here you got 30, it will be allocated here, then something blocked, then here you got 50, it will be allocated. Means it is dividing into several blocks, and after dividing it is adjust. So this is the non-contiguous. It's stored the faster because total together you can place, but it is the slower definitely, and more waste of memory can be there. Here it is less wastage of memory, because why? Because maybe here I need to do I required maybe 100 byte, but there is a 200 byte. So, or maybe 150 bytes. So I have allocated that 100 byte, but the 50 byte is wastage, because maybe 60 byte data now next time is coming, but I cannot allocate here. I need a contiguous location. So that's why more wastage is there. Now come to the overlay allocation, compaction, page table and the segment table. What is overlay? Overlay allows that the run a program its size larger than the amount of memory. This is, here we are using a special type of hardware. There is special type of hardware we are using in the overlay. Compaction. What is compaction? It is using for solving the fragmentation problem. What is the fragmentation problem?
some data, some 10 byte is free here, maybe after that here it is 5 free, then this is allocated, after that maybe 20 byte free, then it is already blocked. So compaction will do that key, the all the free memory it will take it together, that is 10 plus 5 plus 20, that will be your 35. 35 will be free here, and this all the allocated will be together, so that you will get a contiguous location and you can allocate another process. So compaction is the solution of the fragmentation. Now page table, it's getting stuck. What is virtual address space, physical address space, minimum number of bit required for virtual address space, physical address space, what is the offset, how many bits will be there for offset, and after that how to calculate the page size, how to calculate the page table size, means what will be the size of the page table, and after that what will be the internal fragmentation also. For this type of question you are getting confused, right? So that's why I am here with this video, and after watching this video this concept will be very easy to you and you will tell me how you are feeling. And after watching, definitely you can subscribe to the channel and click the bell icon to get all the latest update and notification. So see that here we are doing first of all what is the requirement of paging, that is the very important to understand. So here is the secondary memory. Normally our secondary memory size is very high because our hard disk, secondary memory is what? That is our hard disk. So it can be 1 TB size near about. Next thing is our main memory. So here is the main memory. Normally main memory means what? Normal main memory is our RAM. What will be our RAM size? Maximum it can be 16 GB or something, right? Now here is the CPU. So CPU is from where CPU will execute each and every program? From the main memory, because the secondary memory speed is very slow. So we are sending some of the part of the program to the main memory, and after that CPU will execute it. Now here the concept is coming how we will send. The paging is the concept where each and every program, because program is the process, program in execution, that is called the process. So you wrote a program, maybe the size is 10 KB, that is a process 1. Now what we will do, we will fix a size. What is the size? We will fix the size, that is the page size. And always the page size and the frame size will be same. Page size and frame size will be the same. And that is called actually the offset. What is page? What is page? Page is actually divided into the secondary memory. We will divide the secondary memory into a same size of slots. These are called the pages. Okay. And the main memory also divided with the same size of slots. These are called frames. So secondary memory is divided into pages and main memory is divided into frames. Clear? Now thing is, how many pages will be there and how many frames will be there. See that. How many pages will be there, that is depending on the process size. Because for each and every process we are dividing into some pages. In your secondary memory, that is in your hard disk, lots of program are there. So each and every process we will think about separately. So see that. Here it is your 10 KB. If I am thinking that each and every offset means size is 1 KB, that I am fixing. So how many pages will be there? 10 by 10. 10 by 1 KB, that is 10 pages. So there will be the 10 pages. So here are the pages 1, 2, 3, 4 till 10. Now the thing is that main memory. Now main memory, for this time being I am thinking that there is not 16 GB space is not there. At a time I can take, maybe here it is a 5 KB space is there in the main memory. So main memory will be divided as per that how many frames will be there in main memory.
that is depending on the main memory total size. The total size of the main memory is, for now I am thinking it is 5 KB. And what is the size of each and every frame? That is 1 KB. So in the main memory, how many frames will be there? There are 5 frames. Now see that I want to execute the process. But the problem is that in the process there are total 10 pages. But in main memory I can allocate only 5 frames. So at a time I cannot allocate everyone. Some of the pages I will send here. What of the pages? That is depending on my criteria. And it's not like that every time I will get all the frame free also. Because it is not like that in main memory I will execute only my process. There are multiple processes. So main memory have to give the space to each and every process. That's why it's not like that every time it will be free. For now I am getting that 5 KB space fee and there are 5 slots are free. Maybe this is frame number 1 is free, frame number 2 is free, frame number 2 is not free, 2, 3 is blocked, maybe 4, 5 and 6 and 7. These are free here. Okay. So what I am doing, page number 1 I am sending to frame number 1. Page number 2 in frame number 2. Page number 3 in frame number 5. Page number 4 in frame number 6. And page number next one, that is page number 5 in frame number 7. These are previously blocked. It was previously blocked. Okay. Now, for now I am telling these are previously blocked. So now what it will be? See that. Here is the page table. Now here is the page table. So this is my page table. Okay. And here you will be confused. That's why I am telling here are 7 KB. Okay. For now I am telling it is 7 KB so that there are 7 frames was there. But out of 7 frame these are already allocated. And now this 5 frame I got free. And in this 5 frame I put this. Okay. So that you will be no confusion. Now what will be the page table? In the page table, we will store according to the processes. Per process, how many pages was there? 10 pages was there for this process. So this page table is for the process number 1. For this process number 1, I am taking a page table. In this page table, number of entry is depending on the number of pages. So in the page table, number of entry will be depending on the number of pages. There are 10 pages. That's why 1, 2, 3 till 10. Total 10 entry will be there. Now, outside there are 10 entry means it is indexing like 1 to 10. Now, inside what I will store? Inside I will store the frame number. So, in the frame number, page number 1 was stored in frame number 1. Page number 2 was stored in frame number 4. Page number 3 in frame number 5. Page number 4 in frame number 6 and so on. In that way it will be coming. Right? Now think that CPU is always sending the logical address. In the logical address, CPU know the page number. CPU know the page number and what? That is offset. Now what is offset? Offset is actually what? Offset is the size. Means what it is? Think like that. It is your copy. Okay, it is your copy. Copy means a book. In your book it is a page. Now in the page so many things are written. Now you take a Xerox copy. Now in this Xerox copy, whenever you are taking the Xerox copy, then also same thing will come here. Right? So size means size of the page will be same. Like if you are taking the copy, if you are taking the Xerox copy, that will be same. So if the line number 10 I want here, in the Xerox copy also line number 10 will be there. The page number 10, it is maybe the page number 10. So you take the Xerox copy of page number 10. In page number 10, if I am asking you for line number 10, So line number 10 will be here. If I am asking for line number 2, line number 2 will be here. If I am asking for line number 20, line number 20 will be here. So that is the offset. That's why what will be happen? Page number 10 you took a Xerox copy, that is okay. But in a book there was 100 pages. Okay. Out of the 100 pages your teacher told you to take the Xerox copy for page number 10, 20, 30 and 40. Now you take only this 4 copy. So when you take only this 4 copy, where you will store? Here in this folder you will store. So in the folder number 1 you store the page number 10. Folder number 2 means in the folder this is the number. You store page number 20. Here 3 you store page number 30. Here in 4 you store page number 40. Right. Now see, when your teacher is asking that open page number 10, that is the CPU. CPU asking you open page number 10 and in that page number 10 maybe line number 2. Now you don't have the book. What you will do? You will go to your folder. In this folder you are maintaining an index here. This is your page table. You are maintaining the index here. You know that yes, page number 1 to page number 100 that is okay, but I don't have everything. I have the page number 10 in my page number 10 is there in frame number 2. So where I will go? I will go to frame number 2 and after that I need the line number 2. Line number 2 will be same thing. There is no change. So ultimate changing is what? Ultimate change is that according to this page number 10 I need that frame number. And this is actually same. This is called the offset. The offset will be same. There is not required to change any offset. Offset will be same here. Okay. So I hope it's clear to you what is going on here. Just take a page. If you are taking the book or if you are taking this copy, for this copy, if it is a copy, think like that. I am making the Xerox copy of this one. So the Xerox copy will be same. The line number will be same. So that's why offset will be also same. No problem. So now this is going on in this page frame, right? So when I am taking that page frame and offset, the page table. Why the page table will be required? The page number will be converted into the frame number. Here I need the maybe page number 2. I need page number 2 and offset number 4. So what it will get? The page number 2 is in frame number. I will get here that the frame number is 4 here. From frame number 4 you can get, and offset will be same as it is, that is 4. So now CPU will go to here, that is okay. Frame number 4 I can get the page number 2 and offset will be same. No need to change anything. This is the thing going on and this is called the logical address and this is called the physical address. Logical address means that is page number and offset, and physical number means that is frame number and offset. We are changing the page number to, so what it is? Logical address and the physical address. Logical address, there will be the page number and offset, and after that in physical address there will be frame number and offset, right? Now see that offset will be always same. Offset will be always same. Offset means the size of the pages. This is the size of the page and this is the size of the frame, and this is always same. So no problem here. Only the problem is here page number and the frame number. This will be converted through the page table. I will send here page number and from here I will get output as a frame number. I will go to that frame number. This is the thing. Now the thing is that logical address space and physical address space, how to calculate? That is how many bits will be required. Now we will
work on bits. How to calculate the number of bits for logical address space and physical address space. So how many bits will be there? See that. When I am storing here the page number. So page numbers, to store the page number, how many bits will be required? Here the concept is like that. If I am telling you, you have to represent 0 to 7. 0 to 7. It is binary, right? So 0, 0, 0, 0, 0, 1 till 7 means 1, 1, 1. So to represent 7, how many bits are required? 3. If I am asking you, you need to represent 0 to 15. How many bits will be required? 0, 0, 0, 0 to 1, 1, 1, 1, that is 15. So how many bits are required here? There are 4 bits required. How to get it? It is actually the concept of log. Log means if there are total range is 8. Here the total range is 16. So 8 means what? 2 to the power 3. So how many bits are required? 3 bits are required. If there are range 16, then how many bits are required? 2 to the power 4 means 4 bits are required. If it is 32, then how many bits will be required? 2 to the power 5 means 5 bits will be required. 64 means it will be 2 to the power 6, that is 6 bits is required. And same way you have to go for 1024 means that is 2 to the power 10, that's why 10 bit will be required. This is the concept. You have to remember till 2 square, then 2 cube, then 2 to the power 4, then 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9 and 2 to the power 10. Throughout the computer science, this is very, very important. How many bits will be required? Not only in computer science, everywhere. Okay, so must remember that. Now after that, so here if I am telling you that I need to page number, what is the range of the page number, that is means number of pages. If there are 512 pages total, so how many bits will be required? 2 to the power 9 means 512. So I need 9 bit. Now you will tell me, ma'am, in between something is coming. If I have to represent 80 pages are there, then how many bits? Always take the upper bound, because 2 to the power 6 is 64. It cannot do 80, right? So 2 to the power 7 is 128. So I will take here 7 bit. Always take the upper bound. In lower bound you cannot do. So that's why for 512 pages I need here 9 bit. Now offset. Offset is also depending on that size. If your size is, now it will work on the size, right? So size means offset. So size means offset means how it will be. What is that? Size, what it is? 1 KB, 1 GB, 1 KB. After that it is coming 1 MB, 1 GB, 1 TB. 1 KB means, and B means what? B means actually byte. Byte means, that is, byte means 8 bit. 8 bit means 2 to the power 3. That is bit. Okay. Now we are coming to byte. Byte means 2 to the power 10 byte. MB means 2 to the power 20. GB means 2 to the power 30. TB means 2 to the power 40. Right? So if it is given like that 16 KB. So how many bit will be required? 16 means 2 to the power 4. Multiply into KB. 2 to the power 10. So how many bits? 2 to the power 14 means from here I can get 14 bit. Got it? If it is given like that, maybe 32 GB. So 32 GB means what? 2 to the power 5 multiply into 2 to the power 30, that is 2 to the power 35. So here 35 bit will be required. That is the simple way what you have to do. Yeah, just whatever is given need to convert in to the power, and it is KB, GB, MB, convert in 2 to the power.
then add it, because 2 to the power m multiplied into 2 to the power n, that is 2 to the power m plus n. That's why we are adding this number, right? So here whenever it is given like that, page size and frame size, it will be same, because the page size, if you can calculate page size, then frame size, here offset, this offset and this offset will be always same. If page size is given, that is frame size. If frame size is given, that is page size. So offset is depending on the size. Convert the size into 2 to the power n, and then number of bit will be this n bit. Clear? Now what is the frame? So here frame number we will store. So it is also depending on how many frames are there. If there is 32 frames, then how many bit will be required? 2 to the power 5, that is 5 bit will be required. So just this is the bit, how to get the bit, this is the way, that number of bit. Now total address space, what will be the total address space? If I am telling it is the 10 KB each and every one, so it will be, or I am telling 1 KB, I am not taking 10 KB, 1 KB. If it is 1 KB, 2 to the power 10. So here is 10 bit. Here is also 10 bit. And here I got the 5 bit. So 5 bit plus 10 bit, that is 15 bit here. And 9 bit plus 10 bit, that is total 19 bit will be there. So the logical address space will be 19 bit and the physical address space will be 15 bit. Logical address space means secondary memory divided the process. It is depending on the process. How many pages will be there, how to calculate the number of pages. Here also you will be confused. So how to calculate the number of pages? I am searching for some space. Yes. So number of pages equals to process size divide by offset. Offset means the size of the page. Offset means this is the size of the page, right? That is the number of page. And number of frame, how to calculate? Number of frame, how to calculate? That is the main memory size divide by offset. Size of the main memory total divide by offset, that is the number of frame. I hope it is clear. Now you can solve the question. So here a main memory management system, 64 pages are there and 512 byte page size. Physical memory consists of 32 frames. Number of bit required for the logical address and physical address. Easy. You can do it very easily. Right? The logical address space and the physical address space. In logical address space and physical address space, what we are storing? That is page number. And here we will store the frame number. Here will be the offset. Here will be the offset. So number of pages here 64 pages means 2 to the power 6. So 6 bit will be required to represent. 512 is the page size means 2 to the power 9. So 9 bit for offset. Here also 9 bit for offset. Same thing. 32 frames are there. 32 frames means 2 to the power 5. So 5. 6 plus 9 equals 2. And 5 plus 9 equals 2. That is the answer. So yes, your answer will be 15 plus 14. It's easy, right? Now see that. Here read the following. This is the question. Read it and do it. Consider the machine 16 GB main memory. 16 GB is your main memory. 32-bit virtual address space. Now the page size is 4 KB here and frame size on page size are same, that you know. Now what is the minimum number of bits needed for the physical address? It is asking you total physical address. Total physical address means what it will be? That is the frame number plus offset together. And frame number plus offset together means directly you can go from the main memory. Because when I am doing the number of frame, what I am doing? Main memory divide by offset I am doing it, right? Now when I will calculate the total, offset is already included here. So what I can do directly from the main memory, I can get the total size. So main memory is given here 16 GB. 16 GB means 2 to the power 4 multiply into 2 to the power 30. So it will be 2 to the power 34 means number of bit will be here 34. So your answer will be 34 here. Next one. So next one is asking same question. These are actually the UGC NET question. These are asking on UGC NET comprehension type question, means 10 marks was there, and it is 2021 question. Now see, find the number of pages required for the virtual address space. How many pages required for virtual address? How many pages? How to do? Here is given 32-bit virtual address space. Here total is given you 32-bit. In this 32-bit, some are allocated for the page number, some are allocated from the offset. And what is offset? Offset you can get from the page size. So that is 4 KB. So how many bits will be there for the offset? 2 to the power 2 multiply into 2 to the power 10 because KB. So it is 2 to the power 12. So how many bits? 12 bit is for the offset. So here it is 12 bit. Total was 32. So 32 minus 12, I will get here 20. So number of bit will be there 20 bit. Now 20 bit is required to store the page number. Same here we calculate the 20 bit. So how many pages will be there? That is 2 to the power 20. Two things are there. That is how many bit when the total number of pages are there. When the 8 pages was there, how many bit was required? That is 2 to the power 3. From here we got the 3 bit. So opposite thing we calculate here. The 20 bit is required to represent the page number. So how many pages will be there? Just opposite. When bit is given to you, then you need to do number of pages means 2 to the power n. When the number of pages are given to you, you have to do the how many bits are required. Then you will do log the number of pages. Means you will see that number of 2 to the power n, and after that n is the power. So n will be the number of bit. Right. So that's why your answer will be 2 to the power 20. Now the next thing, it is the already we have calculated number of bits reserved for the frame offset. Last one only we have done here, right? You can see the 12 bit offset. Page offset, frame offset is same. So that's why definitely same thing. Answer will be 12 only for frame offset. You got it? Now see here, page table. What will be the size of the page table? So what we are storing in page? What we are storing in page? Page table. We are storing the number of pages. An entry, number of entry in the page table is equals to the number of pages. So just now we calculate how many pages are there total. 2 to the power 20 pages are there. What we are storing in the page table? We are storing the frame number. So how many bits are required to represent the frame number? How many bits are required to represent the frame number? That is the thing. How many bits will be required? Here we got already the from the main memory, that was the size, means the physical address space. Just now when we calculate the physical address space, that was 34 bit. and out of that offset is 12 bit. So remaining will be 34 minus 12, that is 22 bit is remaining from here, right? So 22 bit is there for the number of frame, right? So to represent the number of frame, 22 bit is required. So that's why what will be here? So here 2 to the power 20 and 22 bit is required actually. But in this question no need to think about that, because in this question it is already given that the page table is 2 byte. It is already given to you, because in the page table we are storing frame number, that is okay, plus something extra, some extra information are also there, like that some bit, that is obsolete bit, are there or not. So in the page table some extra information is also there. So it is given that the each and every size of the entry is 2 byte. So directly you can calculate. In some question maybe it will be not given, then you need to calculate the bit of the frame number. But here in the question it is not required. If it is not given to you, then what to do? 2 to the power 20 multiply into 22 bit. This bit you need to convert in byte. 22 bit is near about 2 byte. Okay, so that's why you can think like that. Actually you have to take the upper bound. That will be 3 byte. So no need to confuse about that. Here it is 2 byte is given. Just you will do 2 to the power 20 multiply into 2 byte. If it is bit, always remember I have to convert in byte, means I have to do 8, divide by 8. Like it will be near about 3 byte then. But in question it is given 2 bytes, so we will work on 2 byte. Okay, otherwise it will be, answer will be different. So here I will multiply with 2 byte, then it will be what? 2 and 2 to the power 20 means, 2 to the power 20 means MB. So my answer will be 2 MB. It's very easy. Now the last question, what is the internal fragmentation of the process? Internal fragmentation of the process. So for that let's learn internal fragmentation and external fragmentation also. Internal fragmentation, external fragmentation. Here internal fragmentation means I have a 38 byte space, but I am placing here a process that is only 32 byte. So my wastage is 6 byte. This wastage of space is called the internal fragmentation. What is external fragmentation? Here I allocate a 4 byte process, that is P1. Here I allocate a process that is, okay, no, here maybe it is free. This is a free space. Okay, this is also a free space. Here I allocate maybe a 3 byte process. Okay, so this is free also, this is also free. So 4 byte is free here, 4 byte is free here. Now I have another process, that is maybe process 2. It's required a 8 byte space. Although you can see this 4 byte, 4 plus 4 byte, this is free here, but I am not able to allocate because it is not contiguous. In between, this space is already blocked. It is not contiguous. This is the problem of external fragmentation, and it can be overcome using compaction. Compaction will do that. It will take all the free places together, like it will free the 8 KB here, and after that it will allocate this 3 byte here. This is the possible through compaction. Now let's solve the question. See that here it's easy, internal fragmentation. What was the process size? Is 30 KB process size. For 30 KB process size, I know that page size is 4 KB. If I am dividing 34 divide by 4, it is actually 4 multiply 8, 9 means it will be 36. 4 multiply 8 means it will be 32, right? Now see that. If I am allocating all the 8, this is the space here. So yeah, here I am going, space is not there. So 2 KB will be the answer. Why the 2 KB? I am showing you.
all the 8 will be blocked, right? 1, 2, 3, 4, 5, 6, 7 and 8. These all are the 8 will be total. I am not written 8, so it will be 4 multiply 8 means 32 total complete. 1, 2, 3, 4, 5, 6, 7 and 8. These 8 are all total completely 32. Now I need the 9th one also, and in this 9th one, actually this 9th one is how much? 4 kb. It is total 4 kb. But out of 4 kb, how much remaining? My total size was 34 minus 32. 2 kb is remaining only. So from here I will take only 2 kb space. And this 2 kb is wastage here. This 2 kb is actually wastage here. So answer will be 2 kb, that's why. That is the internal fragmentation. You can do this question in same way, that is 34 kb I require, means I need at least 9 pages. That is 36 minus 34 is 2 kb. In that way also you can do, but conceptually this is the answer. This is just like a disk. Disk means nothing else, it is just like a CD. But you all are well known about CD. So how the CD is working? It is just like a CD. This is a CD. Now in this CD, this total is a surface. There are some platter. What is the platter? Double-sided platter means it is just like a double both side CD. Means this side also you can write, opposite side also you can write. There are some track. What is called track? These are the track. These all the circle, just like a when the running race is going on, then there are some track. These are the tracks only. What is sector? Sector means each and every track are divided into some small part like this way. These are called sector. What is block then? Block is actually the collection of some sector. Like here I am taking 3 sector together. So now I am making a block. This is a collection of some sector. This is called block. So from here you can easily understand one thing, that the block size, whenever it is a block, the block size should be greater than the sector size, and it should be multiple of sector size, because either I can take 2 block, 3 block, 4 block. So it will be multiple of sector size, and it will be less than of the track size, because ultimately block is a part of track. So it cannot be greater than the track, right? This is a very important concept about block, sector and track. And what is the surface? Actually the total circle is the surface. Surface is the collection of some track. Whenever you are calculating that, what will be the surface size means, first of all you have to calculate the track size. What is the track size? How to calculate? It is a collection of some sector. What is track? Track is collection of some sector. So that's why now go and solve the question. And what is the cylinder? Here you can see the cylinder. This is called a cylinder. Cylinder means it is the collection of the track. Means how many tracks are there? That is actually the cylinder. Total number of tracks in the storage, that is called the cylinder. So now solve the question. See that here are 5 questions. Each and every question will clear your concept. Here is a sector size given to you. 2000 track are there. 50 sector are there. And here is also seek time given. Seek time means that is actually from one track to another track moving. How much time will be required for the arm. So this is, we are not doing it because that is the part of when we will do the disk scheduling. This is the part of disk scheduling. But here it is not required. Here we are working on the storage capacity of a disk. See, first question is the capacity of the track in byte. How to solve it? Capacity of the track in byte. What is the surface? What is the capacity of the disk? How many cylinders are needed? How many cylinders are there actually? And if the block size is there, which one is the correct block size? If it is the RPM, then which one is the rotational? What will be the rotational delay? and the per revaluation if it is given, then what will be the transfer rate? So let's solve one by one. Capacity of the track. In one track, it is a collection of the sector, right? Now here the sector size is given to you 512 byte. Now how many sector are there? There are 50 sector. So definitely we will multiply 50 with 512. That is your answer for the capacity of the track, right? So it will be 25600. Is it or not? So near about value you can take, it is 25k, because this is in byte, this is in kb. Why? Because 2 to the power 10 means 1024 is actually kb. So 25600 means we can say that it is near about 25 kb. Next one is, what is the capacity of each surface? Now it is given that in the disk, how many tracks are there? Because a surface means it is the collection of tracks. There are 2000 tracks per surface. Just now we have calculated it is the track size. So just if we are multiplying with it 2000, then we will get the surface size. That is the capacity of the surface. Now the capacity of the disk. What is the capacity of the disk? Here are 5 double-sided platter. One platter means one surface size we have calculated. There are total 5 like this type of 5 platter are there. Each and every platter have 2 surface. And here are total 5. So total 5 multiply into 2. And the surface after multiplying 2000, that will be your capacity of the disk. So it is here 512 multiply into 50, that is 25k. 25k multiply into 2000, that is 50,000k. And 50,000k multiply with 5, because there are 5 platter and each and every platter have 2 surface. That's why it is the total disk capacity. You got it. Now the next question, that how many cylinders are there? I told you the cylinder means the number of track, nothing else. There are 2000 track means number of cylinder is also 2000. That is very easy. Next one is that which one is the valid one? First of all, I told that how to understand the block. What will be the block size? It should be greater than, it should be less than what? So tell me, 256, is it a valid one? Here there is the sector. Sector is 512. Is it a valid one? 2048. Is it a valid one? 51200. Is it valid one? Which one is valid? No, definitely 256 is not valid. Why? Because 256 is less than 512. Always our block size will be multiple of the sector size. It cannot be less than, right? So that's why 256 though not valid. 2048, this is multiple of the 512, right? If you are multiplying with what? Tell me with what if I am multiplying, then I am getting this. Or can I divide 2048 by 512 or not? I can divide, right? What will be the result? Let me know in the comment section. And it is a multiple definitely. And is it less than 25600 or not? Because block will be less than the track size also. Just now we have calculated the track size, that was 25600. So it is less than 25600 and that's why it is a valid one. 2048, it is a valid one. After that, next one 51200. Yes ma'am, 51200. This is also multiple of 512. If I am multiplying with 100, then I am getting 51200. So it is also valid. No, this is not valid because it is greater than 25600. Block cannot be beyond the track size because block will be within the track only. It cannot be more than the track size, right? So it is more than track size. That's why this is also not valid. 51200 is also not valid. Now came to the next one. That is the disc platter rotate for 5400 RPM. Means revolution per minute. So what is the rotational delay? What is the meaning of rotational delay? Meaning of rotational delay is for one rotation how much time it's taking. For one rotation how much time it's taking, and we have to give the answer in second. Here it is RPM is given. What is the meaning? That in 1 minute it is rotating 5400 time it is rotating. So 5400 times rotation is taking 5400 rotation is taking 1 minute. 1 minute means 60 seconds. So if I am converting it into 60 seconds, so for one rotation how much time it will take? 60 by 5400. So it will be 1 by 90, right? It is 1 by 90 second. So 1 by 90 second means it will be 0.011 second. That is your rotational delay, nothing else. If it is asking you average, then average means 0.006 second. Now the last question. If one track data can be transferred per revaluation, in one revaluation, revaluation means rotation. Don't be confused with the revaluation and rotation. Means one, how much time is taking for rotation, that is only revaluation. Okay. So transfer rate per revaluation is one track data. So then what will be the transfer rate? So I know that for one revaluation I need 1 by 90 second, right? Or 0.011 second. But 1 by 90 it will be, calculation will be easy. It is transferring how much data? One track size data. One track size data means 25600 or 25K, right? So 1 by 90 second I can transfer 25K data. Transfer rate means what? In 1 second how much data I can transfer? That is 25 multiply into 90. That much data I can transfer. That will be my transfer rate. So that's why your transfer rate will be 25K multiply into 90. That is 2250 KB per second. So you got all of your answer, right? Now I am... Hi, CPU scheduling is a confirm area from where always questions are coming, and unfortunately and fortunately students are doing mistake here. Students are getting confused here because in the numerical they are doing mistake. So that's why I am here for you to make this topic more easy, and after watching this video, all the algorithm, all the CPU scheduling numerical will be very easy for you and you will get the score here. So definitely watch this video till the end and we will solve the numerical. I will give you the tricks also. I will tell you each and every point that where you can do the mistake. Why? Where the students are doing mistake. Especially problem is happening on round robin algorithm. So I will teach you round robin algorithm also in easy way so that you will never forget. So that's why definitely watch the video till the end and subscribe to the channel. Click the bell icon to get all the latest update and notification. Please like this video if you like, and please share this video to all of your friends. So let's start. And after completion, I will come to the last minute revision so that it will be clear for you. So let's start with the FCFS, that is called the first come first serve. So let me change the color of my pen. Here I think black color will be better. Yes. So first thing is that FCFS, that is first come, first serve. Who will come first, they will serve first, right? This is called first come, first serve. So by learning this, it is most of the students are thinking that it is very easy. Who will come first? I will take that first. But here the problem are happening. So I am telling you some common area where the students are doing mistake. First common area is to know all the CPU algorithm, all the CPU scheduling algorithm. Some terminologies are required. First of all, AT, that is called arrival time. Arrival time. So always, whatever algorithm it is, if it is FCFS, SJF, round robin, always check the arrival time. Because whatever constraint is there, if it is not arrived, you cannot do anything with that process. Because CPU scheduling means when the process are coming and they are trying to execute, now CPU will allocate the slots to them, right? So if any process is not arrived yet, then what CPU will do? So that's why always be careful about the arrival time. Here so many students are doing mistake. Now after arrival time, next thing is the burst time. So burst time means here it is called the when how much time is required to execute the process. That is called the burst time. Burst time means how much time is required to execute. Think like that you are coming to doctor. There is a long queue in the doctor. You also came there. Other patients are also there. So when each and every patient arrived to that hospital, that is the arrival time of that patient. Now, actually, doctor is taking how long time? Doctor is taking you only 5 minutes, 10 minutes maximum. That checkup time is your burst time. Now, there is the completion time. Completion time means when you ultimately coming out from the hospital. All the everything is done, payment is done, your waiting time is also there. You are taking the medicine and all, everything is done, and after that you are coming out from the hospital. That is your completion time. When your total things is completed. Completion time. Right? Now after completion time, here is a turnaround time. Now what is turnaround time? Turnaround time means here completion time means maybe you went to hospital at 10 a.m. and ultimately you complete all the work in hospital at 2 p.m. like that, or 12 p.m. like that, or 1 p.m. whatever it is. So that is your completion time. So here I am taking that you came to hospital, arrival time is 10 a.m. Burst time, doctor checkup and your test and all, taking medicine, that is only I am taking 1 hour maximum, all this. But your completion time is here maybe 1 p.m. Maybe 1 p.m. So here your turnaround time, what will be the turnaround time? Turnaround time will be completion time minus arrival time. So when you complete your task, that is 1 p.m. and you arrive at 10 a.m. So 10, 11, 12, 1. 3 hours is your turnaround time. Now next one is the waiting time. Waiting means how long you are waiting. Actually you are sitting in a place and you are waiting. Nothing is going on. No testing, no checkup, no for medicine, anything, nothing is going on. Just you are waiting in a sitting on a chair or you are scrolling mobile. That is a waiting time, right? So what is the waiting time here? Waiting time is turnaround time minus burst time. So ultimately this was means when you arrive and when you completed the task, that was your 3 hours is your turnaround time, and your waiting time is from that 3 hours, actual checkup time was 1 hour. So this 2 hour is your waiting time, right? This 2 hour is your waiting time. So I hope now these all are clear. And response time, then another concept is coming, that is response time. Response time means when process
Getting chance means getting chance in the CPU. When it is getting chance in the CPU, that is the response time. Means it is like that. You arrived at 10 a.m. and maybe 10:15 a.m. Maybe 10:15 a.m. your fast call. Normally it is happening when we are going for the eyes checkup. So your fast call is there. Okay, they will call you and they will check your are you able to see that, and or power checkup, optometrists are checking the power checkup is done. That was your first call, and after that they put the medicine. Now again wait, and that waiting time is a too long waiting time, right? So that 10:15 a.m. was your first call. It is not completed. Fast checking, or maybe your pressure check, your temperature check is done. This is your response time when process gets the CPU for the first time. Okay, minus the arrival time. Minus the arrival time when you arrive. Okay, so this is your response time. That is the concept when it is getting the first chance. That is called the response time. Got it? Now I am coming to the concept one by one. It will be required for mainly when we will go for the primitive algorithm. There are two types. There are two types. One is primitive scheduling, another is non-primitive scheduling. What is primitive? Primitive means preemption, means before completion of the work. Preemption means here FCFS we will do in the next page. So here we are not doing FCFS. Here I am telling the CPU scheduling is divided into two parts. One is called preemption, preemptive, another is non-preemptive. Okay, so preemptive and non-preemptive difference is that preemptive means before completion of the work, means total for my checkup, for my doctor checkup, total time is 1 hour. Actually, total time will be 1 hour. And if I am not completed in that time, anyone cannot come. Maybe I am thinking like that. But here it is what it is going on. 10 minutes you are getting chance. After that again you are waiting. Again 10 minutes another one is getting chance. Again after half an hour or 1 hour you are getting chance again. That is called the preemption. You have not completed your task, but some of the part is done. Again you are going to the waiting phase. Again you are waiting. Another one is getting chance. And finally again you are coming. This is called the preemption method. Before completion of the task of a process, it can be preempted so that another one can get the chance. And no preemption means when I am getting the chance. If it is my chance, if it is my turn, I will complete all my work. After that only another will get the chance. That is called no preemption. So if my time is required 1 hour, my full checkup will be done in 1 hour. After that, next patient will come. That is called the no preemption method. I hope preemption and no preemption is clear to you. Now I am coming to the FCFS algorithm. And FCFS algorithm is the first come first serve algorithm. Here first come first serve means what? That here I am taking an example. From the example it will be clear. See that. And all of you after giving try to do by yourself. Okay. So there is the process number. There is arrival time and the burst time. It will be given to you. So process number 1 arrival time 0, burst time 4. Process number 2 arrival time 1, burst time 3. Process number 3 arrival time 2, burst time 1. Process number 4 arrival time 3 and burst time 2. And process number 5 arrival time 4 and burst time 5. Okay. So here it is very easy. Here there is no problem in the arrival time or the burst time, because who is arriving first, it will get the chance. So process number 1 will arrive first. Here we will prepare a NAT chart. This is called the NAT chart. This NAT chart will be prepared like that. It is always started with 0. When it is arrived at arrival time 0, who arrived? Process 1 arrived. So I will take process 1. And from process 1, it is a no preemption. Here is not a preemption, non-primitive algorithm. This is a non-primitive.
This is a non-preemptive algorithm. Okay, whenever it is getting chance, it will complete the task. So P1, after that 4, it will complete the task 4. At the 4 means 4 p.m. maybe you are thinking, after that who arrived here? 1. He arrived already in 1 p.m. He arrived already in 1 p.m. but now he is getting chance at 4 p.m. So P2 get the chance. P2 will be execute till 7 because 4 plus 3 is 7. After that P3 will get the chance. P3 only 1, so it will be 8. After that P4 will get the chance, and P4 will get what? That after 8 there is 10. It will be 10, and then P5 will get the chance, then it will be 15. So that is done, right? Now after doing that, you have to fill this table. How to fill the table? Here you have to fill the completion time, after that waiting time, after that turnaround time, then waiting time, and finally response time. Okay, so completion time always go from this side. That is better. Always going from back side. So completion time of P5 is 15. Just put it here, 15. Completion time of P4 is 10, and here it is 8. Here it is 7. Here it is 4. This is my completion time. And what is turnaround time? Turnaround time was completion time minus arrival time. That was equals to turnaround time. So completion time is 4. Arrival time was 0. So here turnaround time is 4. Completion time is 7. 7 p.m. it is completing. Its checkup is done at 7 p.m. but it came at 1 p.m. So here turnaround time is 6 hours. Here it is completion time is 8 p.m. It came at 2 p.m. So here also 6 hours. 10 p.m. it came at 3 p.m. Here it is 7 hours. Here 15 and 4 p.m. So it will be 11 hours, right? That is the turnaround time. Now what is waiting time? Waiting time is turnaround time minus burst time. That was waiting time. So how much I am waiting? That is the turnaround time, 4, and burst time was also 4. Turnaround time minus burst time. So turnaround time is also 4, burst time is also 4, waiting time is 0. Turnaround time is 6, burst time is 3. So waiting time will be 3. Turnaround is 6, burst time is 1. So it will be 5. Turnaround is 7, burst time is 2. So it will be 5. Turnaround 11, burst is 5. So it will be 6. So these are the waiting times 0, 3, 5, 5 and 6. And what is the response time? Here actually for FCFS and for all non-preemptive algorithm, your response time will be also same. It will be also same as the waiting time, because ultimately when I am getting chance, I am completing my task. So how long it is taking response, that will be same. Here it will be same. So response time was that when CPU get the chance, when P1 get the chance at 4, and when it is arrived at 0. So that's why 4 minus 0 will be here. That is, I am 4 minus 0 will be means I am getting chance 4, I am arriving at 0. That will be 4 only, 0, right? That is the 0 only. So there is no problem here when I am getting the P1 is coming at time 0, arrive at time 0 and getting the chance at 0 also. So that's why response time is 0. And when P2 get chance at 4 but arrive at 1. So what is the response time? Response time is 3. When it is getting chance on CPU first time getting chance on CPU minus the arrival time, that is we are getting, right? So it is getting chance at 7, but when it arrive at 5. So that's why it will be 5. It was 5, that is 7 minus 2, arrive at 2. Here it is the 8 and arrive at 3. So 8 minus 3 will be 5 again. Here it's getting chance at 10 and arrive at 4. So it will be 6. So here you can see one thing. The waiting time and response time is same here. Why? Because it is a no preemption method. As there is no preemption, so response time and waiting time will be same. If it is preempted, then waiting time can be more. Before means I am getting for the 10 minute, I am getting chance for the 10 minutes, still my 40 minute is remaining, but I am waiting for 2 hours. Then waiting time will be increased, but response time will be different for the preemption method. So I hope this concept is clear now, right? Okay. Now I am going to the SJF and I am focusing on that. You are doing the last night study here and you are trying to complete this chapter. So that's why I am recording in one shot, one video only. So SJF is called shortest job first. Shortest job first. Right? Shortest job first. Who is shortest job? He will get the chance. It will get the chance. Right? So here I am taking an example. P number. After that arrival time. Then burst time. So process number is 1, arrival time 1, burst time 7. Process number 2, arrival time 2, burst time 5. Process number 3, arrival time 3, burst time 1. Sorry, it is 1. Let me erase this. So after 5, this is 1. Okay. Then next one is 4, then 4, then 2, and here it is 5, then 8. Now try to do it. I will suggest you, please try to do it by yourself. SJF, who is the shortest one, it will get the chance. And do it. Do that, the NAT chart. Who will get the chance? Without watching, please let me know in the comment section. That's why I want to see that how many of you are doing correct and how many of you are doing wrong. Before going to the next, only comment in the comment section. Who will get the chance? Okay, and don't erase your comment after knowing the correct answer. Okay. So who will get the chance? Who will get the chance? Most of the students will think that yes, here my burst time is minimum 1. So that's why P3 will get the chance. But that is wrong. Because what? Because we have to check always the arrival time. The arrival time is the most important factor here. So at the time 0, anyone arrived? Anyone not arrived at time 0? Who at time 1 someone arrived? So here it will be idle. This time no one is working. After that, when at 1, in this time 1, who arrived? Only P1 arrived. Although the burst time is 7, but no one arrived. So what the CPU will do? As that it is, so maybe that patient will take 7 hours, but that patient only arrived. So definitely I have to get the chance, right? So that's why here P1 will get the chance. And this is SJF is a non-preemptive. Here no preemption. You cannot preempt. Another version of SJF is there, that is where the preemption is going on, but this is no preemption, no preemptive. Another version of SJF, that is I am coming to later, that is SRTF, shortest remaining fast, or preemptive shortest job fast. In that way they are giving. So here whenever it is getting chance, it will complete its tasks till 8. Now at 8 p.m. Now time is 8 p.m. In that time, see that who arrived? Everyone arrived. It arrived at 2 p.m. It's arrived at 3 p.m. It's arrived at 4 p.m. and it's arrived at 5 p.m. Now out of all them,
I will take the shortest one. Now this is my shortest one. Now P3 will get the chance, and I hope now it is clear to you. Most of the time students are doing mistake here. So P3 is now 9 because it is the 1. After that, who is the shortest one? After this one, shortest one is P4. So P4 will get the chance. P4 will execute till 11. After, next one is P2. P2 will get the chance. It is 5 means it will be 16. And after P2 will get the chance. Who is there? P5. Next, last one. That is P5. P5 is 8. So it will be till 24. I hope this is clear to you. Now the next task is to do the completion time, waiting time and turnaround time. So just do it quickly. What is completion time? What is turnaround time? And what is waiting time? Completion time, again go from this side. When you are going for this side, that is 24. Who is 24? P5 is 24. So put here P5 is 24. P5 not, sorry, it is 24. And here it is 16. Who is 16? P2 is 16. So P2 is 16. Here it is 11. Who is 11? P4 is 11. Put here 11. 9. Who is 11? 9. P3 is 9. And here 1. Who 8? Who is 8? P1 is 8. So in that way, fill it so that there will be no mistake. Okay. So we got here 24, 16 and all. Fill this. After that, turnaround time was completion time minus arrival time. So here completion time is 8, arrival time is 1, 8 minus 1 is 7, 16 minus 2 that is 14, 9 minus 3 that is 6, 11 minus 4 that will be 7 and 24 minus 5 that will be 19. That is our turnaround time. What will be the waiting time? Waiting time is turnaround time minus burst time. 7 minus 7 that is 0. 14 minus 5 that will be 9. 6 minus 1 that will be 5. 7 minus 2 5. 19 minus 8 that is 11. Okay. Now here last one, I forgot one thing, that here we have to calculate the total turnaround time and waiting time. They are asking that average turnaround time and average waiting time. So what will be the average turnaround time here? Here your average turnaround time means just do the total, all the total, and after that divide by how many processes are there. There is 1, 2, 3, 4, 5 processes. After that divide it, your average time will be here 6.8, and here average waiting time is add all, after that divide by 5. So here it will be your 3.8. Okay. So that they are asking you what will be the average waiting time, what will be the average turnaround time, and sometimes they are asking that what is the waiting time for this process. That is also they are asking. What is the turnaround time for this process? Partially also they can ask. And here after doing your average turnaround time will be average turnaround time. Just calculate all, add all. After adding, this will be actually 53. If you are dividing 53 divide by how many process? 5 process. 53 divide by 5. You will get here 10.6, and average waiting time. Here total waiting time will be 30. So 30 divided by 5, it will be 6. That is the answer for the SJF, shortest job fast. Hope this is clear, and now you will not do any mistake in shortest job fast, right? Now the next one we are doing, that is shortest remaining, SRTF. SRTF. It is the primitive version of SJF. It is the primitive version of SJF. Sometimes they are giving the name SRTF, shortest remaining time first. The name is shortest remaining time first, or it is the primitive of SJ, right? So here I am giving a example. Take an example and we will do that from that example. P number, arrival time and burst time. So here it is 107, then 213, 215, sorry. Very sorry. Just so here it is 215. After that 323, and after that 431, then 542, and finally 6, 5 and 1. This is the process number, arrival time and burst time. Okay. Now, in shortest remaining time fast means it will check in every millisecond. In every millisecond means every unit of time, not millisecond, every unit of time it will check. What is the remaining task? What is the remaining task? Who is the shortest one? So here how the NAT chart will be, just check the NAT chart here. Your NAT chart will be like this way. So here it is time 0 and always arrival time. Always we will work on arrival time. Arrival time 0, only P1 arrived. So definitely P1 will get the chance. There is no other one. P1 will get the chance and it will work 1 unit. 1 unit, that is it will work till 1. Now here it is remaining 6. At that time who arrived? At that time only P2 arrived. No other one arrived. So P2 will get the chance here. P2 will get the chance. And after that, P2 will also work 1 unit of time. That is 2. And here it is remaining 4. Right? Now, after that, at that time, who arrived? P3 arrived. And see here, it is remaining 6, it is remaining 4 and it is 3. So that's why P3 will get the chance and P3 will be till 3. Now it is remaining 2. Okay. Now who arrived? Now P4 arrived. So when P4 arrived, P4 is also remaining time only 1. So P4 will get the chance and P4 will do 1 unit of time, that is 4, and now this is 0. At that time who arrived? At that time P5 arrived. And P5 is also 2. Now here is a tie. This is also 2 and this is also 2. Now who will get the chance? In this situation, according to the process number, we will break the tie according to the process number. So here P3, not P5. Here who will get the chance? P3 will get the chance and the arrival time is also there. The arrival time was also 2. So here P3, P5 both are 2. Okay. And according to the arrival time, that is not only process time, according to the arrival time of the P3 is, means P3 came fast. So that's why P3 will get the time first. Got it? So now P3 will get the chance and P3 will execute till again 5. Now P3 is 1. Now out of all, P3 is only at that time already P6 also arrived. It is also 1, it is also 1. Again the tie. But who will get the chance? P3 will get the chance because arrival time is here. It arrived previously. So that's why again P3 will get the chance. It will be 6. Now this is 0. And now at that time, who is remaining? P6, that is the lowest one. So P6 will get the chance. It will be 7 and now this is 0. And now out of that it is 6, 4 and this is 2. So now P5 will get the chance. P5 will get the chance And directly now you can execute till 9, because all whatever process queue was there, everyone already get the chance. Everyone for the first time get the chance. Now directly you can do, because ultimately this will complete. Because if you see that it is 2 remaining, it is 4, it is 6. So already I can directly do it. P5 will do till 9. After that P2 will get the chance, and P2 will do till 13. And after that P1 will get the chance. 12 will complete like till 19. And this is your SRTF, shortest remaining time fast. And after that, same way you will complete the completion time, turnaround time and burst time. And as we cut this, so that's why I am writing again the burst time. Original burst time was here 7, 5, 3, 1, 2, 0. That was my original burst time. And here now completion time. What is the completion time? Go from this side. P1 complete at 19. So put here 19. P3, P2 complete at 13. Put here 13. P5 complete at 9. So in P5 put 9. P6 completed at 7. So it is 7. Now again P3. So P3 is here. P3 is completed at 6. So put here 6. Here it is P3. So P3 already done. Here it is P4. P4 completed at 4. So put here 4. So our completion time is coming 19, 13, 6, 4, 9, 7. Now what will be the turnaround time? What is the turnaround time? Turnaround time will be my completion time minus arrival time. 19 minus 0. 19 minus 0 is 19. 13 minus 1, that is 12. Same way you have to do. That will be here 4, 1, 5 and 2. That is our turnaround. Next one is waiting time. Waiting time, turnaround time minus burst time. 19 minus 7, that is 12. 12 minus 5, that is 7. 4 minus 3, that is 1. And same way this will be 0. After that this will be 3 and this will be 1. Right? Yes. So here next one is, so here burst time was, sorry, here some again we did, that is the 1. Here this was burst time was not 0, that was 1. Right? So that's why 2 minus 1 is 1. Right? Now here what is the response time? See, as it is the primitive, now response time and waiting time will be different. Previously you saw in the FCFS, response time and waiting time was same. But here response time and waiting time will be different. Why? Because see, P1 get chance at 0. When P1 arrived at time 0. So 0 minus 0, we are doing here 0. P2 get first time chance at 1 and it arrive also 1. So 1 minus 1 is 0. P3 got chance first time at 2 p.m. It arrive also 2 p.m. So that's why it is again 0. P3 get chance, P3 already we did it, P3. P4 get the chance at 3 p.m. and arrive also 3 p.m. So it is also 0. P4 is done. So for the P4, after that P3, then again P3, then after that who get the chance here? P5 get the chance at 7. See that. First time when P5 get the chance, P5 get the chance here at 7 p.m. And when P5 arrive at 4 p.m. So what is the response time? First time I am getting chance at 7 p.m. and I arrive at 4 p.m. So my response time is 3. And finally for P6, P6 get the chance at 6 p.m. and it arrive at 5 p.m. So that's why response time is 1. Now you can see the waiting time and response time is not same. So response time is, I hope it is more clear now. Whenever CPU is getting chance for the first time, minus the arrival time. But waiting time is total time, how long you are there from the waiting time. That was the turnaround time minus arrival time minus the burst time. That was our waiting time, right? So our waiting time was turnaround time minus burst time. But the response time is when CPU, when the process get the chance first time, that is there minus the arrival time, that is called the response time. Got it? So I hope SRTF is clear to you now. Okay, so I hope everything is clear. Now we are going to the round robin algorithm. Here students are doing mistake most of the time, and after watching there it will be also very clear to you. Round robin. Round robin scheduling is what? Round robin is working on time quantum. Here is a time quantum. What is time quantum? It is fixing some amount of time that it is also a primitive. It is also a primitive version, but in SJF what it was going on, it was going on like that key every time whenever every unit of time we are checking how much remaining, but here we will check according to the time quantum. If your time quantum is finished, then you have to come. And here main thing is, here we have to maintain two. One is process queue and another is nurture. How to do it? See that. Here I am taking time quantum is 2. Okay, and I am taking an example. So from that example your round robin will be also clear. That is process number, after that arrival time. Sorry, mistake when writing. That is the arrival time. After that one is my first time. Okay, so this is my first. And here we will maintain 2q. How to maintain 2q? Here we are maintaining the process queue. One is process queue and another is the nurture. So process queue means what? Here I am writing first 104 and it was 215. Next one is 322. One is 4, 3 and 1. Next one is 5, 4 and 6. Next one is 6, 6 and 3. Okay. So from here, process queue means first one who arrived at the time. If I am going for the nurture, this is my nurture like this. Okay. This is our nurture. The nurture at the time 0. Who arrived? Only P1 arrived. So in the process queue also we are writing P1. Okay. So from P1 I will get only P1. Okay. And now P1 will execute maximum 2 quantum. Maximum 2 unit of time it can execute. So here burst time was 4. So it will execute till 2. And now it is 2 milliseconds is remaining. Now when it is coming out at 2 p.m. I am coming out 2 p.m. When it is coming out at that time, who arrived? Be careful here. When it is coming out, at that time who arrived, you have to check that. And let me a little bit making good it. I'm very sorry for handwriting. Very sorry for that. Little bit, but I hope your concept. So here, when I am coming out, 2 p.m. I am coming out. I did not complete my task. 2 p.m. I am coming out. At that time, who arrived? P2 and P3 arrived. So that's why in the process queue, I will write down P2, P1 already done. After that, P2, then P3. And now I did not complete my task. Till now, I need more 2. So that's why after that again you have to write P1. This is very important here. You have to understand this part very carefully. Very carefully. I am getting chance at arrival time 0. As my arrival time was 0, P1. So it get the chance. And it is executing 2 milliseconds. Your time quantum was 2 milliseconds. So it is executing. And when it is coming out, that is 2 p.m. Now time is 2 p.m. So now who arrived? Who arrived? Already P2 and P3 arrived. That's why write down here P2 and P3. And as P1 not completed, till now P1 needs. So that's why now write down P1. And now who will be the next? That next one you have to check from the process queue. Don't go for here. Here if you are going, then you will do the mistake. You have to check from the process queue. In process queue, who is there? P2 is there. I will give the chance to P2. P2 will execute more 2 milliseconds and its burst time is 5. And always checking the burst time. If it is like that, burst time is less than time quantum, then that is only. So if it is less than 2 milliseconds, then I will execute that much only. Necessarily, I will not take the time, right? So that's why always check the burst time. Here it is 5. Now it will execute more 2 milliseconds, that is 4. So here it will be remaining 3. Right? Now time is 4 p.m. Time is 4 p.m. At that time, who arrived? P2 already done this part. Always cross it. Otherwise, again you will do the mistake. So time is 4 p.m. At that time, who arrived? Already P4 arrived and P5 also arrived. Arrival time, check that. So write down here P4 and then P5. P4, P5. Now, till now, P3, P2 did not complete its tasks. P2 till now remaining. Then after that, write down P2. Clear? I hope this is clear to you. So P3, after that P1, then P4, then P5, then P2. Done. Now again, who will get the chance? Check the process queue. Who is there? P3. So P3 I will take here. Right? P3 will execute how long? P3 burst time is 2. So P3 will execute 2 milliseconds, means it is 6 now, and this is now 0. P3 completed its task. At that time, who arrived? At that time, only P6 arrived. So, write down here P6. And is it required to write P3 again here? Is it required to write P3 again here? No. Because P3 already completed its task. P3 required 2 milliseconds and it is already completed the task. So, that's why it is not required here. Now who will be my next one? My next one I will check from the process queue. No, not from here. I will check from here. P1. So I am taking this P1 here. P1 how long remaining? 2. So that's why P1 and time quantum is 2 also. So it will be 8. Now this is 0. Now this is 0. And finally, after that next one, who is the, so see that already my all the process are here. No one is remaining. Is it required to repeat P1? No, not required. because P1 already completed. Whenever it will be 0 means it is completed the task. So no need to repeat again, no need to write down again. Got it. Now here what it will be, after that who will come? P4. Take P4 here. Take P4 here. Whenever you are taking P4, then check that the burst time for P4 was only 1. Burst time for P4 was only 1. So it will execute till 9. Although the time quantum is 2. But I will not execute 2 because it is not required. I need only 1 millisecond. So my task is only 1. So I will do only 1. And after that it will be 0. Now is it required to P4 again? No, because P4 done its task. Problem. Now the next one is P5. P5 is getting the chance. When P5 got the chance, P5 remaining, it's required 6. But it cannot execute because time quantum is 2. So it will be till 11 it will execute, and here it will be remaining 4. Now P5 is remaining. So that's why here again write down P5 because P5 did not complete its task. Whenever I am not getting 0 means till now it is remaining. So that's why I have to write down again. Got it? Now who is the next one? Next one is P2. Take P2 here. Whenever you are taking P2, at that time check here. For the P2 it's required 3. But we cannot allocate 3. We can allocate maximum 2. So that's why P2 will be now 13. Here till now it is remaining 1. Till now it is remaining 1. So means I have to repeat again P2. Means write down P2 again here. Who is the next one? Next one is P6. Take the P6 here. Whenever you are taking P6, check that how much it required 3. I cannot allocate 3. I can allocate maximum 2. That is, it will be till 15 and still 1 remaining. Still 1 remaining. So means I have to repeat here again P6. Right? Now who is coming? Now P5. P5 came here. P5 is still now it is 4 remaining. I cannot allocate you 4. I have only 2. So that's why I can give you till 17. Till now it is 2 remaining. So that's why again you have to repeat here P5. After that who will come? P2. So I will give the chance to P2. When P2 is coming, now check. For the P2 it is only remaining 1. So it will be execute till 18 and now this is 0. It is executing till 18. Now this is 0. Okay. So after that, after P2, who is coming, and is it required to repeat P2 now? No, because P2 I got 0. No need to recoup. Now the P6. So again, here I am taking the P6 now. P6 is remaining only 1. Only 1. So I will give it till 19. Now P6 is coming 0. And finally P5. I will take the P5. P5 is now remaining 2. So that's why it will be 21. And that is now done. Now this is done. And I hope now it is very clear to you how to do the round robin, right? Now how to write down the completion time. As the space is not there, little bit space problem is here. So I am writing the completion time in this side. Okay, you can write in the same way, you can follow the same way. So as there is the space problem, so I am writing the completion time here. Okay, and please write the original burst time. Here whenever you are writing the burst time, write the original burst time 4, 5, 2, 1, 6, 3. Okay, so here what is the completion time? Completion time for P5 is 21. So P5 that is 21. P6 that is 19. And P2 that is 18. Then P5 that is 17.
P5 is already done. Sorry, P5 is already done. P6 is also done. P2 is also done. P5 is also done. You are getting here P4. So P4 is 9. P4 is 9. After that P1. P1 is 8. So P1 is 8. Then P3. P3 is 6. So put here 6. Now everything is done. See that. So your completion time is 8, and after that 8, 8, 18, 6, 9 and 21 and 19. In that way you have to cover the completion time. Okay. Now I am going to the next page. I think now how to put the completion time, that is very clear. So to do the next calculation of the turnaround time and waiting time, I am writing in the next page. Okay, just write down the completion time from here. How to check? Here P5 was 21, P6 was 19, after that P2 was 18, then P5, P6 already done, P2 already done, P5 already done, P4 is 9, P1 is 8, here P3 is 6. In that way we put this value, right? It is very clear. Now I am going to the next page and I am writing again so that you can check your calculation. So here it was like that. Your arrival time, process number was here. That is okay. The process number, arrival time, first time, completion time, turnaround time, and waiting time. So 1, 0, 4, 2, 1, 5, 3, 2, 2, 4, 3, 1, then 5, 4, 6, and 6, 6, 3. Okay. Yes, this was the 0, 1, 2, 3, 4, 6. It was 4, 5, 2, 1, 6, 3. So your completion time was coming from here, that we did here 8, 18, 6, 9, 21, 19. That is I am writing here. So that was 8, 18, then 6, then 9, then 21 and 19. So turnaround time will be again the completion time minus waiting time. Completion time is this, waiting arrival time, completion time minus arrival time. So that is 8 minus 8 is 0, 18 minus 1 is 17, 6 minus 2 is 4, 9 minus 3 that is 6, 21 minus 4 that will be 17, and here 19 minus 3 that will be 19 minus 6 that is 13. So here total will be your 65, and waiting time, turnaround time minus burst time, 8 minus 4 that is 4, 17 minus 5 that will be 12, and here 4 minus 2 that is 2, 6 minus 1 that is 5, 17 minus 6 that is 11, 13 minus 3 that will be here 10. So that is your turnaround time, and waiting time it will be 44. 8, 17, 4, 6, 17, 13, 4, 12, 2, 5, 11, 10. So here this is 40. So average turnaround time is 65 divided by 6, that is 10.83, and average waiting time will be 44 divided by 6, that is 7.3, right? And your task is to do the response time. What will be the response time here? What you have to check, how you have to check? To check the response time, as to check the completion time, we are going from this side. To check the response time, you have to go from this side. When CPU is getting, when process is getting the first time chance, was 0 minus arrival time. For this P2, P2 get the chance as 2. So this one minus the arrival time. What is the arrival time? P3 getting the chance 4. 4 minus when the arrival time. In that way you have to do the response time, just like the same way how we did here, the response time. Same way, go from this side and check that first time when I am getting chance and what was my arrival time. That way you can cover the response time also. And I hope all the algorithm is very clear to you and you are watching till now. And if you are watching till now, then please let me know in the comment section that yes, your concept is totally clear or not. And this is your last minute revision, that where the starvation is going on. Starvation is there in STF, LTF, means shortest job first, longest job first, shortest remaining time first. Everywhere the starvation is there for the priority algorithm. The priority algorithm, there is starvation. Who is shortest, he will get the chance. If I am longest, I will not get the chance. That's why it is called the starvation. No starvation in round robin, because we are distributing to everyone. Everyone is getting the chance. So that's why there is no starvation. Convey effect. Convey effect is FCFS. Convey means when fast come fast up. So if first time it is coming a big process and I want a very small amount of time, but because of this convoy I am not able to go. Because of this convoy, just like that when Prime Minister is coming, because of this Prime Minister convoy we are waiting in the road. If we have to go to office, then also we are not able to go. Maybe office is very less distance, that is also we are not able to go. That is called the convoy effect. Next one is the most suitable algorithm for the real time. In real time we are using the preemptive priority scheduling, preemption method. And most suitable algorithm for the time sharing, that we just now saw, the round robin algorithm. See that first of all, what are the phases of software engineering, and every phases I am dividing into different parts. These are the different model of software engineering. After that, what are the actual part of the software engineering models that I am going to discuss. Next, that is after under the software design, there is coupling and cohesion. This topic also I will discuss clearly. Under coupling and cohesion, what are the different types of cohesion, what are the different types of coupling, that I am going to discuss. Next one is what is SCM, that is software configuration management, how it is going on. What is verification, what is validation, what is testing, what is debugging. After that, all types of testing, how it is going on, unit testing and integration testing, system testing. What is verification, what is validation, everything we are going to discuss. Black box testing, white box testing, software maintenance, different types of maintenance, corrective, adaptive, perfective, preventive. Each and every type of maintenance I am going to discuss. Re-engineering and reverse engineering. What is the difference between re-engineering and reverse engineering? I will discuss clearly, and you can see all are my handwritten notes here. After that, we will discuss the CMM level also. And finally, I will end the video here. So now you can understand so many topics I am going to cover in this video. So please watch this video till the end and definitely subscribe to the channel. Click the bell icon to get all the latest update and notification. Don't skip it, don't pause it. You have to understand each and every point clearly. Then only you can attempt the question. And I will suggest you try to play this video repetitively multiple times, so that like a story you can remember software engineering. It is my guarantee that if you will watch this video at least 4 to 5 times, if you will listen this video like a story also when you are doing other work, then also you will be very much confident about each and every topic, because ultimately you are learning with someone who have 5 years industry experience and 2 years teaching experience with UGC NET qualification. So now start it.
In the software engineering, what are the phases? First of all, why we are learning software engineering and what are the parts are there. When you can do the mind mapping, then it is very easy to understand and then it is very easy to remember. So first part is analysis. Analysis means it is the requirement analysis. What is the requirement? It can be the requirement of what are the specification, what are the feature customer is asking. So that are the feature what I am going to do. Next analysis can be that how many team members are required, like how many developers are required, how many database engineers are required, how many designers are required. That is also a analysis. And after that, the time analysis, what is the total time, that is also required. Then the cost analysis, what will be the cost. So these are the very important analysis in the analysis phase. After that, we are coming to the design phase. In the design phase, what we are going, because design is very important. Whenever you are trying to build a house, then designing is a very important part. How, what will be my planning of the house? So in the same way, whenever you are trying to develop a software, then software design is also very important. In the design part, we are doing the database design, like DBMS database, how the DBMS database design will be. Next one is that use case diagram, like there are so many UML diagram, use case diagram, activity diagram, sequence diagram, and ER diagram also there. This all the diagram we are doing so that how it will actually work. After designing, now your designing part is done. After design, we are going to come to the implementation, means ultimately now coder is coding it. But it is a very less time comparatively to the very total life cycle of a project. Implementation part is a very less time. After the implementation, it is coming to the tester team. So remember one thing, implementation is doing by the coder. And when coder is checking that the program is running successfully or not, that is called the debugging. That is a very important concept. Most of the time, students are getting confused with debugging and testing. So debugging means when you are writing a code and you are checking it that it is working correctly, and after that again you are fixing it. That is doing by the coder. That is called the debugging. And whenever it is coming to the tester, so tester don't know, maybe tester don't know how it is coded. So tester is testing that the functionalities are working fine or not. So there are two types of main testing, that is black box testing and white box testing. In the black box testing, they are providing the input and they are getting the output. Is the output is correct, fine or not? In the white box testing, they are testing through the code. Okay. So we will learn all types of testing. Don't worry. Next one is the release. So after doing everything, yes, now your uh, project is stable. Now your some part of the version is stable. So now you are sending it to the client, means it is called the release. So after releasing, main part is that is 70% of the project life cycle is the maintenance part. And it is the most earning part of every companies, because ultimately maybe 1 year, 2 year you are developing a project, but after developing, when it is running in original environment, then the maintenance part is very important. So then we are doing the maintenance part. At the time of maintenance part, there are different types of maintenance: adaptive maintenance, corrective maintenance, perfective maintenance, preventive maintenance. What are those maintenance that we will learn? So now come to the next part, that is when you are developing, that as per the project criteria, different types of models are there. What type of project you are going to build, in that situation you will take the decision, yes, I can go for the model. These models are telling you, if you are following this model, then it will be easy to implement your software. So there are mainly focuses, what are the question coming? Waterfall model, prototype model, incremental and iterative model, spiral model, and nowadays it is very popular, that is agile model. So waterfall model means it is very easy and very small project, like when nowadays no companies are using that. But when you are doing a school project, small project, then we are going for the waterfall model. Mainly how the waterfall model working, it is just like a waterfall. What is telling by the waterfall? Of before ending one phase, here you see the different types of phases, right? So before ending analysis, I cannot start design. Before ending design, I cannot start implementation. Before ending implementation, I cannot start testing. That's why this is called a waterfall model. Before ending of a project, before ending of a part, you cannot start the next part. That's why this is called the waterfall model. And you cannot back also. That if you have already started the design part, then you cannot go to the implementation part. If you have already started the development part, then you cannot go to the design again. Okay. Next one is the prototype. When we are using prototype model is using when customer is not able to explain you what type of project he want. Means the requirement is not clear to us. Like that, anyone is telling you, I want to make a house, but he is not able to explain you how the house will looks like. Then the engineers are showing them that there are different types of model of the house, maybe from the images or some models. Then from the model he is choosing, yes, this design is very good, so I will go for this design. And after that, maybe with that design as per his purpose, he is doing some changes. This is called the prototype model. So for the software also, when customer is not able to explain what type of project he wants to build, then software developer are showing a dummy. It is not complete version. They are showing a dummy, and by watching the dummy, now customer is able to understand, customer can able to explain it, yes, this is my exact purpose. Then we are started building the project. That's why it is called the prototype. Next one is incremental and iterative. So incremental and iterative means what? Maybe your project is a big project. Maybe it will take 1 year. So it is not possible that I will start now and after 1 year I will release to the customer. It is very risky, because maybe if there is any problem in understanding the project, if there is any problem in requirement gathering, then it can be a blunder that maybe customer told you that yes, I want a bicycle, and you make a motorcycle. After that, customer told you, no, my purpose was bicycle, you made a motorcycle, I am not going to take that. So it will be a blunder. So that's why companies are going for the incremental and iterative model, because when they are doing the incremental model or the iterative model, then they are dividing the project into small part. Maybe there is a total project, they are dividing some module wise or some month wise, time wise. Module wise means when it is parallelly, they are dividing the project. This part will be done by the team 1, this part will be done by the team 2, this part will be done by the team 3, and this part will be done by the team 4. And everyone is doing parallelly, and whatever feature is done, it will deliver to the customer. Or maybe it can be like that ki a total team is working together, and some part of the project, it is a big feature, the project is dividing into some small parts. So one feature I will develop, that is feature 1, it will be sent to the customer. Customer feedback will be taken, yes, it is correct or not. Then we will go for the next feature. Or it can be also possible that one feature is taking more time. So 50% of the feature we will do, the basic model we will do, and after that we will send to the customer. Customer will tell, yes, this is okay, now I want to add this, or maybe I want to change this. So then we will do the remaining 50%. This is the main concept of incremental or the iterative model. There is the difference between increment and iterative. So if you are interested, then I will upload the video. What is the main difference between incremental and iterative? So let me know in the comment section. Next one is spiral. So spiral is main focus of the spiral is the risk management. Here the main focus is the risk management. In other model, risk management, risk analysis was not there. In every phases, it is going like a spiral, one by one phases, incrementally it is going on. But the new feature is added here, that is risk analysis. It is not done in other model till now. So that is the main advantage of the spiral model. Remember that, the risk analysis. Next one is the agile. So what is agile? Agile is the combination of iterative and incremental model. And the main focus of the agile is, what are the main focus? The small medium size project it is doing and rapidly changes. That is the main focus. The rapidly changes. It is customer can do anytime any changes. Maybe you have done something for last 1 month, then customer is asking, no, I want to change there. So you have to be that much flexible. That much flexibility is required so that anytime any changes can be done. And that's why your project structure, your coding structure should be very much efficient. All the team members should be also very much efficient. And each and every project is dividing in a sprint. And each and every sprint will be maximum 3 weeks, maximum, right? So that is the main feature of the agile. And in my channel, I am giving you the link in the top. For the agile methodology, detailed discussion is also there, and for all other SDLC model also detailed discussion I have already done. You can watch the recording. So this is the total analysis of waterfall, prototype, incremental, spiral and agile, and it is your quick revision chart also. Next one is evolutionary model, is also a type of prototype model only. Okay, this is a type of prototype model only. Don't be confused with the evolutionary model. It is a part of prototype model and we are using it, not clear. Waterfall model, that is we already discussed. Rapid application model, that is RAD. RAD we are using when there is minimal flavor of rapid prototype, functionally equivalent component of the product. So maybe some product you have done that is functionally equivalent, then we are going for the RAD. And rational unified process, that is dividing the development process into 4 distinct phases. It is dividing into 4 distinct phases, that is business model, analysis, design and implementation. So these are all the models from where questions are coming. If detailed analysis is required, you can refer to my videos of detailed analysis. And what are the videos are not available? Let me know in the comment section. I will upload that videos in detail. Now come to the design. So in the design part, when you are doing the design, then you have to, in your mind, it is very carefully you have to handle that when I am dividing the project, it is a total project, right? The total project is a big project. Now in my team, there is 10 team member. Okay. So I will divide the total project into 10 part so that I can give the responsibility, I can share the responsibility to each and every team member. Now, whenever you are sharing the responsibility to each team member, module 1 for team member 1, module 2 for team member 2, module 3 for team member 3, in that way, then it should be like that. If between the modules, like module 1 will be not that much dependent on module 2 or module 3. Between the module, there should not be that much dependency. Like you and your neighbor, that much dependency should not be there. Rather than More important is how much you are related with your family member, how much bonding is there with your own family member. That is more important, right? So that's why cohesion. What is cohesion? Cohesion means inside the module, what are the features are very much related, that all the features together you will take in one module, and what are the features are different, there is no relation, you will separate it into the other module. And at the time of dividing the module, you have to, it is very important to keep in your mind. That's why we are telling that high cohesion means inside the model, inside in a model, the elements should be very much related. The bonding is very much important. But one model to another model, one module to another module, coupling should be low. Means it is not possible that there is no dependency, because some dependency will be there, as ultimately you are going to be integrate all the module and it is a total sequence, and ultimately it is going to be a project. That's why it is not possible that there will be no relation. There will be some relation that we cannot avoid, but as much as possible try to lose it, try to lose it. That's why we are telling high cohesion and low coupling. Now we are going to do the different types of cohesion and different types of coupling. And this higher to lower is very important, which one is best and which one is worst. So 7 types of cohesions are there. Functional cohesion, sequential cohesion. Functional cohesion is the best. That is number 1. Next one is sequential. Next one is communicational. Next one is procedural, temporal, logical, and coincidental. So first of all, functional. Functional means what is that see that I have already marked the main line. Both perform one action as a team. Means when the all the some element, like I am taking an example like registration and login. Registration and login are very much related, right? When you will register in a website, then after that only you have to log in, and all the data of the register is ultimately you are using that username and password for the login. So registration and login is very much related. So that's why maybe you can combine these two features together. That is called the functional. Both perform one action as a team. This is functional. Functionally, they are related. Next one is sequential. Sequential means what? That output of one serves as a input to another and so on. So sequential. So you are trying to purchase a product. So you will add to cart. So add to cart is a feature. After that you are trying to payment. So after add to cart, what are the product you add to cart, that is a element, and then finally that is only sending that these are the order is placed, now the payment is required. So now it is going to the payment. So it is a sequence, right? So add to cart, after that you have to do the payment. This is a sequence. They are related sequentially. Next one is communicational cohesion. Communication means say that it contributes the activities that they use the same data. Maybe account number is the same data. So account number of a customer is used by everyone, but mainly when any customer is trying to withdraw money, so money withdrawal, or maybe he want to um, add some money in the account. So these are two other distinct functionality, but withdraw and add money that are using same account number, that's why they are related. They are using the same data, that is called the communicational cohesion. Next one is the procedural cohesion. Procedural cohesion is that different work but related by sequence, but activities are unrelated. Here very important. Here this is very important. Students are getting confused with the procedural and sequential. See that here it was one element, input and output. See that one element serves as input to another. I will add to cart, then this will be the input in the payment. That was the sequence. That's why it was the number 2. But here this is not that much good, because here they are not related. They are the different work. They are not related, but they are related as a sequence. How? That add and edit functionality, read or write functionality. Someone is added. Someone adds something. Maybe I add my profile. Maybe I add my profile image. After that, I am editing the profile image. So these are totally different two things, but they are related as per the sequence. I am uploading now this image, and I will upload, I will edit that image, another image. So these two images are different totally, and these two functionalities are different totally. No need to combine together, but still we are combining. That is called the procedural. Next one is the temporal. Temporal is related to time. This is not at all good. That same time you are doing the work, that's why you are combining in one module. That is not at all good. So they are related to time only. There is no functionality relation, there is no input relation, output relation, no sequence relation. Still you are putting in one module, for as there is timely related. That's why temporal is not that much good. They are related to the time. Logical is when logically categorized. When it is logically categorized, you are categorizing like the same logic are there as per your coding. When you are doing the coding, as there are same logic is using, that's why you are putting in same module. That is not at all good. And last one is the coincidental. Actually there is nothing. Actually there is no relation, nothing. Coincidentally, randomly you are putting. It is totally unplanned. It is totally unplanned, or randomly you are putting some functionalities in same module. That's why it is the worst one. So coincidental is the worst one. That's why remember the sequence. First one was functional, sequential, communicational, procedural, temporal, logical, and coincidental. This sequence is very important. Next one is coupling. Coupling means between two module. Between two module. This is module 1, this is module 2. Till now we was using that in a same module when you are adding the elements. Now what will be the relation between two module? So here eliminating unnecessary relationship, you have to eliminate. Reducing the number of necessary relationship, if there is necessary relationship, then also as much as possible reduce it. And erasing not easing, means a little bit easy. Tightness, so how much tightness is there, try to make it more easy for the necessary relationship. This is the target of the low coupling. We have to be low coupling. So low coupling, that's why the data coupling is the best one. Data coupling, why? Because model interact with each other by passing the data. Whenever some user is login, so after login, the user ID will be passed to the profile only, nothing else. So it is a coupling, data coupling. No relation, only I will pass the user ID to the profile, nothing else. So it is good one. Profile is a different module and login is a different module. So from the login module, I am sending only the user ID to the profile. So it is a good one. Now no other relationship is there. Stamp means they are using the same data structure. Maybe and same array is utilized by when they are creating a session. So when someone is registering, then after that it is creating an array of session. Maybe I am also using that same array, you are also using the same array. So model 1 and model 2 using the same array, same data structure. That is called the stamp. Next one is control coupling. Control means same flag. There is some flag value. I am also using like status. Status is a fact. So my status is on or off. That is using by two module. I am also using that same, another also using that same. So status they are using, that is a flag. So it is a third one, that is control coupling. You are controlling with the same flag. Next one is common coupling. Common coupling means they are using the common global data. These are the main point, guys. That's why I have underlined the point. Please remember the main point and you can write down in your quick revision note also. Common coupling means they are using the global data. Content coupling. What is content coupling? Content coupling means here it is very bad, and don't be confused with the data coupling and content coupling. Data coupling is best one. It is passing only a data. But content is the worst one because it is directly accessing the data. If your neighbor is coming to your home and he or she can access all your data in your home, it is not good. You are giving access to another one. That is not good. So if any other module can change your data, that is called the content. You are giving the access directly, another one can access or modify your data. That is not at all good. That's why it is called the content coupling. So that's why I have written also, don't be confused with the data coupling and content coupling. Okay, data coupling is passing the data, but content coupling is doing that, it is referencing it, right? It is changing your data. So now coupling is done. So cohesion and coupling we have done. I hope still now you are watching. Please write down in the comments so that I can understand. Yes, still now I am watching. I am here in the SCM. We have done coupling and cohesion. Please write down. It will be good for me also for understanding. Yes, students are watching. So now do that. Key software engineering, SCM. SCM. How the SCM is working? Try to understand that. So SCM means when we are doing a project, multiple team member is working, right? Team member 1, team member 2, team member 3, everyone is working. Now, always it is a purpose that maybe I am also working in same page, you are also working in same page. Now, how we can work? That's why in the companies there are a global server, means it is a company server, and in that server all the updated codes are there. And in our local machine, these are the all the local machine of each and every team member. And in between there is the SCM. In between there is the SCM. What they are doing? Whenever they are coming to the company, they are coming to the office at morning, they will update the data, current final data to their machine, and they will do their work. After working their work, then they will again update it to the server before going to the home. Now, maybe I was also working in a same page, you was also working in the same page. I want to update now. So I have updated my things. There was no problem. I went to my home. Now, after 10 minutes, you are trying to update it. Now, what will be the problem? As I have already updated, so if you will replace the page again, then my data will be lost, right? That's why at the time of update, what you have to do whenever you have to update it, you have to check the current version. Means maybe 10 minutes ago another one is updated, right? So you are checking the current version, and the current version is showing you there are some new lines and there is maybe some conflict. Whatever line, maybe line number 52 you also work and I also work in line number 52. Then manually you have to check if whatever I have done and whatever you have done, then you have to merge it together. After merging, ultimately your work will be not lost, my work will be not lost. Then you will update it. That is called the SCM, and SCM is a technique. Mainly example of SCM is Git. GitHub, you all know. Parallelly, all the person can work together. So version control is a big task of a SCM, and we are using the SVN also example of SCM. Okay, so now here there is version, release and variant. What is version, what is release, what is variant? Here it is actually maintaining by the SCM also, and this is very important. Version means there is the different that maybe 1 week ago something we have done and now we have done something, there is some differ, there is some changes. So instance of the system differ some way, some changes are there. That's why it is called version 1.0. Next one is version 1.1. Right? Release. What is release? Release is that it is the instance what is distributed to the customer. That is a release. And what is variant? Variant means actually functionality is same. Variant of the car. When the car is going to the coming to the market, there are different variant they are releasing, right? Actual, these are the same model, same functionality, but some changes are there. That is the functionality identically other than the instance, but designed better hardware or the software. That's why it is called the variant. So what is version, release and variant? Remember that question are coming from here also. So next one is validation, verification, testing and debugging. Already I have discussed the testing and debugging. Testing is done by the tester. Debugging is done by the coder, and debugging means cause of the defect and fixing it. And testing means demonstrating it and providing the confidence that there is no error. And what is validation and verification? It is very important. Verification is the first one, then we are going to the validation. Okay. So are we building a product right? Means it is ensuring that whatever specification is there, are you doing the product, how the process you are following, that process is okay. How you are writing the code, that process is okay. Means rightly you are building the product. That is called the verification. You are verifying. The software implements specification. Validation means are we build the product right? Means right product. It is a correct one after building. It is before. It is before. First we are doing verification, then we are doing validation. After doing the product, is it correct product? That is called the validation. So here now come to the point of testing. What are the testing? Testing is the combination of verification and validation. So there are different types of testing: unit testing, integration testing, validation testing and system testing. And it is a I have drawn in that way so that you can understand. Unit testing is focus on the code. After that, integration testing is focus on the design. Then validation testing is focus on the requirement, and system testing is focus on the system engineering. Okay. So unit testing means small module. Everyone is doing all the I have done my module, then it is tested. That is unit testing. Integration means when combining all the modules, 3 to 4 module, 5 module done. Now they are combining all the module. After combining all the module, again it is tested. That is called the integration testing. And now the total project is done, total product is done. Then you are going to validate it. That is called the validation. The product is right. Customer asks you to make a bicycle. Is it a bicycle or it is a scooter or you have done a bike? That is the validation. And finally, your product is tested. Now you are uploading into the environment, system, the server. Now it is working fine. That is called the system testing. So here I have written also the verification and validation. So are we building the product rightly? And here are we building the right product? It is meeting the business requirement and it is meeting the user requirement of the customer expectation. Does not involve executing code. Human based checking is there for the document and file. And here always executing the code, because ultimately you are checking all the purpose is correct or not, that is always it is doing. And always remember verification. First we are doing verification, then we are doing validation. Verification when you are doing your work, at that time you are checking. Validation after product is done, that is called the validation. Now come to the different types of testing level. It is a quick revision chart for you. Unit testing, integration testing, and the system testing. So unit testing is already I have done. Integration testing also I told. System testing also I told. Here these are the part of different testing. Top down, bottom up, regression and smoke testing is under integration testing. Under system testing, there is recovery system, security, portability, performance. And under performance, there are load testing and stress testing also. So this is a quick revision chart for you. Now, testing approaches are dividing into two ways. One is functional testing, another is implementational. Functional means behavioral testing. That is called black box testing. Under black box testing, there is equivalence class partitioning, boundary value analysis, acceptance testing, cause and effect testing, pairwise analysis, and state-based testing. And white box, statement coverage, branch coverage, and path coverage. And already the videos is there for the statement coverage, branch coverage, path coverage. I am giving the link in the top. You can see in the I button. Must watch that. It is very important part. And other than that, the software engineering playlist is also there. You can watch the playlist also. And after that also, if you are facing any issue, if you want some videos from me, then definitely let me know. And what is alpha testing and beta testing? Alpha testing means it is inside the organization before releasing to the market. When it is checking inside the organization, that is called the alpha testing. And beta testing means it is released for a limited number of customer, and the customer is checking the version, and after that they are providing the feedback. It is called the beta version, means real time environment the testing is going, and it is by the user. That is called the beta testing. Now come to the software maintenance. So we are coming to the next part, that is software maintenance. So please write in the comment section, yes ma'am, till now I am watching, and now we are doing software maintenance. We have done the software testing. So in detail, if you want to learn the software testing, then let me know in the comment section, so that I will upload a specific video for software testing only, different types of testing. Now see here the maintenance. What is maintenance? What is the main target of the maintenance? It's not just fixing a software. Here after development, no major changes is allowed here. Unavoidable broad activity means there are some, what is I cannot avoid, we have to maintain it. There is water is not coming to your home, so you have to call the plumber and you have to fix it. That is unavoidable situation, right? So some unavoidable situation can be there that you have to control for the maintenance. Error detection, some small error can be there that you can do, detect and correct it. Enhance of capabilities, they are your capability means 100 user are coming, then working is fine. When the 1000 user is coming, then it is not working fine. So capability also have to be. Deletion of obsolete capabilities. What capabilities are not working now, it is not required, that we can delete. And optimizing means time. More optimized query you have to write, so that it is taking more time. Maybe when the load is more, stress is more, then it is taking more time, so we have to optimize it. These are the main purpose of the maintenance. And what is maintenance? That become old and unstable because of changes in the platform or operating system, then we practice the maintenance to improve the stability and quality of the performance. That is called software maintenance. Now there are different types of maintenance, and these are very important. Questions are coming from here: corrective maintenance, adaptive maintenance, perfective maintenance, and preventive maintenance. So corrective maintenance means what? Corrective maintenance means we are doing only correction, defect, initiated by the defect. Here is some defect like bug fixing you are doing, that is called the corrective maintenance, means fixing, defect, corrective. Adaptive means new platform. Remember that adaptive means ever changing environment. It is related to the new platform, new environment. That is called the adaptive maintenance. And keep software up to date. This is the main purpose, and the keyword of adaptive maintenance is new platform or new environment. Remember that. Next one is perfective. Here most of the time students are getting confused with perfective and adaptive. Perfective means here I want to be more perfect. That's why I am trying to add some new feature. I am trying to record my video in different ways so that you will be more happy to watch that video, right? So it is called the perfective. Day by day improving ourselves by including new feature, or the new user requirement. I am asking you what type of video you want from me. That is the new user requirement and new feature. That is called the perfective. So usable over the long period of time. That's why we are going for the perfective maintenance. Next one is preventive. Preventive means in future maybe some problem can be happen. That's why now we are taking the precaution. That is, prevention is better than cure. So that is the prevention. Nowadays we are taking more prevention so that we can protect ourselves. Same thing when you are doing for the software, that is called the preventive maintenance. So now all 4 types of maintenance is done. Write down in the comment, yes, maintenance is also done. Now come to the software re-engineering and reverse engineering. What is re-engineering? What is reverse engineering? Why we are doing the re-engineering? Notes is already there. You can go through it. Just I am telling you what is there. Re-engineering means that when it is a old project, legacy system means it is a old project. Now you are trying to re-implementing it. It is not a new project. Remember that it is not the new project. No new functionalities are there. Maybe you have built a software previously in C. Now you want to change it in Java. Then we are doing the re-engineering. Now the problem is there. Maybe 5 years ago you have done the project in C. Now after 5 years you want to do it in Java. Now client is telling you I want to do it in Java. Client don't have any documentation, any requirement, any design in their hand. Now the problem is that how you can do. They are telling it is my project, I want to rebuild it, I want to re-implement it. So what you have to do, that's why we have to do the reverse engineering. Re-engineering means reverse engineering plus forward engineering. Why we are doing reverse engineering? Reverse engineering is that detecting from the existing software. You have only the existing software, you don't know anything. So for a time, maybe for 5 days or 10 days, you will only visit the software. You will try to understand the software, what is going on. So that is called the reverse engineering. That is deciding what the re-engineering, source code translation or everything means. You are trying to understand. So from the old project, from the existing software, now you are trying to understand the design of the software, requirement of the software. That's why it is called the reverse engineering. Normal engineering was first we are doing requirement, then design, then development, then complete product. Now you are doing from a complete product, you are trying to understand the design, you are trying to understand the planning and requirement. That's why it is called reverse. You are going in reverse direction. That's why it is called reverse engineering. So after doing the reverse engineering, now you know the requirement. Now you know the design. Now you can restructure it. Now you can do the code, restructure it. Then you will do the forward engineering, you will write the code and everything, then you will deliver it, the re-engineered product to the customer. It is called the software re-engineering, and that's why re-engineering is reverse engineering plus forward engineering. Now finally, this is the last slide of this class, and I hope till now you are watching. And last one is CMM 5 level. CMM level. What are the level? This is nothing else. These are the company's level. Company's level means like CMM level 1, 2, 3, 4, 5. Don't cram it. No need to cram it. What is that? Initial. Initial R means new companies. What are the currently just startup companies that are called the initial. So when they are startup companies, they are not thinking about anything. They are just trying to understand what are going on in the market. So process is unpredictable. You cannot predict the process, and poorly controlled. It is not that much control because they are new companies. Managed. Now the level 2, managed means it is categorized the project. This type of project, it is focusing on the project more, because if I can do a project properly, then I can do this same type of project multiple times. That's why it is focusing on the project management more. Level 3, in the next level, it is called the defined. Now they are focusing on the process definition, process characterization. That is called the defined. Next one is level 4, that is qualitative managed. Okay. So level 4 is here. Now process is also there, quality is also there. That is level 4. Level 5 is optimized. Now level 5 companies are totally optimized. They are focusing on the project quality also, process quality also, team quality also, how the project is going on, each and everything they are thinking about that, because they are now the higher level company. That is called the level 5 companies. And this is all about the CMM, all everything whatever we have done. Yes, it was the question of 2022 UGC NET. There was 3 questions from software requirement. Yes, this was the 3 question. To understand this 3 question, you have to understand what is requirement engineering process. Actually, requirement engineering process means whenever a client is coming to build a software, they are giving that, yes, this is my requirement, I want to do that. So some of the person from the company, they have to take the requirement properly, and they have to define it, documenting it and maintaining it. Because ultimately, if the requirement is clear, then only your development will be correct. Otherwise, your development will be not correct. And what are the main activity done here? That is the requirement elicitation, requirement specification, requirement verification and validation, and requirement management. These are the main activities. So what is requirement elicitation? Requirement elicitation means to gain the knowledge about the project domain. Means in which domain customer wants to do work. And knowledge include the customer, business manuals and existing software of the same type. Means when customer is coming, yes, I want to build a website for maybe tour or travel. So they will say that, yes, there is a website like that, so I want to build like that, like Make My Trip. Maybe they can refer that, yes, Make My Trip, I want that website like a Make My Trip. So means you will get the idea, okay, we have to build like this way. And after that, how requirement you will gather? Through interview, brainstorming, task analysis, Delphi technique and prototyping. These are the technique under requirement elicitation. Next one is requirement specification. Yes, after getting the requirement, you need to specify it from the customer, so that will be in a technical manner, right? Software requirement model means through which model it will be good, because for each and every software we cannot go for each and every model. There are different types of model, as you know. There is waterfall model, spiral model, nowadays agile philosophy model is there. So which model we should choose? It should be according to project criteria. After that, all requirement including the functional and the non-functional requirement also, that we need to learn in detail, because question was there from this area, right? And there is the during the specification, you have to understand that if there are any problem during specification, if some area more knowledge is required, then you can ask again the customer. And after that, we will go for the stage of design stage, that is the yard diagram, data flow diagram, and DFD. All this area it will come next. Now, requirement verification and validation. What is verification? What is validation? This is also coming in this part, and this is also very important point. So what is verification? Verification means it's refer the set of tasks that ensure that software correctly implemented as per the specification. Customer told you that yes, I want to build the tour and travel management software, and this should be my flow, and you are doing it correctly. That is called verification. You are verifying each and every time all the functionality and everything. That is verification. What is validation? Validation is actually after completion of the product, you need to verify, you need to validate it. Yes, as per the customer requirement, whatever I built, is it correct? It refers a different set of tasks and ensure that the software has been built is traceable to the customer requirement. Means customer requirement was travel and tour management, and I did travel and tour management. It's not like that customer asked you to travel and tour management and you did a hospital management. That is a validation. So here these are the some main steps. It should be consistent, it should be complete, and it should be practically achievable also. Next thing is, these are the some undercoming requirement management. You can pause the video and you can read this document as per your requirement. These are very important theories. I am not going in theories because sometimes students are getting bored. So those who are interested, you can go to this. So that's why now we can see the process: gather the software requirement from the client, analyze and document, is known as what? Definitely now answer is easy. Yes, answer is requirement so engineering process. After learning the concept only, your answer will be easy. Next thing, a good software requirement specification does not have the characteristics. So for that, again you need to learn the concept. And here also, here cost effective process, then SRS is called what? Is it verifiable, traceable, modifiable or complete? For that also, let's learn the concept. So under the software requirement specification, these are the need of SRS. Why? That it helps the team to save the time, and it's means it will be actually when SRS is correct, then next part means designing part, development part, it will be easy. They will read the document and according to that they will do their work. So for the team it will be very easy. So what are the characteristics of a good SRS? Correctness, completeness, consistency, unambiguous, and ranking for the importance of stability, modifiability, verifiability, traceability, design independence, testability, understandable by the customer, and right level of abstraction. These are the main quality of a good SRS. And now you can answer this question. Yes, The good software requirement does not specify which one: completeness, consistency, clarity or reliability. Yes, the answer will be reliability, because in this list you can see reliability was not there. Yes, reliability you can get ultimately after doing the project. You did 3 to 4 times you did project and your performance is fine, then only you will be reliable to the other customer, right? So reliability is not the part of SRS. Next one, it was asking every requirement checked by the cost effective, the SRS is called. So for that you need to understand the term, what is the meaning. So yes, here you can see the correctness. Correctness means it should be cover all the requirement that are actually expected. Means whatever customer told, we should write it correctly and that should be there. Completeness, every sense of completion, numbering of all the pages, and functional and non-functional requirement, everything should be there properly. Means your SRS should be complete. Consistency, consistency is very important. There should not be any conflict. Maybe in page number 10 you have written something and in page number 20 you have written something, and that are creating a conflict. It should not be like that. So here next one, unambiguous. Unambiguous means your whatever you are writing, that should be in easy and the interpretation should be only one interpretation. I am writing something, when one of my friend reading that, he is getting some knowledge, it is interpreting in one way and another one is interpreting in another way. That is called a ambiguity. So your sentence should be in a simple sentence and that should be one interpretation should be there from your sentence. That is called unambiguous. And ranking for importance and stability means your means there will be less or more important. Where it is more important, where is less important, that ranking should be there. According to the requirement, these are the high priority requirement. These are the less priority requirement. In that way, actually, we should prepare. Modifiability. Yes, if required, then maybe it can be modifiable also. Easily accepting the change to the system. That part should be there also. Next one, verifiability. Yes, verifiability. That's why the verification is there, right? So SRS should be verifiable in a technique of quantifiability, like measure the extent to which every requirement is met by the customer, met by the system. Means whenever developer are doing that, yes, this part is done, this part is done, this part is done. In that way it should be verifiable. Each and every point wise it should be there. Traceable. Trace a requirement to design the component. Means your requirement should be like that, so that they can divide in per module and they can design as per component wise or segment wise. That is called the traceability. Design independence. Choose from multiple design alternatives. Your SRS should be like that, so that it can give the designer, means those who are doing the design. Designer means not the UI designer. Designer means who will design the software, means what will be the ER diagram, how the DFD diagram. They can get the alternative chance also. That is called the design independence. Testability. Yes, your SRS should be testable. Understandable by the customer. It should be in easy language. Right level of abstraction. Right level of abstraction means SRS is written for the requirement phase and detail should be explained in, means there are different level. First we will write down all the level. After that, means these are my requirement. 1 to 10 requirements are there. After that we are explaining it another one. So for a feasibility study, fewer details will be there also. That is called the right level of abstraction. Now you can see, if every requirement can be checked by cost effective process, then the SRS is called what? Then the SRS is called verifiable. So is it cost effective or not when you are verifying it? That is called verifiable. So answer is verifiable. Now let's learn some related topic also. Yes, here are some related topic. These are classification of software requirement. There are functional, non-functional and domain requirement. Three types of requirements are there. These are called the functional requirement. You can pause the video and you can learn. Next one, these are the non-functional requirement. The portability, security, maintainability, reliability, scalability, performance, reusability and flexibility. These are coming under non-functional requirement. The points are very important. Day by day question pattern is changing, and that's why I have prepared these notes for you and must go through it. Next one, these are the non-functional requirement. In detail you can learn domain requirement also. Next three question was from software metric. Yes. Which of the following is indirect measure of product? So for that you need to understand the metric also. So now let's learn the metric. So what is software measurement? Software measurement means what is the size, quantity, amount of the software, that is called the software measurement. What are the principles of software measurement? Formulation, collection, analysis, interpretation and feedback. These are coming under the principle of software measurement. Now there are classification two types. One is direct measurement, another is indirect measurement. Direct means actually what you can measure mathematically. Means it can be measurable mathematically, like LOC, line of code. You can count the line of code. Execution speed, according to time you can measure it. Memory size, what are the total memory size it's required, that is also countable. Defect per reporting time period, each and every day or each and every month how much defect is coming, that is also countable. That is called direct measurement. Indirect measurement means these are coming under quality. It is not quantity, it is coming under quality, which you cannot count mathematically or you cannot write mathematically. These are the qualitative. So ultimately functionality, quality, complexity, efficiency, reliability and maintainability, these are coming under indirect measurement. So your answer will be, which of the following is indirect measurement? You can see, yes, quality, complexity, reliability, these all are actually indirect measurement. So I hope you can understand it. Now you can see which of the metric derived from the normalized quality of the productivity measure and the size of the software has been produced. That is actually function point metric, because we did it. There are function point metric, LOC, line of code, and the COCOMO, size oriented metric. So function oriented metric is not there, and it is given, read the question very carefully. Which metric are derived by normalizing quality and or productivity measures by considering the size of the software that has been produced. So line of code is counting the number of line. And why it is not size oriented metrics? Because there is nothing like size oriented metric. There are three type of metric we are normally doing: line of code, function point and COCOMO. That is the COCOMO model. So here it will be function point metric. Now size and complexity are the part of which metric? Size and complexity. So size and complexity means it is the part of product metrics, because size and complexity is coming under product. It is not under people, project or process. So answer will be this one. You can understand that in UGC NET 2022 how they ask question. So here is the detail of metric. You can see this is what is metric. Actually metric is the measurement level, and here these are the software metric, that is planning, organizing, controlling and improving. What are the four functions related to here? And here are the characteristics of software metric. It should be quantitative, understandable, applicability, reliability, repeatable, and the economical, and it should be language independent also. This is here use product metric, process metric and project metric. What is called product, what is called process and what is called project. So product means product metric are used to evaluate the state, tracing risk. Process metric means this is actually how you are doing the project, that pay the particular attention enhancing the long term process for the team or organization, how they will do the project. And project metrics means project metric describe the project characteristics and execution process, that is coming under project metrics. So here are number of software developers, staffing pattern, and from software design, that is this question, that module X and Y operates same input output, then which type of cohesion it is. There are different types of cohesion. These are the 7 types of cohesion. I am giving my handwritten note here because with the handwritten note it will be easy for you. Functional, sequential, communicational, procedural, temporal, logical, coincidential. Functional means both performing one action at a time. That is called functional and it is the best one. Always you have to remember the cohesion in sequence, cohesion and coupling. Sequential means output of one element serve as a input of another one. That is called sequential. Communicational means elements contribute to activities that use the same data input or output, like a customer account number. Procedural means they are doing different work but related by the sequence and activities. They are doing different work but related by the sequence. How? Like add and edit. Temporal is related to time. They are doing in same time. Both component are doing in a same time. That is the temporal. Logical means when logically they are related. Means these two components are doing with same logic. Coincidental means actually it is the lowest degree and there is no proper definition. Means anytime you are putting any one. That is called coincidental. So here as it was given, module X and Y operate on same input and output. Same input and output, as you see here, that was communicational. Same data input or output, that is the communicational cohesion. So answer will be communicational cohesion. An exact point I have written here and you can understand it. It will be good for you. Next one are 2 question was from SDLC model. That was very easy question. First question was the model in which the requirement are implemented by its category. Evaluationary model, waterfall model, prototype model, iterative model. Waterfall model is actually which model? When you are starting means each and every steps of SDLC, if you are not completing then you cannot start, and that was actually the means school project, college project is doing by that. Nowadays anyone is not following. Prototype model means when customer is not able to explain it properly, then we are showing a dummy model, and after that customer will change something, and after that when customer is able to, yes it is my thing, then we are going for the original one. That is prototype model. Iterative model means we will not do that complete one. We will do the part of the software and we will send it to customer. Each and every part iteratively, step by step we are doing. Means total complete software we are dividing into some small parts, and every iteration we are doing and we are sending it. So definitely this any one is not the answer. Here it is by category, implemented by category wise. That is actually the evolutionary development model. And here it is the notes for you. What are the different types of model, how it is focusing. You can pause it and you can learn it, or you can take a screenshot also. So here your answer will be evolutionary development model. RAD software model, what is the full form? That is rapid application development. Actually RAD is focusing on parallel work.
means they are dividing into some team 1, team 2, team 3. When we are using, when a big project you need to do in a small time, like normally it will take 1 year time, but you have to complete it in 3 months. So now you will divide the total project into 4 parts so that parallelly every team can do it, and after that you will combine it and you can deliver it into 3 months. That is actually the main focus of RAD model, Rapid Application Development. So there was 2 questions on testing. That was also easy question. Alpha beta testing, you all know. Yes, we did it also previously. Alpha beta testing is coming under acceptance testing. For testing in this channel already video is there for software engineering. In software engineering detailed video, rapid revision video, all are there. That's why I am not going here again. Fault based testing, is it unit testing, beta testing, stress testing or mutation testing? Unit testing means we are doing each and every module wise testing. One module completed, one unit completed, that is unit testing. Beta testing is actually acceptance testing. Stress testing means when there are lots of stress is coming to the system, then is it performing well or not, that is called stress testing. So by elimination only you can do the answer, it is mutation testing. And what is actually mutation testing? This is a type of software testing which certain statement source code are changed or mutated to check if the test case able to find the error in the source code. That is called the mutation testing. So the global mutation testing ensure the quality of the test cases and robustness for, that is the fail or the mutated source code. And that's why your answer is mutation testing. These are the question of 2021. And first question was from the clean room approach, where most of the students got stuck. As per the review of the mock test, whatever I saw, most of the students got stuck here. And that's why you need to understand the clean room approach very carefully. What is clean room approach? Clean room approach is that approach like you have a room and you want to see that the room will be always clean. So what we will do? For that you have to regularly follow some ritual or some manner, that every day I will do the dusting, every day I will check it, mopping and cleaning every day, that it should be my regular activity so that my room will be always clean. That is the same thing we are doing in software engineering also. In software engineering we are trying to avoid the defect. It is the avoiding technique, that is the prevention technique, so that there will be no defect. And that's why it is using the formal method of development and rigorous inspection process to assure that there will be zero defect in software. The objective and the approach is of the software development is zero defect software. That is prevention and avoidance technique. This is the main point. Please write down on your notebook. And there are 5 strategies, 5 key strategies are that for the clean room approach. From clean room approach, not only in 2021, there was 4 to 5 times they asked question on clean room approach. So here you can see the formal specification. First of all, formal specification means the specification have to be correct, otherwise your work will be wrong. Incremental development. If I am giving you lots of pressure per day, then definitely you will do mistake. But if I am telling you that small part daily you can do and incrementally you can update yourself, then your mistake will be less. And that is the focus, incremental development. Structured programming. Proper framework, proper structure of the coding whenever we are maintaining, then it is more clear and chance of the defect will be also less. Next thing is the static verification. After writing the code, static verification, as a human being you can go through the each and every line, so that static verification will be also done. And the statistical technique, statistical testing means statistically with the data we should do the testing parallelly so that we can assure there will be no defect.
These are the 5 key strategies for the clean room approach. Now, if you come to the question, now it will be very clear to you. Yes, the clean room software process model incorporates the statistical quality clarification of the code increments as they accumulate into the system. Yes, it is following the incremental, so it is true. Statement 2 is clean room software engineering follows the classic analysis, design, code, test and debug cycle to software development and focusing on defect removal rather than defect prevention. Here is the problem. It is not focusing on defect removal rather than defect prevention. It is the defect prevention technique. It is not focusing on removal. It is the defect prevention technique, and that's why this will be false and this will be true, and your answer will be yes, statement 1 is true and statement 2 is false. Now come to the next, the MVC, V component of MVC. So for that you need to understand the MVC. What is MVC? See here, MVC is the framework that is called Model View Controller Framework. Yes, software engineer, when they are doing their work, it's not like that anywhere I will write SQL, anywhere I will write the server side scripting, server side code like Java, C, normally nowadays everyone is using Java. So like Java programming also, anywhere I will write HTML, CSS. It is not like that. Normally we should follow a framework. The user part, that is the view part, HTML part, CSS part, JavaScript part, that will be separate. That is called the view. Model means where we are writing the business logic. That is called the model part. And controller is there as a bridge between model and view. Means model is doing business logic. It is trying to for the business logic. It will call the database. From the database it will fetch the get data, and after that it will send it to the view, means HTML. In between, controller will work. Controller will take the data, and after that it will frame it properly and it will send it to the view. Again view will call to the controller, controller will call the model, and again this way the work will be done. So controller routes the command to the model and view part. It is working as a bridge between view and model. So you can see here model, this is view, and this is controller. So controller is two-way. You can see manipulates in the model and sometimes update directly in the view also. User send the input here, and after that model send the update in the view also. So view part, what is the V? V is the view part, that is the user interface. So answer will be user interface. Now next question was there from SCM, software configuration management. So for that again you need to understand the software configuration management clearly, and it is also very important topic. 4 to 5 times they ask software SCM topic questions came. So here you can see what is SCM. SCM is one type of software, like example GitHub, SVN. These are using so that parallelly the team member can work. Because normally what is happening in a software company, you are also working in same page, another one is also working in same page. Maybe you are working in the part of HTML, another one is working in the part of business logic, another one is working in the part of database. Now at the end of the day every work should be combined. It should not be like that ki I am working means you will stop your work. So that's why SCM is giving a in between, means it is working in between of server and client. Means here will be a server, that is the original server of the client, and here will be the local server, and from the local server everyone, each and every team member is working here in their machine independently. So every day when they are coming to work, then they will download it, they will update it in their local machine, and after that they will do work independently. Then at the end of the day, they are trying to merge their work through SVN or through the SCM. SVN is an example of SCM. So through the SCM, that is software configuration management. Then SCM will help to show that yes, where are the changes, everyone did it. It will merge all the code there, and if there is any conflict, it will show that there will be conflict. You will verify it, you will check it, and after that ultimately all the team member will combine the code and they will upload it. This is the main purpose of SCM, and SCM is helping us to prevent lots of things that you can see. SCM using for build management, process management, teamwork, and mainly here the DevOps, here for the cloud computing and DevOps also, this process of SCM we are using. So that's why here the question, whenever this question is more easy, that in the SCM whenever you are committing it, then what are the part you should commit. Definitely I will commit my code file, whatever I have written I need to commit it. Documentation file means whenever I am writing a code, there are two types of documentation you can do. In the code you are doing comment that is this line I am writing for this, or maybe you are working in a module, you will prepare a separate document and you need to update it, you need to upload it, so that another team member can understand, okay, what are the changes you did it and why you did it. So that's why documentation file also need to be updated. Output file definitely no need to update, because output file you will check the output locally, and whenever you will run in server it will also automatically create it, so no need to upload. Automatically generated file, like some temporary file it is generating, that is also no need to upload. Why I will upload that temporary file, auto generated file? Whenever it will be executed in the server, it will be automatically created again. So that's why these are also not required. Only code file and documentation file are required. Although here question was easy, but still I provide you the question on SCM so that you can understand the SCM, and I will provide the topic wise question also in mock test, and you have to do it. Next one is coming under capability maturity model. So that is called the CMM, capability maturity model. It is also easy question. They ask the order of the capability maturity model. So for that, let's learn this one also. So capability maturity model is that actually what is the capability of the software company. The organization is providing the label, it is CMM level 1 company, level 2 company, level 3 company, according to the capability of the company. These are called the level. So initial, first level is initial level, means these are the new companies, startup companies, those who are work as a ad hoc basis. Whatever work they are getting, they are starting their work. There is no proper definition, there is no proper target, nothing. It is just focusing on I need a work, so I will do everything. That is the startup companies. Next one is the repeatable company. Repeatable means after the startup, some of the project they did it correctly, and now they are doing the same type of project. Like hospital management. So hospital management they did it correctly, and that's why one hospital they did it, and now they are doing for different hospitals same type of project. That is called the repeatable level. Next level, now after the repetitive work for 1 year or 2 years, they came to understand that this way they cannot stay in the market. They need to perform well for a long run. So that's why they need some training program for the developer also, peer review also, inter-group coordination also. Means now they are focusing on the improvement of the group properly, improvement of the process also properly. That's why they are focusing in this area: peer review, inter-group coordination, organization process definition, organization process focus, and the training program. So proper defined structure they are coming to say. This is called the level 3. After that they are coming to managed. Managed means now after getting coming to a proper defined level, now they are focusing on qualitative and quantitative management. because yes, now we are doing work, now we have to focus in quality and quantity also. That's why they are focusing in quality and quantitative management, that is called the managed level. And finally the company came to the level 5, that is called the optimizing level, when they are ready for the defect prevention. Just now we learned that one defect prevention technique, that is the clean room approach. So they are focusing on defect prevention, process change management. For last year you are following a process, now as per the market you have to change the process also, you have to change the technology also, so that you can get a optimized output, optimized result. So these are the companies, are the high level companies, highest level companies, that is CMM level 5 companies. They are called the optimized or the optimizing level. So these are the 5 level of CMM level, and according to that definitely answer will be this. Now next one is, in the software testing, beta testing is the testing performed by what? So for that, those who did it, that is correct. Those who are doing mistake, you need to understand what is the difference between alpha testing and beta testing. Yesterday also there was the question. So these are actually the acceptance testing. After completion of the development, means your software is ready now. Now we need to think about the market will accept it properly or not. And that's why alpha testing is done by the developer in the developer end, in the developer house, means in software company only. They will check that product acceptance levels, means how happy the customer is by using this software. But customer will not check it, it will be checked by the developer only in that development house, means in that software company only. Beta testing, after doing alpha testing, when developer are thinking yes, we are satisfied enough, this is a good software, now it will be given to that means it's some limited version they will put into the market, like you are getting some beta software. So that the real time environment, customer can use it, client can use it, and after that they can put the feedback how they are feeling, or if there are any problem then they can do it. So ultimately real time user, customer, clients, they are doing this type of testing. Sometimes they don't know also they are doing testing, because we are sometimes downloading the beta version, after that we are using it without knowing that yes, this is also a part of testing. So ultimately we are doing it in our home, that is we are the real time user, we are using it in our home, in our own area, that is called the beta testing. So that's why here is the difference between alpha testing and beta testing. And you can see the answer will be definitely potential customer at their own location. This question was very interesting question. They provide potential location, developer location, that is actually the alpha. Potential customer at developer, no, customer are not coming to developer location. You will not go to Google, you will not go to Microsoft Office, right? Product developer at their customer, product developer are never coming to customer location. Product developer own location, that is actually the alpha testing. So answer will be this one. Next one is, in software engineering, what kind of notation do formal method of predominantly use? What type of notation we are using predominantly? Computer code, diagrammatic, mathematical, or textual? Answer will be here mathematical, because predominantly means mostly we are using what type? That is mathematical. Because when you are doing the LOC, AP, COCOMO, project estimation, anytime we are using mostly mathematics, and that's why your answer will be mathematical. Next question was from the exhaustive testing. So here was the assertion and reason, and here most of the students are doing mistake in assertion reason, and that's why here I will tell you how to do the assertion reason properly. Very carefully understand it, not only for this question, in paper 1, paper 2, everywhere lots of assertion reason question are coming,
and students are doing mistake here. Is it a correct explanation or it is not a correct explanation? Here only students are doing mistake. That's why understand it. First of all, what is the concept here? And before concept, I will tell you how to do the assertion reason. First of all, for assertion and reason, you need to think separately. This is statement 1, this is statement 2. You need to ask yourself, if I am thinking that statement 1 is a independent statement, according to that, is it true? And if I am independently thinking that statement 2 is a independent statement, is it true? So if both are true, yes, statement 1 is also true, statement 2 is also true. When you find out that yes, both are true, then come to the conclusion that yes, is it a correct explanation or not. To get that, you have to ask in assertion, whatever is given, you have to ask yourself why. Because the reason should be here. Whatever the assertion is telling, the reason should be here. And after reading the reason, you have to understand, am I getting the correct answer why here? Am I getting a satisfying answer that yes, is it supporting this assertion? If it is supporting, then it is correct explanation, otherwise not. So this is the way how you have to understand assertion and reason. Now come to the exhaustive test. Exhaustive test is actually the all possible combination. When you need to do all possible input, like if you are giving a password, your password is taking any 3 character. If it is taking any 3 character, now how many characters are there? Total A to Z. This much character are there. So total 26 letters are there. So now how many combination I have to check for that? Permutation. How many permutation will be there? 26 multiply into 26 multiply into 26. This much permutation can be there for only 3 input. And as per exhaustive testing, you need to check all this. So that is a very much difficult task, right? And that's why you can see here the assertion was the software developer do not do the exhaustive software testing in practice. Yes, it is not possible because that much all types of permutation, all types of input I cannot check. It's not possible because even for the small input, exhaustive testing is taking the computationally intensive very long, because you saw here for only 3 character I need to check that much input. So that is practically supporting this assertion, and both are true, and it is the correct explanation of assertion.
Yes,
Yes, finally it's completed. Thank you for watching. Those who are watching till now, I hope you got that total explanation and everything is done. Best wishes for your exam. After coming back from exam, definitely let me know in the comment section how was your exam. Share this video to all of your friends and like, share, subscribe. Stay tuned with me. Bye bye.